Natural language processing is the branch of computer science, and more specifically the branch of artificial intelligence or AI concerned with giving computers the ability to understand the text and spoken words in much the same way human beings can. In this tutorial, you will start from the absolute basic of NLP and then proceed forward semantic segmentation, focusing on learning how to build a recommendation engine and build a chatbot using the widely used programming language Python. If this interests you, then fasten your seatbelt as you are going to dive deeper into the world of artificial intelligence. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.
So let's have a look at what is natural language processing, a proper description for this particular technique. So NLP stands for natural language processing, which is basically used to understand and interpret human language to the machine. In short, it is the automatic way to manipulate the natural language like speech and the text by software for further analysis to get the required information from them. Yes, this stands for natural language processing. Now we will have a look at what are the examples of natural language processing. What are the field where we are currently using NLP. So we use NLP for predictive text. We know about Gmail, right? Suppose you are writing a mail and it will automatically give you the prediction what will be your next words, right? How they can do that. So this is doing by the natural language processing technique. Now email filters. Suppose your email is a spam email or it's an important email. How Gmail do that? Yes, for this also they are using natural language processing. Now comes data analysis and language translation. What is language translation? Suppose you don't know the particular language we know, right? Suppose we were talking about, if you don't know Bengali or Hindi, you only understand English. In that case, what you can do, you can use Google Lens to understand basically what language, like what is written in this particular language, it will convert it to English. How they do that? Again, by doing that, they have to use natural language processing. We will see this is really interesting part of NLP. You can do really cool stuffs using NLP, right? And last but not the least, smart assistants. When we talk about Siri or Google Assistants or Amazon Alexa, and there are a lot more we use as a smart assistants. How they understand our language, how they understand what we are talking to them. Yes, by using NLP, they understand what actually you want to mean by, right? Yes, this is the most used example we can say for natural language processing. So yes, this is more interesting technique, and you will learn lots of things. How can you actually make your own smart assistants using NLP as well, right? So let's move forward. What else we have? Let's have a look at. Now we will see what is the roadmap to learn natural language processing. So in that case, you can see what you have. You first need to do data pre-processing, and from there you have to do modeling techniques. But under data pre-processing, there are few ways to do that. What are those ways to do that? You have to do tokenization. Then you have to do stop word removal. We will see how actually we can do the tokenization. What is tokenization stands for. Then we will see stop words removal. Then we will see stemming and limitization. So these are the basics way to do your data pre-processing, and we will do all of these things in this particular course. After that, if we talk about the modeling techniques, what are the modeling techniques we have? We have bag of words, TFIDF, word embedding, and sentiment analysis. And sentiment analysis is one of the best way to understand your customer sentiment. We will do a project on that as well, right? So yeah, these are the type of data pre-processing we will work on, and also the modeling techniques of bag of words, TFIDF, word embedding, and sentiment analysis we will work on. Let's move further. Now we will see how to implement Python or how to use these techniques. So basically, to use these techniques and to implement these techniques, you need a language. But what language should we use? We will use Python. And now we will see why do we use Python. As I have said, we will see why should we use Python and why we choose language as a Python. We will talk about that. So let's move further and let's have a look at what are the technologies, rather what are the features we have in Python, right? So what is Python? Python is a popular high-level object-oriented and interpreted language. Now, when we say it's high-level, object-oriented and interpreted, what actually I want to mean by? Suppose you are someone who has good idea about English and you really don't know how to write a program, right? You don't know what is syntaxes, you don't know how to, write your first program. Then also I can suggest you can start with Python. Why? Because Python does not have any syntax, but yes, you have to maintain the indentation, right? We will talk about that. What is indentation? But for the other language, you really need to know lots of syntaxes. And if we talk about what is syntaxes, suppose we are talking about in a human language, right? So in a human language, one thing we need, that is grammar. You don't understand a particular sentence if the words are, placed without any manner, without maintaining any grammar. Will you understand what this sentence actually want to mean by? Suppose you are saying, hey, I am going somewhere, right? It, we are using grammar for that. But suppose you were just suddenly saying, going, we are somewhere, right? Can you understand that the words are actually there in the sentence but without any proper maintaining grammar? Can you do that? No, you cannot do that. You will not understand what this particular sentence is talking about. Yes, to understand a sentence, you need to have a good understanding of grammar. In this case of programming language, you also need to have a good grammatical understanding. What is that grammar for a programming language? This grammar is nothing but your syntaxes. Your computer will understand the particular command if you properly put the syntax. Where it comes for Python, you just need to maintain the proper indentation to make your compiler understand what you have written in your program, right? Yes, Python is very easy to start with. Now, if we look into the benefits of Python, I will give you a short introductory part of what are the benefits you will get if you start learning Python. Suppose you are from somewhere you want to make your own web page, right? If you want to use Python, the best option for you is Python. Why? Because Python has lots of frameworks to work with, right? And second, the length of the program. The first and foremost thing when we think about a programmer, the first thing comes into our mind that programmer must have working with the thousands lines of code, and that should be very difficult, right? Yes, they do work with lots of lines of codes, but when it comes to Python, it really makes your life easy. Let me give you a quick example of that. Suppose you are writing Hello World. When you are writing a Hello World program in Java, C, C++, at least you have to write 3 to 4 lines of code. In the case of Python, you just need to write 1 line of code. You can understand how easy it is to work with, right? Now comes the Python is simple and beginner friendly. Yes, I have already mentioned, if you are someone who has no idea about the programming language, then also Python is for you. Now we will see the mathematical computational can be done easily. How actually we can do a computation easily using Python. Yes, Python has lots of libraries. We will look into that. Lots of library makes your life easy. Already this particular mathematical function are implemented in these libraries. So you just need to call the function and your work is done to work with, right? This is why Python is one of the most used language these days. Now, last but not the least, graphical user interface. If you are a gamer, if you want to make your own game, and also if you want to make your own GUI, Python is for you. Again, Python has lots of options to work with, right? So you actually understand what are the benefits we have in Python, and I will show you how actually it's making your life easy with the lots of library, right? So yeah, this is why we have choose Python over any other language. Now we will have a look at what are the important libraries we have in Python. The first library, that is NumPy, which stands for numerical Python, to solve your numerical problems. If you have lots of numerical problems and if you want a library which can actually make your life easy, then this is NumPy. Then you have pandas. Then comes, as we have said, we need to do lots of data pre-processing. How can you do that? Are you really thinking to do these things by writing each and everything in your code? No, because pandas has lots of functions to make your life easy while it comes to data pre-processing, right? So pandas is known as one of the most used tool for data pre-processing. Suppose if you want to look at your data and if you want to see how your data looks like, then Matplotlib and cbot is the best choice for you. Now comes NLTK and Spacey. So we are going to use this two particular library and talk about that, how we are going to do that, right? For your natural language processing techniques to basically implement them, right? So yeah, this is the what are the most important libraries we have in Python. In this part, we are going to talk about the data pre-processing. What are the steps you have to follow to do your data pre-processing? So let's get started with that. First, we will have a look at what is data, the basic thing you have to know before start with the data pre-processing. So basically, data is a bunch of raw information which operations will be performed, right? Yes, it's a raw information you have, and using those raw information, you have to make a proper report out of it. That is known as data. Now, if we move further, we will see how you can start working with types of document you have, and that is how can you read those documents using Python, and how can you actually manipulate those document using Python. So basically we work with different types of document in Python. So most of the time we use PDF version or text file version or CSV version. What is CSV? Comma separated file, right? So now, basically CSV stands for comma separated values. So now we will see how can you actually read a PDF file using Python and text file using Python and also CSV file using Python. So let's get and started with Python. So here we are going to use Google Colab, and Google Colab is basically, let me give you a short intro of Google Colab. If you just write Google Colab, right? So what you will get, so basically it is by Google for the AI researcher. If you are someone who is aspirant for artificial intelligence, so this platform is for you. You don't need to install anything. You just write Google Colab, and from here if you just click on this new notebook sign, so you will get start with this particular new notebook. So in this particular new notebook, what you will get, there are few features given by Google for the AI researcher. Suppose you don't have a good, computer to work with, but if you want to work with the natural language processing, I will show you when we are going to work with the long data type and large data type, it's going to take a long time, right? So when your data set is large, so basically that time you need to have a good computational power. So if you do not have a good computational powers, PC or laptop, then also you can make your work done. How? By using Google Colab. Because if you go to runtime and if you just try to change your runtime type, you can see you have GPU and TPU. So TPU stands for Tensor Processing Unit and GPU for Graphics Processing Unit, right? So yes, you can have this two type of runtime using Google Colab, right? For this time, we are not going to use any one of them because we are not going to use any huge data set to work with, right? Yes, so you can see this is the whole scenario of Google Colab, and these are the code cells you have, and if you want to put text, you can put using this, just click on that and you can write whatever text you want to add, any note you want to add, and also you can share your code with anyone by clicking on share, right? So basically it makes our life easy, the Google Colab. It's a basic intro of Google Colab, right? And yeah, this is how you can share. Now if we go back to that, we have made our notebook for like natural language processing for this. So what we are going to do, first we are going to read a PDF file using Python, then we will talk about the text file, and then we will talk about the comma separated value file, which is CSV file. So you can see already we have few files over here. So if you want to actually import few files to your Google Colab, you can see there is an option for upload to session storage. So one thing you have to keep in your mind, that whatever the thing you are going to upload in Google Colab, that will be removed after 12 hours, right? So whatever work you have done Do not forget to save that. Now if you just click over here, you can actually redirect to your local system, and anything if you want to upload from there, you can easily do that, right? So you can see we have ready data.csv file, we have demo file.txt, and we have a PDF file for Python, right? So how to do that? We are going to install pypdf2. This is a library in Python if you want to read PDF file, right? So if you do that, after that, what do you need to do? Let me make it a little big. What do you need to do? You have to import it, right? So you have done the import pypdf2, right? Let me do the rest part. So now if I just copy and paste whatever I had, so now I have to import pypdf2. You can see what I have done. I have imported pypdf2. Now in the variable called data, what I have done, I have called the open method, and on that I have written what? The path of my file, right? So we are creating the PDF file object. Now in this you can see we are again assigning one variable called reader, and we have said pypdf2.pd file reader. We are trying to read the file what we have already storing data variable, right? So you can see creating a PDF reader object. This is our PDF file object. It is PDF reader object, right? Now what we are going to do, printing number of the pages in the PDF file. What are the total number of pages you have in PDF file? To get that, you have to use .numPages function, right? You can see I have 52 pages in my PDF, and it is like actually read by the library, and I am sure that I have this much pages in my PDF. So you can actually load the PDF file using Python, and you can start working with the PDF file in Python very easily, the way we have done. Now if we come further, so if I just do one thing, right, creating a page object. Now if I want to make pages, what are the pages we have, right? If I want to do that, okay, so what to do that? I need to call a function called .getPage. Now if we see page.extract text, the first page we have, for that the page of what we have, that is installation and data structure, right? So the first page text we have, that is Python installation and data structure, and this is how you can read each and every file or each and every page in your PDF file, right? Now as we had here for 0, right? Now I want to go for page 2, right? So let's have a look at what we have. Now if I do the same thing, okay, I'm getting an error. Okay, it's saying it's a closed file. Okay, right, let me do that once again. Right, after that I want to get the page 2. Right, let's see. Introduction to Python I have in my page 2. Now if I go to page 1, let's see what I have. Okay, so I think I am making the data close. That's why this. So one thing you have to keep in your mind, whatever you are working with that data, do not close it until you know you are going to really close this file. You don't need this file anymore, right? So why we do that? Because do not want to waste our memory, right? So it's like you can see, can you see we had the agenda, and now we have these things in our PDF file. The page calls one page, right? The page started with 0. The first page we have, that is agenda, and this is, you can see, introduction to Python and the installing Anaconda. These are the things we have in our PDF file, right? So now if you want to close the data, so what is closing the data? You are closing the file. You are saying we don't need the file anymore. It will close the file. It will not take the memory from your compiler, right? Yes, so this is how we have read the PDF file. We have load the PDF file using Python. Now if we come down and if you want to check how to do the text file, in this case again we are going to use the open function, and there we are going to give the path for our demo file.txt. If you see what we have, this is one I have made, right? What we have, hello, welcome to Great Learning, right? Let me make it big. So this is the one I have in my demo file.txt. Now let's see if I read it, what I will get. So here if you see that text data.read, you can directly read the text file. So you get hello Welcome to Great Learning, what we have in our text file. So using text file and reading text file using Python is really easy. Now if we start working with CSV, as we have talked about few libraries in Python like NumPy and Pandas, you don't need to NumPy for this, you need Pandas for this, because to read the CSV file we need to get a function called .readCSV function, which comes from Pandas. Right, that's why we have written pd.readCSV and the path for that. Now I will show you how will you actually get the path. Just click over here the data you have uploaded, and if you click over here, right, the three dots you have, there is an option called copy path. Right, you can easily copy the path of your data, copy path, and if you just copy paste it over here, right? Can you see? This is one you get. Now if I just execute this, and if you just write data.head, we will talk about this. What is data.head and what are all these things? For now being, you can understand this is a data frame we have, which actually takes all the data from the CSV file and store into the variable called data. And if you just write .head, you will get the first 5 rows of your data. You can see basically it easily actually loaded, right? Yes, so this is how we do our CSV file reading, right? So let's see what we have in next. Now we will see what is data pre-processing. So data pre-processing is a way to develop informative data from raw data by removing noise and unwanted attributes. So what actually want to mean by removing noise and unwanted attributes? I will let you know when we are going to do the demo on that, right? So let's have a look at what are the types of data pre-processing we have. We have remove or fill null values. Right, I will show you how can you remove the null value if you have in your data set. After that, count the unique values in the column. Yes, I will show you if you have null value, then you can see, okay, I can remove the null value. But if you have redundant value, you need to focus on that, how much value you have that is unique, which are not repeated. Right, after that, drop the irrelevant columns. Suppose you are working with the data set where you need to find the price, right? And you know there is a option for your customer's passion, right? So your customer passion column is not related to the sale or the price of your product. So you can easily drop that, right? So we will do this pre-processing to make your data perfect for the whatever the modeling, whatever techniques we are going to work with, right? So let's move further and let's have a look at what are the types of data processing we have. The first type of data pre-processing, that is removing null values, which are known as imputation techniques. So remove or fill the null values in the data to get appropriate informative data, right? So let's have a look at how to do that. So here you can see I have already given the example, that is you have the raw data and you have the converted data. So in the sentence columns you have a lot of NaN values, right? And in the converted data you can see we have actually used them in sentence 1, or we will see in the demo how we can remove them, right? So let's get started with the demo. Again, we are going to use the same data set what we have actually used in this, that is ready data.csv. Now, if you want to check what are the columns you have in your data, how to do that? You can use the dot columns function, which will actually give you what are the data you have, what are the columns you have in your data set. So you have clean comment category. This two you have in your data set. Now, if you want to check the shape of your data, what are the shape you have in your data? That time you need to give dot shape function. Now, what shape it's going to return? What are the columns you have? Like basically how many columns you have and how many rows you have in your data set, right? So here you can see you have total 37249 rows and 2 columns, right? Now, if you want to go for the data.describe are basically used to understand total count of your data, few statistical terminology about your data like mean, standard deviation, interquartile range for your data, right? So these are the things we use for, we get basically using dot describe method, right? Now comes the null value. How can you check them? So if you use dot is null, basically dot is null function used to check do you have any null value. If you have any null value, please give me the sum of that. So why? Because for each and every column and rows, I don't want to check do you have null value or not, because it's going to return me on boolean like true or false. I don't want to look into that. I just want to understand what are the total null value we have in our data set, right? So if I just execute that, you can see for the column called clean comment, we have 100, right? We have 100 null values. Now, if you don't want to have a summation of that, if you just want to check, do we have any null value for any column? That time you can easily use data.isNull function, then .any. It will give you the boolean. If you have any null value, it will show you true for that particular column. So you can see for clean comment, we really have null value. That's why it's given true. For category, we do not have. That's why it's false. Now, how to actually solve the problem? What you can do, we have taken a new variable called data part, and we have said data part equals to data.dropInA. So what dropInA does? DropInA basically drop all the null values. Now, if you say, hey, I want to see for dropInA, right? If you just say, hey, for this after using dropInA, let me check my data. If you just write data underscore part, you will get all the data. Now, as I said, we don't have any null value. If you want to recheck it, how can you do that? You can just write data part dot is null dot sum, right? So basically it will give you if you have any null value after using drop in a function or not. Can you see you do not have any null value? That's why you get clean comment equals to 0 null value you have, and category also you have 0 null value. So one option is you can drop the null value, otherwise you can replace it with mean value or anything you want, right? So this is how we actually check our data has the null value or not. We have removed the null value problem. Now, if we go back to the presentation and if we move further, so we have done this, that removing null values or imputing data, and also checking the count of the unique data, right? Now, if I just go again and I just want to check that remove all the unnecessary column. So as I said that we just want to understand that removing unnecessary column. So we are trying to predict the cells. There is no point of having a column for the hobbies for your customers. So in this case, what we can see, we can remove the unnecessary column. So yes, this is also the part of data pre-processing, right? So yes, these are the basic data pre-processing you need to look into whenever you are going to work with any technique, right? If it's going for machine learning or data science or artificial intelligence or NLP, right? You need to look into these things for the very basic parts of your data. In this particular part, we are going to talk about what is tokenization. As we know, this is the part of data pre-processing. So let's have a look at what is the actual meaning of tokenization and how can we actually implement them using Python. So basically, tokenization is a method is used to split phrase, sentence, paragraph, or an entire text document into smaller units. By doing that, we can get the individual words or terms. We will see how we can do that. Each of these smaller units are called as tokens, right? So this is what tokenization stands for. And to do the analysis of our human language, to understand our language in a proper way, we have to do the tokenization. It's a very basic part after you do the basic data pre-processing, like removing null values or removing the irrelevant columns for your data, and how can you deal with the null values. After doing all these things, you have to go for tokenizing your data set. How you can use the tokenization. So tokenization is meaning, from the name itself you can understand, tokenize your whole data set with each and every tokens, right? So now we have done, we have seen that what is tokenization. Now we will see why do we need tokenization. The most basic part of natural language processing, it helps to interpret the meaning of the text by analyzing the words present in the text. Count the number of words in the text. Yes, if you want to count the total number of words you have in your text, suppose the example we have, this is a cake. In a tokenization form, after you have performed, you will get this is a cake. So each and every word will be your token. The total number of count of word you will have, that is 4. And this is how we did the tokenization. Now we will see how can we implement tokenization using Python. So here also we are going to use Google Collab to do the line tokenization. So there are two types of tokenization. We are going to show you what we are going to do for implementing tokenization in Python. So to do that, we are going to import the library that is known as import NLTK. So we are going to use NLTK, the library we know that is used for natural language processing. So we have written import NLTK and our data will be a string, right? That is equals to welcome to great learning. Now we want to make it a line tokenization. So basically line wise tokenization, right? Let me add one more sentence for this. I am very happy to be the part of great learning, right? Suppose you have done this. Now I'm removing to this, okay? So you have a whole total string, right? Now what you will get? If you look at this, so you can have two total line, right? Welcome to great learning. I'm very happy to be the part of great learning. Now what we are going to do, our token will be a line token, not the word tokenization, right? So if you want to make a tokenization according to what are the total lines you have in your document, you can totally do that. Now you have written tokens equals to NLTK dot send underscore tokenize. So this is the function called that is named as that is from NLTK, which is known as send underscore tokenize. And you have sent your data, which is the data variable again, and you said, hey, I want to see my tokens. So after you do that, after you actually execute this one, what you actually get, you get welcome to great learning, and I am very happy to be the part of great learning. If you can see, this is the first token, welcome to great learning, and the second token is I'm very happy to be the part of great learning. So you can see this is how our line tokenization work. Now if we want to check how the word tokenization work, what do you need to do? You just need to call dot word underscore tokenize. So this is for word tokenization. If you just execute that, what you will get? You will get welcome to great learning. I am very happy to be the part of great learning. Can you see all at the word you have, that is already what? That is already divided into tokens. All the words you have, that all the word in each and every word will be one token. Right now, if you want to check tokens dot count, right? After we did the tokens dot count, we get an error. But why? It's saying count takes exactly one argument. Yes, before you go for the checking the count, you have to check token is what type, right? Type of the token. So what we have done, let me just write one more line for you, right? Now I want to check the type of the token, right? As it's giving the error for when we are going to use the count function, right? Let me do that. Okay, what I get? The type of the token is list. To get the total count of your list, what you need to do? You have to call the function called length function, not the count function. So if you write length of tokens, you will get the total count of words you have in your documents, right? I hope this is quite clear to you how the tokenization is done. What is tokenization and why do we need tokenization? And how can you implement tokenization using Python? In this part, we are going to talk about what is stemming. Stemming is the way to reduce a word to its word stem that affixes to suffixes and prefixes. In simple terms, the algorithm works by cutting off the end of the beginning of the word while taking into account a list of common prefixes and suffixes that can be found in an inflected word. What is basically stemming stands for, we got to know. But how to do that? Suppose you have a word that is cats. So it is going to cut the S from cats and it will give you after the stemming as cat. Suppose you have birds, again it is going to cut the S from the word and you will get bird, the basic form of your word, right? So yeah, this is why we do stemming. But why do we need stemming? Because it's less input dimension. So when your words are cutting down and like in the basic form, your input dimension will be less. Machine learning techniques works better with it and makes training data more dense, reduce the size of the dictionary and helps to normalize the data in the document, right? So this is why we need stemming. So it also the part of normalizing your word. We will see when we are going to do the actual project that how stemming is going to help us. And it's also reduce the size of the dictionaries. So when we this is something related to how you are going to work with your long data set, and we will try to always cut it down to a less number of the dimensions, so we don't need a high computational power, and your technique will also work fine with a short data as well. So that's why we go for using stemming technique. Now we will see how to implement stemming using Python. So let's go to Google Colab. Right, so we came to Google Colab and I'm going to show you how to do the stemming. So to the stemming, we have to import NLTK. From NLTK, we have to import porter streamer. We are actually going to, call the porter streamer, and which is like, maybe you can give that port stem. The name you can give for port stem, the variable name, and you can directly call the function called porter stemmer. After do that, you have a word list. What word list you have? You have like, liking, and likes. I want to see how it's going to work with stemming, right? After doing that, what we are going to write? We are going to write port stem, right? So we have a list and we are iterating through a list using for loop, and your I will go to each and every words you have in your list, and you have print I and port stem dot stem, that is your not W, the I, right? If I just execute this, right, I will get for like it's like, for liking it is also like, for likes also it is like, right? So you can see how this stemming is going to work. So if you give different type of different ing after adding ing, or adding s, or adding like, right? So it's anyway it's going to give you the what? It's going to give you the base part of your word, right? So yeah, this is what stemming stand for, right? So yes, we have talked about that. What is stemming? Why do we need it? And how can you implement stemming? Right? So yes, this is what stemming stand for and why do we need it. Now we will have a look into what is limitization in NLP. We know limitization used for the part of data pre-processing. But what is that? Limitization helps to do the morphological analysis of the words. It is important to have a knowledge about the detailed dictionaries which the algorithm can refer to the link, the form back to its lemma. But what is actually meant for, right? So let's have a look at the example of limitization. Now you have given helps. So this is what? This is third person singular number, present tense, help. So your lemma will be help. Now you are saying that I am going to give a word called helping. So ing form of the word you have with the help. So your base word will be again help. So you can understand limitization and stemming is quite same. We will see what is the difference between them as well. And also we will have a look at how can you implement limitization. Before going back to the how to implement limitization, let's have a look at what is the difference between stemming and limitization. The goal basically for the stemming goal is reduce the inflectional forms. Stemming refers to the crude historic process which chops off the end of the words in order to achieve the goal correctly. Whereas the case of limitization reduce inflectional forms, but limitization refers to the things do properly with the help of the vocabulary and morphological analysis of words. So you can understand there is a one catch point for limitization. It's actually use the morphological analysis, which in the case of stemming they don't bother about morphological analysis. Now if we go and check about the implementation, stemmers are typically easier to implement and run faster compared to limitization, whereas limitization is difficult to implement. Obviously it takes time when we actually it's going to work with morphological analysis, right? So let's see how can we actually implement limitization using Python. So again we came back to Google Colab and let's have a look at how to do the limitization. So we have already imported NLTK. In this part we are going to download nltk.download wordnet, right? So downloading the package wordnet to the root, you can see this is up to date, the wordnet, right? Now you have going to actually import that wordnet limitizer from nltk. So you have made a variable called limity and you have called the function called wordnet limitizer. Now you have given socks and sons. Let's see how it's going to work. So you are going to write limity dot limitize. So what is limity? The function you have called, that is wordnet limitizer. Now you said limity dot limitize, then your word called socks, right? And you have called one more word, that is sons. So limity dot limitize, then sons. So what you will get as a result? You will get as a result sock and son. So it will chops off the last word, last character you have, that is s, and it will give you the base words. So you can understand this is what stands for limitization and stemming. Stemming is the basic way to do that, whereas limitization is doing the same thing but using morphological analysis, right? So yes, we have talked about what is stemming and also we have talked about what is limitization, difference between both of them, and how can you implement them in Python. Now we are going to talk about what are stop words and why do we need to remove them. Why it comes under data pre-processing. We will talk about that and how can you define and how can you understand what are stop words you have in your document, right? So common words that occur in sentence that add weight to the sentence are known as stop words. The stop words acts as a bridge and ensure that sentences are grammatically correct. In simple terms, words that are filtered out before processing natural language data is known as stop words, and it's a common pre-processing method. Yes, we know this removing of stop words, it's a common pre-processing method, and we will see how can we actually implement them using Python and also using NLTK library. But I hope you understand what are stop words. Stop words is nothing but common words that occurs in the sentence, but that will not have weight that add weight to the sentence, but that is not that important while we are going to do any modeling technique, so we can easily remove them. So let's see the demo, how can using NLTK, how can you actually remove the stop words from your documents. So we have came to Google Colab and let's have a look at how to do that. In order to removing the stop words, what you need to do basically, just need to import stop words from NLTK, and then you have written import NLTK nltk.download stop words, right? Let me just do that. It will actually download the stop words you have in your NLTK library, and we will see the whole list of stop words we have in NLTK. Now we have a data called data, that in the under data variable we have written data science is one of the most training field to work with. It needs the data to be give prediction by using the past scenarios. So now what we have written stop word equals to set stop words dot words, and you want stop words in which language? In English, right? So you have written stop words dot words, and then in the bracket you have written English. Now write print stop words dot words. So basically it will show you what are the stop words you have in your library, if you just remove this particular part, let's have a look at what it's going to give you. Right. So basically, it's some other language. It's going to give you the stopwords that I cannot understand. Maybe some other language. But if you write 620 to 680, basically it's splitting the data. Like what you have in these total words, in like if the stopwords have the all stopwords from like the all language they know in the library, like in the library, whatever the language it has. So basically, particularly for English one, I want to look at. So you can see your, yours, yourself, he, him, his, all are stopwords, comes under stopwords, right? So now if you just want to see what are the stopwords you have in your data, before that you have to tokenize your data. We have talked about tokenization. What tokenization does is basically make all the word one token. So whatever the word you have in your data, it will make each token for each word. Right? Let me just make it let's do the tokenization. Okay, I'm getting an error because I need to download Pound. So yes, these are the few things you have to keep in mind when you are working with NLTK. Right, you can see it basically tokenize your data. You had written data will be one token, science will be one token, is one of the most, everything will be one token. You have made the tokenization. Now if you want to check that, okay, what are the data, what are the basically tokens I have as a part of stopwords in my data after I have done the tokenization. So what you have written for word in data, if word in stops is basically the whole data, like the stopwords you have, right? Print word. So what are the stopword you have? You have is, of, the, most, to, with, to, by, the. So these are the words are not important to do the data pre-processing. So not data pre-processing, it's not important to do the modeling using natural language processing, so you can easily remove them. Yes, so this is how you can actually remove the stopwords. You can check the total list of stopwords and you can understand easily that what are the stopwords you have in your document. Yes, so if you have if you don't remove stopwords, it will basically add more weight to your data. It will take, make your prediction not that good. So we prefer to remove stopwords from our document. Right? I hope you understood about what is stopwords and how can you implement stopwords in Python. Now we are going to talk about the modeling technique in NLP. That we say that we will learn what are the modeling techniques we have in NLP, like bag of words, word to wake, and then we have TFIDF. Right? So let's have a quick look at what are this modeling technique all about and what are the main history behind it as well. Right? So let's have a look at bag of words. What is bag of words? So bag of word model is used to pre-process the text or documentations. It converts the documents into a bag of words, which keeps account of the total occurrence of the most frequent used words. And bag of words is one of the most used method to transform tokens into the set of features. So basically, after you do the tokenization, you have tokens, but there is no features. But if you are going to use bag of words, basically we use count vectorization method to do the bag of words. So what it will do, it will keep a count of total occurrence of most frequent words, right? It will going to help you to do the data modeling and to understand the prediction, right? And bag of words, as we see, that one of the most used methods to transform your tokens into a set of features, right? I hope you understand about how and what is bag of words, and we will do the bag of words implementation in our project as well. That is also using Python. Then we will see what is TFIDF. So as we know, TFIDF stands for term frequency and inverse document frequency. This helps to measure the score in order to get the transformation retrieval, that is in short known as IR or summarization. TFIDF is also used to reflect how relevant a term is in a given document. Yes, we do check that how relevant a term is in the document, basically help us to do the data pre-processing, right? And also data modeling. And procedure to calculate TFIDF by multiplying two metrics. What are these two metrics? How many times a word appears in a document and the inverse document frequency of the word across a set of documents. Yes, there is a two type of metrics you will have in TFIDF, and we will actually implement TFIDF using Python when we are going to do the project, you will see how can you implement TF-IDF as well. So you can understand about the modeling about bag of words, and also what bag of word does. It makes a count of total occurring word in the whole document, and also it does shape that what is the like how can you make a features out of your tokens. And also in the case of TF-IDF, it works pretty much same, but there is some concepts of inverse document frequency of the word across a set of documents, right? So these are the model technique we use. But why do we need TF-IDF? TF-IDF helps to establish how important a particular word in the context of the document corpus. TF-IDF takes into account the number of times the word appear in the document and offset by the number of documents that appear in the corpus. Now, TF is the frequency of term divided by total number of terms in the document, and IDF is obtained by dividing the total number of documents by the number of documents containing the term and then taking the logarithm of that quotient. Right? So this is why we need TF-IDF, and TF-IDF is the multiplication of two values. What are those? This is TF and IDF. Right? I hope you understood about what is TF-IDF and why do we need it, and we will do the implementation in our project. Then we will see what is word embedding. So basically the types of word embedding we have: word to wait, glove, and first text, right? So let's have a look at what embedding is. So word embedding vectors are one of the most common ways to encode word as vector of numbers. Those vectors can be fed into the machine learning models for inference, and also it helps to establish the distance between two tokens. If you want to check how actually you can do the distance between two tokens, you can do the word embedding. And we have talked about the types of word embedding: word to wait, glove, and first text. In this part, we are going to talk about what is machine learning. So machine learning is a subset of artificial intelligence that we all know, which comes under AI, that allows the system to automatically learn and grow from experience without being explicitly programmed. What does that mean by? Let me tell you in the diagram how this machine learning is going to work, and you can understand in layman term. Suppose you have a data set. So you have some algorithm to make a model. So you are going to make the model. Now you have data set. For the training purpose, you will use the data and the algorithm to make your model trained about whatever some prediction you want to do. Then you will have a test data set by checking your model that how your model is working with the new data. This is what machine learning stands for when we talk about in layman term. There are lots of algorithms we have, and we have different types of machine learning as well. Now we will see the life cycle to make a machine learning model. How can you do that? First, you have to understand the business problem. What type of business problem you need to understand? Suppose you try to understand for a food delivery app. You try to understand how they can actually make more sale using their app. Now, you want to make their customers happy. How can you do that? In order to do that, you can maybe use their all data to cluster their customers. If you after cluster their customers, you can maybe assign a particular coupon for all of them. Suppose you have different type of customer base. Some of the customer love to have Chinese, some of them love to have Thai food, or some of them just love to have Indian food. So you will actually make few coupons for them, and you can send across all the customers. Your customers will be happy after getting a coupon, and also they will make more orders from your app, and you are easily going to make a high sell. So that's what I have given a small single example of that. So the basic step is that you have to understand your business problem. After you understand your business problem, you have to go for data acquisition. What is data acquisition? Data acquisition is basically collecting your data. You have to collect your data to do the analysis, to do the prediction, to make the model. So all you need, that is data. Then you have to go for data cleaning. But what is data cleaning? Is my data is not cleaned? Yes, your data is not cleaned, because in past the data we used to have in a very structured way. Someone used to dare to store those data. But now in these days, you actually making the data, you are having a lot of data, but those data are unstructured or semi-structured. So in order to clean those data, you have to follow the data cleaning process that we have talked about, the data pre-processing earlier. right? After you clean your data, you have to go for exploratory data analysis, few statistical term to understand your data. After you do that, you can easily make your machine learning algorithm because you have a good idea about your data. You know what algorithm will work best for your data. After do the machine learning algorithm, you can build your model using the data and the algorithm. After you build your model, you just want to predict your model at how it's going to work. Is it going to work perfectly with the new data, which data is not shown in your model during the training? If you can see your model is giving a good prediction on that as well, you can easily say your model is ready to work with the new lots of data and it's going to give a good prediction on that as well. So this is the whole life cycle of machine learning. Now we will have a look at the types of machine learning. We have supervised learning, unsupervised learning, and reinforcement learning. What is supervised learning? What is unsupervised learning? And what is reinforcement learning? Supervised learning name itself saying there will be a supervisor. Who will be the supervisor for your machine? Your data will be the supervisor for your machine. If you have a label data, then this data comes under supervised learning. You can use any algorithm from the supervised learning in machine learning, and you can use that algorithm for your data set. Suppose you have a data without label, you don't know for what label you have in your data set. You have to make a cluster with the same type of customer or same type of a data points. That time you have to go for unsupervised learning. And last but not the least, I hope you all have an idea about Tesla self-driving car. They use reinforcement learning. Reinforcement learning is basically if your model is going to work perfectly fine, you are actually going to give a revert to your model, and if your model is not going to work perfectly fine, you will get a penalty for that. This is pretty much about the types of machine learning. So yes, we have talked about what is machine learning, what are the types of machine learning, what are the way to make the machine learning, and one more thing we will talk about, that is logistic regression, because we are going to use logistic regression concepts in our project. But what is logistic regression? Logistic regression is a part of supervised learning classification algorithm. It is used to predict the probability of a target variable, and the nature of target and dependent variable is discrete. What is actually that is meant by? Your target variable will be comes under 0 or 1, true or false, right? So this is how our logistic regression works. So for the output, there will be only two class present. So you will have a two class in your data set, right? So the dependent variable is a binary in nature, so that it can be either 1 or 0, yes or no, true, false, anything out of this. So basically it will be like a two class data set, or you will have two class in your output. Okay, not the output, you can say the label, right? In the label you will have two class. And logistic regression is also known as sigmoid function, and we all know sigmoid function equals to 1 by 1 plus to the power minus value. So it maintains this particular technique, and this is all about logistic regression. And yes, you can after this you can easily do the project what we are going to do on sentiment analysis. Now we are going to talk about what is sentiment analysis. From the name itself, you can understand we are going to talk about the sentiment. Yes, you are right. You are guessing it right. We are going to talk about the emotion of a particular person. So sentiment analysis is a technique which is commonly used to understand the positive, negative, or neutral sentiment about the particular topic. Sentiment in text are represented as a value between -1 and 1, referred to as polarity, right? And it is an unsupervised machine learning technique as well, right? So yes, so if you have few movie reviews data, and if you try to understand what is this particular review all about, it's a positive or it's a negative review. How to do that? You have to use sentiment analysis process to do that. We will do a demo on sentiment analysis. How can you understand a movie review using this particular natural language processing, all the modeling technique, data pre-processing, and also using machine learning techniques, right? So let's go to the project and let's have a look at how to do that. Now we are going to talk about a project on sentiment analysis, and we will see how can we actually implement whatever technology and whatever the techniques we have learned so far, right? So let's go to Google Colab and let's have a look at how can we start it and what is the data set we are going to use for this particular project. First, we will have a dataset description, and then I will show you step by step how can you do the sentiment analysis using natural language processing. And also we will include all the data pre-processing technique we have done so far. So let's get started. So here we are going to do a movie data analysis. But where we are going to get the data, I will show you. And what is the data all about? Let's have a look at the data description. So we are going to use IMDb dataset. So IMDb dataset having 50k movie reviews for natural language processing or text analytics. It's basically for binary sentiment classification containing substantially more than previous benchmark datasets. We provide a set of 25000 highly polar movie reviews for training and 25000 for testing. So predict the number of positive and negative reviews using either classification, or if you want to use, you can also use deep learning algorithms. But in this process, we are going to do all the modeling technique, and also we will do all the data pre-processing we have learned for our natural language processing course, right? So let's get started how we can do that. So first we need to import few libraries. What are those libraries? These libraries we are going to use for the very first time. We are going to use NumPy and Pandas. Why do we use NumPy? NumPy stands for numerical Python, and Pandas stands for data manipulation tool, right? We have talked about that before as well. So we have written import NumPy as NP and Pandas as PD. Now we are going to use this particular IMDb dataset .csv. But where you will get this dataset? It's an open source dataset. You will get this dataset on Kaggle as well. Let me show you how can you see and how can you search for Kaggle for IMDb movie dataset. Right? So you can see we have this particular dataset in Kaggle, that IMDb dataset of 50k movie reviews. If you go down, you can see an option for download. This is a 26 MB dataset. It's a pretty big dataset. If you are first working with the dataset, it's going to take a few seconds or few minutes to get download. And yes, for that you have to wait, right? And if we go down, you can see the license and usability and IMDb dataset.csv, the detail you have for what are the things you have in the dataset, everything you will get over here, right? Yes, so this is how we can actually download this particular IMDb dataset from Kaggle code. And let's have a look at what are the things we are going to do with this particular dataset. So now you can see we actually take a variable called data, and we have written pd.readcsv. We have talked about earlier as well in the part how can you use different type of data set using Python and using Pandas basically. So if you want to read a CSV file, that is comma separated value file, you have to use a function called .readcsv. So that's why we have written pd.readcsv, and then we have given the path. Now I will show you in Google Colab how can you upload the data set. So I have already shown that, but for the recap, you can see there is an upload option. If you click over here, it will redirect to your local system, and from there you can directly upload your data set what you have, and it will automatically get uploaded in the Google Colab. Now if you want to take the copy path option, you can just click on this three dot and you will get an option for copy path. Now what you need to do, you have to write read CSV and you have to give the path, right? Let me give the path. Yes, so this is something /content /imdb dataset.csv. Now, if you want to check your dataset is loaded or not, that's why we use a function called data.head. So data.head will return you the first 5 rows of your dataset. Now, I have written data.head, and it's actually return me that first 5 rows. You can see 0 to 4, and we have review and sentiment column. Now, if you want to check the last 5 rows of your dataset, how to do that? You can just write data.tail, right? Okay, so this dot tail is basically from the name itself, you can understand it's going to return you the last 5 rows of your dataset. So your last rows is 4999, and you will get the last 5 rows from your dataset. Now, if you want to check, okay, I want to check what are the columns I have in my dataset. I can see over here, we have only 2 column review and sentiment. But in the case of other data set, there will be lot more columns you will have. Now, if you want to check what are the columns you have, what do you need to do? You just need to write data.columns, and it will return you the whatever the column you have in your data set. If you just write data.column and if you just execute this, you can see review and sentiment you have, right? Yes, so this is how we can see what are the column we have in our data. Now, if I go further, before that, I want to see what is the shape of my data. So why do we need to check the shape of our data? Shape basically returns us how many columns you have, how many rows you have, right? So if you just write data dot shape, so it will first return you total 50,000 columns you have, 50,000 rows you have, and 2 column you have, right? Can you see? Yes. So this is how you can see the shape of your data. Now, if you want to check, hey, I want to see what is the description of my data. So to do the description of your data, what you need to do, you have to do the data.describe. I will talk about this is not little later, right? So first we are going to see what is .describe is going to basically return us. So this .describe we used to see, okay, maybe description is going to be what? Your data description. What is the total count of your data you have? What is the unique value you have in your data? Then, these are the things you can see in this particular case, right? If you just write data.describe, right? Can you see what are the count total 50,000 data you have, and you have unique data of 49582. There are few redundant data you have, right? Now we want to see the next step is always for that. Do we have any null value in our data sets? If we do have any null value, then we have to remove that. And otherwise, we need to understand the outlier. For now, you don't need to understand what is outlier. But one thing, always keep that in mind. If you have null value, always try to remove the null value or try to replace the null value. Because doing more the null value data set, it will not give you a good prediction, right? So to check that do you have any null value or not, you have to write data dot is null, and then we have written dot any. So basically it's going to return do you have any null value in your any column. So it will return you in the boolean. You can see what we have written, data dot is null dot any. So the review is false, sentiment is false. So that means you don't have any null value. Now, if you don't want to get it in a boolean format, if you want to see in the summation format, what you need to write, data dot is null dot sum. So basically it will give the summation of total null value you have in your data set. If you just execute that, you will get the review has 0 null value and the sentiment column has also 0 null value, right? Now, go further. Let's have a look at, I want to check what is the total value counts I have for my positive and negative. Okay, before start with the data analysis, let me show you how our data looks like. Let's go to Excel and let's have a look at what actually our data looks like, right? So I have already opened this particular IMDb dataset in my Excel. You can see we have review and sentiment column. Let me just read out one particular review and then, okay, there's a very big review. If I took this one, this is the big one. No. So basically, I got if you like the original gut-wrenching laughter, you will like this movie. If you are young or old, then you will love this movie. Hell, even my mom like it. Great camp, right? So, based on that, you can see this is a sentiment is positive. You can understand obviously it's a positive review, right? Let me just read out a negative review. So the negative review we have that is no one expects the Star Trek movies to be high art, but the fans do expect a movie that is as good as some of the best episodes. Unfortunately, this movie had a muddled and implausible plot that just left me cringing, and this is by far the worst of the 9. So, okay, so keeps on saying, so you can understand by just reading out the first 2 lines that this review is not a good review. So basically, the sentiment for this particular review will be negative, right? So this is how we are going to see if I'm going to give a particular review to my model, it's going to predict that it's a positive or negative, right? So how to do that? We are going to use natural language processing for that, and also we will use one particular machine learning concept. We will talk about that, what machine learning concepts we are going to talk, right? So let's go and let's have a look at our code so you can understand what our data set is all about, right? So let's go for data analysis part right now. So again, we came back to Google Colab and let's have a look at the total value counts for your sentiment. So I want to see how many total positive positive feedback I have and how many total negative feedback I have. So for that, what I have written that data, and then in the bracket I have written which column. That's a sentiment column. Dot value counts, right? So in this case, you can see what we have. Total negative is 25000 and positive we have 25000. So you can understand total we have 50,000 data. In this, 50% you have negative value, 50% you have positive comments, right? Now we have done this data.shape portion before as well. Now we will do the text normalization. So what it comes under text normalization, tokenization, stemming, limitization, what we have done before. Now for that, we are going to import few more libraries. Yes, you need lots of libraries to do that. So we are going to import Seaborn, Matplotlib. You can understand these two are for data visualization. Then we have NLTK. Then we have count vector for bag of words. We will see how can we do that. Then we have TFIDF vectorize. Then we have stop words removal. Then for stemming. Then again stop word. Then limitization. Right? We have also imported NLTK and we have import spacey as well. Right? So yeah, these are the basic things you need to actually start your project. Now, if I just want to show you how to, like what we have done, import NLTK we have done. But if you want to take some stop words, right? If you want to, that we have done the demo as well. So you have to download nltk.download stop words, right? Now we will do the tokenization. How to do the tokenization, right? So in this case, what we are going to write, we are going to write tokenizers equals to tokenizer. You have called this particular function, and also for stop words, you have called the function of from NLTK, that nltk.corpus.stopwords.words, and what stop word you want? You want English stop words, right? So after that, I just want to show you how to do this particular tokenizing text, removing stop words, and also if you want to remove few, if you have any brackets, right? If you have any HTML code, like if you have any tag, right? If you want to remove all those things, how to do that. So first we have written that maybe here we are going to give that noise removal text, right? We are going to remove the noise from the text. How to do that? So we have called beautiful soup. Beautiful soup is basically used for data, scrapping, if you want to do the web scrapping. And also you can use beautiful soup to actually remove the HTML tags from your data. So you can see here, so as we were talking about, and that particular comment or review have that, HTML bracket or, any special characters. I don't want them to be in my, text because I'm going to use the data pre-processing and I'm going to remove all those things to clean our data, right? So you can see we have written soup equals to beautiful soup and we have given the text. Text is nothing but your total data where you have stored all the CSV file. Then you have written HTML parser. Then you have soup.get text after removing your HTML parser from the text. Then you have written read.sub and then you have given the special characters. If you have any special character, you don't want them. So you can remove that as well. And after removing all of the, unwanted part from your data, it will return you the text. So now we are going to use a lambda function to do that. So what we are going to do, we are going to write data of review. We are going to remove all these things from the review. Data of review equals to data of review dot apply and noise removal text. So what you are going to do, you are using this particular function to this particular data. We have to remove all the HTML parser and also the, the special character. If you have, you just want to remove them. You did it, right? And then if you just write data.head, it's going to take a few minutes because yes, your data is too large to work with these things, right? So that after that, if you just write data.head, you will get the data set where you don't have any HTML parser and any special character in your data set and your data is partially clean. Now we are going to do the stemming, right? How to do the stemming? You are going to again write a function for that, that's stemmer, and you have written text. The text basically again the total data you have. Then you have written that NLTK dot put a stemmer that we have called for stemming your, to apply the stemming technique in your data set. Then you have written ps.stem words for wording text.split, right? Return text. Suppose you have done this and then you have applied this particular function to your data again. So you will get this part, right? That if you have any, prefixes and suffixes will be cut from your all the word you have, right? So here what we are going to do, we are going to declare one particular function again for what? For removing stop words, right? And here also we are going to take a parameter for text, or you can write data as well, whatever the name you want to give. Then is lowercase equals to false, right? And from there what we are going to write, we are going to write tokenizer equals to tokenizer, right? Basically we will call the tokenizer function, and then we have written tokenizer dot tokenize, and you will give your data, right? After that you will have tokens. You want token, right? That we have to do, that we have said that we need tokenizer to token our, make tokens from our document, right? Or the data. Now we have written I.strip for I in tokens, right? Your tokens, you already get the each and every tokens, and no, it will be very big, right? So fine. So you will have tokens, right? After that, you have written I.strip for I in tokens. If is lowercase, then filter tokens I for I in tokens if I not in stop word, right? So you are checking that your data is not in stop word, then you will actually make them the filtering the token, that your token is not in stop words. Else you have written filter tokens I for I in tokens if I dot lower not in stop words, right? So you are basically checking that do you have any word in your data which are coming on the stop word, right? Then you will remove that as well. So what you have done, you have actually tokenized your data, and then you are checking that the token you have, they are not the part of stop word list you have in NLTK. Then you have written that return filter text. So filter text, what is going to return? It's going to return that your data, right? What are the data you have given? The data is tokenized, and also the data is not in the part of stop words, right? So after that, you are going to again apply them and removing stop words, right? And then if you just give data.head, it will show you what after it coming, right? And it will take a little time because what? Because the reason behind it, because the data set is really big enough to work so many things in the whole data set. It will take few seconds to complete, and yes, it's completed. And data.head, you can see this, right? Now we need to train, we need to split our data set, because we are going to use one particular machine learning technique to do that, right? How to do that? So here we are going to write 10 trade split. How we are going to do the splitting for training part and testing part? Yes, what we are going to do, we have said that for training part, I want the 30,000 data, right? And for, you can see, you have written train reviews data.review, and you want this particular splitting you have done for the training. And for testing, you are going to again test the race data you have, right? After you have done this particular review part, then you will use a bag of words technique. So we have talked about what is bag of words, and here we are going to implement that. How to do that? So we are going to write CV, and we are going to call count vectorizer, right? We are going to call the count vectorizer. So basically this count vectorizer function is used for bag of words, you can say, right? Then you have written CV train. So you want to change your data or vectorize your data, the data you have, using CV train, right? So what you have, you are going to store this particular train data set in CV train variable. You have written CV.feed transform, and you have given your data get vectorized using this particular function. After that, you have written CV test, CV.transform, and test review data, right? Then what you have written? You have written that bow CV, you have done the bag of words part, right? Bow CV train and CV train dot shape. What is the total shape for this, and what is the total shape for this? You can see for training purpose, we have taken this part, and for testing purpose, we have taken this part, right? But the case of, positive for review, you did not make it train or test part, right? Yes. So you can see this is the training shift, this is the testing shift you have for after you use this particular train review data using bag of words, right? Now we will use the TF-IDF and then we will do the label encoding, right? Yes, and that time we are going to do the splitting for the reviews, like, you have what type of sentiment. We will do the training and testing speed for that, right? Now we will do the TF-IDF. So what is TF-IDF? We have talked about, and here we are going to write TF-IDF vectorizer. You are calling the method, and then you have called this method and making the object for this particular method, that is TF. Now you are going to store your training data for TF after applying the TF-IDF. You have written TF train, TF dot feed transform, and you have given your data again, train reviews data, right? After that, you have TF test and TF dot transform, trace reviews data you have given. So basically, you are using or applying TF-IDF for training as well as for testing. Now, if you want to check the total shift for them, you again can see for training you have 30,000, for testing you have 20,000 data, right? And I will show you why do we need this training and testing part, what part of the machine learning we are going to use as well. We will talk about that, right? Now, we are going to do the label encoding. Why? Because you have negative and positive. Now I want the label encoding to make it 0 and 1, right? It will make a label for, or you can see the cluster for each and for negative and positive, right? So what we have done, we have called label equals to label binarizer, right? And then you have written sentiment data label dot feed transform, and you have given data of sentiment, right? Not like the review part. You want the label encoding for sentiment, right? After you've done that, you can see the total set for this, and also if you want to check what level encoding it has done, right? So you can just write sentiment data. Can you see what it makes? 111000. So basically for all the reviews, for negative maybe it's 60. For all the positive one, it takes 1. Right? So this is how we have done the label encoding. Now what I'm going to do, I am going to make this data.sentiment for again training and testing. Right? For training purpose, I'm going to take 30,000. For testing purpose, I'm going to test 20,000 of the data. Right? Now we are going to use logistic regression. Yes. So basically, I hope you have understood about what is logistic regression, because before start with what is logistic regression, you need to have an idea about what is machine learning and how we are going to use logistic regression to do this analysis, right? So I hope you know about what is logistic regression, as we have talked about before in this particular course, right? So what we have written, logistic equals to logistic regression, and you have called this particular function logistic regression. So as I have said, for if you use Python, the basic, feature about Python is everything is already implemented in Python library, right? So we are going to use scikit-learn, and scikit-learn has the function called logistic regression, where it's implemented the concepts of logistic regression. Now you can see we have written LR-bow, and Y-bow is for bag of words, right? So you can see what we have done, logistic.feed, and we have given CV train for, bag of word. We have used counter vectorizer. So we are going to use CV train data. That is your train data basically for the sentiment, CV train for reviews, right? And you have written print LR-bow, and also you have written this, right? Let me cut this part out because we will do the TF-IDF later, right? Right? Let it give some time, and let's see what is it's going to print for bag of words, model, because first we are going to use bag of words, and then we are using logistic regression for that, and then we will see how TF-IDF will work, right? According to that, maybe you can use one of them, or maybe, yeah, right? It's going to take a little time to get executed. Yes, it's got executed. Now I want to see how the prediction is going to work for bag of words. So we have written, let me write this, POW predict, and here let me make it a little short. And here you can see we have written logistic.predict and we have given CV underscore taste, right? The testing part of our data, but we are not going to provide the sentiment because we want to check what is going to predict is how much it's going to work with the like our actual one, right? So here let's see what is going to predict. Okay, it's going to say negative, 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 dot dot dot, negative, right? I can see only negative here. Okay, we will see the accuracy score as well. Let me do that as well. Okay, so here we are going to do the accuracy part. So let me cut it down and make it here, right? Okay, so first I want to do all these things for back of words and then we will do for TF-IDF, right? Okay, so how to do the accuracy score? You have to call as accuracy score function and you have to give the test data and bow predict we have, that is backward prediction by your model, right? So right now let's check. Okay, for this it's going to give you the prediction. Okay, let me just delete it. Okay, so for this you can see it's going to give you the prediction is 59.21%. It's pretty low. It's not working that fine, right? So let's have a look at if I use TF-IDF, what I will get. For TF-IDF, again, we are going to use ELA TF-IDF, the variable name we have used and we have written logistic.fit, and we are going to provide the TF underscore train and train data, the normal one, right? Then let me check if I do the prediction, what I will get. Again, it's going to take a few minutes because yes, that's a big data set anyway we are working with. Now, if I do the prediction, so you can see the prediction is giving me 0.74%. So you can see here basically TF-IDF is working pretty cool with this particular data. And like first you are doing all the data pre-processing, you are removing the, tokenizing the data, you are removing the, noisy part you have in your data set. Then you have used tokenization, steaming, limitization, removing stop word, we have done everything. And then we have used TF-IDF and back of words. So in this case, we can see TF-IDF is working really good with this data. And then we have used logistic regression from machine learning. That is a supervised learning technique, right? So yes, you can see this is how we have done the sentiment analysis using natural language processing, right? I hope you like it. And please, if you have any doubt, do let us know. And yes, this is pretty much about the project we have done. And we have used all the technique we have learned in this particular course.
So now let's come to what is text blob. So what is text blob? Text blob is an open source Python library which is used for ML activities like limitization, stemming, tokenization, noun phrase extraction, POS tagging, n-grams, and sentiment analysis. So what is n-grams? Since we didn't discuss about it, so let's now take an example to understand it. Let's say this course is about NLP and text blob. Okay, so what n-grams stands for? N-grams are like, for example, let's say unigram. Okay, so unigram will get the tokens like this course is, similarly it will get text blob, okay, into a list. Similarly, bigram, or so what bigram will do, bigram will take the 2. Your window size from 1 it will change to 2. So now your window size is 2. This course will become 1 word. Course is will become 2. Similarly, and text blob will become 3rd. Okay, so this will become 2nd, this will become this, and then this will become this, then NLP and this, then this text blob and text blob. Okay, So this way we can create unigram, bigram, trigram, quadgram. So how many number of grams we want to extract, we can get that. And with those n grams, what we can do, we can get the phrase. For example, this course, NLP and NLP text blob. Okay, so this way we can extract the information in terms of phrases. So this way it helps us in getting the phrase from the sentence. Let me remove it. So text blob is faster than NLP. However, they do not provide the functionality of vectorization and dependency parsing. Like we discussed in the previous slide, what is text vectorization? But these features are not available with text blob. So text classification, sentiment analysis, these kind of activities we can do with the help of text blob. So let me clear it. So how you can install text blob? So if you have Python, what you can do, you can install it with the help of this command pip install text blob. So once you do this, it will take more than 2 or 4 minutes. Hardly it will take 5 minutes based on the speed of your internet and all. It will get installed into your system, and then you can import text blob, and then you can do all the activities, functionalities of text blob. So for this, let's jump into Jupyter Notebook and see you there. Now we have our Jupyter Notebook open. So for this exercise, we are using Jupyter Notebook and Anaconda. So if you don't have Jupyter Notebook and Anaconda installed, I would highly encourage you to install them. Or if you have any difficulty, you can go through the videos of Great Learning. They have provided videos for how you can install and how you can run your programs on Jupyter Notebook with the help of Anaconda environment. So now let's get started. So we have discussed what is NLP. We have also discussed what is text blob and what are the kind of activities we can perform with the help of text blob. So without wasting any time, let's get started. This is the official website. You can go there and you can read about it, and you will find so many information about text blob. You will see examples how you can use them. So I will also encourage you to go through the documentations of text blob. So in order to install text blob, you need to have NLTK in your system. You need to have text blob. So pip install NLTK, pip install text blob. So since I have these installed, so I'm not going to do anything. So then what you can do, you can just write import NLTK and then NLTK dot download. In that you can write popular. Okay, so once you do that, what it will do, it will download popular corpus for natural language processing, and which will help you in going forward performing any activities in natural language processing with the help of NLTK. So once you download that, then you can also download this average perceptron tagger. Okay, this helps in doing the tagging task. Okay, so you can also download it. So in this session, what are the functionalities we will be looking into this video? We will be looking into what is language detection, what is word correction, how you can count the word or get the frequency of the words, then phrase extraction, then POS tagging, what is tokenization, popular pluralization of words using text blob, limitizations in text blob, and n-grams in text blob. So what is language detection? Okay, so with the help of Google Translate, what this text blob does, text blob takes your input, it hits the Google API, Google Translate API, and then from that Google Translate API, it gets an response, translated text, and that text it reflects in your system. If you don't know about APIs, how APIs works, how you can hit an API, so these things you can see in the video of Great Learning. They have also a video on APIs, so you can go and watch them. But for this course, we don't need to have a API, or we don't need to hit any API. But for the sake of understanding how text blob works, we just wanted to give you the information. So let's suppose we have a text. Hey John, how are you? So first we will detect what is the language, or in which language this text is. Similarly, then we will convert it into Spanish. Okay. So for different language, they have extensions. Let's say let's execute it. To execute it, we will press Shift plus Enter. So once you press Shift plus Enter, it will take some time, and then you will see detected language is English, that is EN. Input text in Spanish. Hola, I'm not good at Spanish, so I'm not going to pronounce them. But yeah, this way we can translate the sentence into from English to Spanish. So now, when you there is a disclaimer or there is a note. So when you will do this text blob and you try to detect the language or try to translate the language, what will happen? You will get an error 404. Okay, why this is happening? Because recently Google have changed their API address. Okay, and which is not updated till now in text blobs API. Okay, I think in their function they will update in some other some time. Okay, but for now what we can do, you can change that. Okay, you need to go to your C user, then whatever is your username, then anaconda 3, then your environment name. Like let's say our environment name for this is Rython. Okay, so we'll go to Rython, then lib, then site packages, then text blob. In that you will find translate.py. In that translate.py, just copy this URL equals to this text and just paste it instead of the other URL, and you will be able to execute your code. So yeah, let's move on to our next thing. What is spelling correction? So what happens that whenever we write anything in any platform, due to typo or something like that, we do commit we commit mistakes. So how we can correct them? Okay, so sometime for a programmer, it's a difficult task to read each and every words. Okay, so what TextBlob does? TextBlob provides you a feature to use a text blob and to convert the wrong word into a correct word. Okay, so it uses lexical rules to do so. We are not going to discuss those rules in a detail, how they can do the spelling correction. So I'll just execute it. So first we will import from text blob, import text blob. So we are from text blob, we are importing this function text blob, then executing it. Now let's print the text. ABCD Corp, ALAYS values, I think it's their employees. Okay, but the words are written in a wrong. Okay, so we will create an object of this. Okay, we will pass this text into this text blob and we will create a blob. Okay, so if you print this blob, let me print this for you. We'll create a new cell, blob. So text blob, this will give you the input. So blob dot correct, the correct as the function to do the spelling correction. So you will see ABCD for this corp is missing now. Always values their employees. Okay, So we can see sometimes some of the words are getting misplaced, but we see few words are getting corrected as well. Okay. Let's use has. Okay, if you use smaller text, I'll give you a hint. If you use a smaller text, you will get the output correct, but if you provide a long string, it will not give you a good result. Okay, since someone has written UR instead of your, but it will convert it into or, which is wrong. So sometime it is correct, sometime it is wrong. So based on the use case and based on the incorrection in the spelling of the words, you can apply it. Okay. So now let's see word count. So in any machine learning, we need to identify the variability. We need to know what is the variability of the documents or what is the variability of the data. So in terms of text data, it is very important to know the frequency. If the words have no frequency, let's suppose you have 50,000 words and those words have no frequency, they are only called once. So it's a difficult for the machine, because what will happen, your this uh, the text vector, the vector will become very sparse. It will have zeros more as compared to ones. Okay, so in that case, it will be very difficult for machine to understand the text, understand the patterns, and then do the classification, do the recommendation, and things like that, whatever you want to achieve. So it will become very difficult. So you need to know whether the text has the frequency or not. So the counting the frequency of words is very important. So for now, let's take an example. So let's take this word count. If you want to count the analyze, let me correct it out. Analyze, what is the count of sentiment? Sentiment count is 0. But if you see the sentiment in lower, it has a count of 3. So whenever you are searching a word with uppercase, see here we are writing in uppercase sentiment, sentiment twice, sentiment 3 times. Okay, if you see, we have sentiment 3 times. But when you search this term, the sentiment with starting with capital, okay, it will throw a 0. But if you use this, it will give you 3. Similarly, if you use analysis, we know analysis frequency of analysis is 1, but still if you do it with the uppercase, you will get a 0 count. Okay, so be mindful whenever you are counting the word frequency, you need to provide it in lowercase. Okay, so now let's do POS tagging. So let's suppose you have a word, my name is Adam. I like to read about natural NLP and I work at ABCD Corporation. See, my, it's a preposition, name is noun, it's a verb, it's preposition, it's VBP, it's to, it's verb. So there are so many POS present here. Okay. Okay, now we got that. Okay, from any word we can extract the POS. Okay, but what I will do with those POS? Okay, let's suppose I know that. Okay, it's a noun, it's a pronoun, it's a verb, it's a adverb, adjective. I know each and everything, but how it will useful in my use case? Okay, now let's suppose you are you are doing some review sentiments. Okay, review sentiment analysis. Okay, and in that you will find that prepositions are not making any sense. Okay, or verbs are not making any sense. For example, I'm not going into the little understanding of that whether it the process is right or wrong, because any process is right or wrong is based on the data set. Until or unless you don't have the data set, you cannot say that this process is right or this process is wrong. But what we can do, we can understand that, okay, whatever I am doing is making sense to me or not. Okay, so we are just looking into example hypothetically. So let's say I want to remove this VBP. Okay, I want to remove this POS. I don't want this POS in my sentence. Okay, and if any word is there with this POS, I'll remove that word. Okay, so how we can do this? So I'll use forward loop for I in text dot tags. If VP not in I of 1. Okay, so let's execute it one by one. Print I. Okay, so I'll just remove them. If you print, you will see this. Okay, next what we are doing, if VBP not in I of 1, this is I. Okay, I of 1 is this, I is this, I of 0 is this, I of 1 is NN, I of this is this, VBZ is I of 1. Okay, so if this is not there, what we will do, we will update this new tuple list. Okay, so I'll just execute it. Now if you see, we have all those tuples into the list. Okay, now I want to join those sentences, so I'll use join. And now you see, my name is Adam, I do read and about NLP, I at Adam ABCD Corp. Okay, no matter what, this thing is like helping us in understanding, or is it making sense, this example or not. But what our intention was, or what our intention is here, to just see how we can remove a particular POS and how it will help me in cleaning my data. So now moving on to next thing, what is tokenization? So before that, what is corpus or corpora? Corpus is nothing but it's a collection of text data. So in terms of NLP, like we say data set, in any machine learning thing, we say corpus in terms of natural language processing. Okay. So your corpus may be of one language, or it may be a combination of multiple languages. Okay, that is not a concern, but a corpus will contain text data. Okay, so now the next term which comes is token. We have discussed earlier also what is token and all. We discussed that we will convert the word into tokens. So token is nothing but a total number of words in a text. Okay, so what token is? Token is smallest unit of a sentence. For example, this is a book, so this is a this token is another token, another token, book, another token. Okay, so tokenization we can do with various things. Let's suppose if you want to, for example, ABC underscore 123 underscore DFGA. So you want to tokenize the text with the help of underscore, then your terms will become ABC is one token, 123 is another token, DEFG is another token. Or if you want to perform with the help of space, you can keep the normal space and then you can get the tokenization done. So now let's see how you can how we can do the tokenization uh, 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 in text blob. Okay, so this is our text. We'll create a blob object of it. Okay, and then corpus dot word. This is it. So now we have the tokenization on the basis of words. Okay, let's say there are 40 words. Tokenization we can do on the basis of sentence also. So on the sentence level, let's see, there are 3 sentences. Okay, So this way we can do tokenization at particular character level, or at particular spatial character level, or at the level of sentence. Okay. So what is pluralization of words, and how we can do it with text blob? So now for that we will use the function word. From text blob, import word. Then we will pass the words or the string to this function word, and we are storing the result into w small, then w small dot pluralize. So when you do this, becomes platforms. So but if you do the pluralization of platforms, let's see what will happen. It will add one more s to that. Okay, that is wrong. Okay. So now let's do one more thing. If our POS is NN, okay, what we will do? We will pluralize the word. Okay, so we will pluralize that particular word. So let's see. So our great learning is a great platform. So this become platforms to learn data science. So science becomes sciences. Okay, so which is not correct word. It helps community, so communities, that is right, but etc will become etcs. Okay, so this way we can do this, but yeah, we will have to be mindful whenever we are performing any activities in text, whether that will make any sense to it or not, that we need to check. So now let's see how we can do the lemmatization. So for lemmatization, we will create a object of this thing. We will create a text blob object, and that from that we will create the unique tokens of it. Okay, and then we will do the word dot lemmatize. Okay, and word dot stem to perform the lemmatization and stemming. So now let's execute it. So when we execute it, we will see great learning. Great lemmatization is great, stemming is great. So learning, lemmatization is learning, stem is learned. Okay. Similarly, when we provide a word, okay, and we are lemmatizing it as terms of noun, you will see it's a learning. Since great learning is a name, so we are calling it as a noun. But if it is verb, how it will do? It will treat it as a verb. So it will change it to its base form, that is learn. Okay, like peoples. So it will change it to into people. Okay. So now let's do how we can do the n-grams. Okay. So we have our blob ready. So blob dot n-grams, where n is 1. Let's see. All the words are unique tokens. Okay. So unigrams. Now let's do the second one. Great learning. Learning is a. This way we are creating 2 grams. If we provide 3, it will become trigram. 4, then quadgram. Okay. So yeah, this way these are the functions which we can perform with the help of text block. Now let's move on to our next topic, that is sentiment analysis on text block. So for that, let's jump into our Jupyter notebook. Now for this example, or for this exercise, the sentiment analysis on text block, we will be using the data set, which is IMDb dataset sentiment analysis in CSV format. You can get this dataset from kaggle.com. You just use this link, kaggle.com/Columbian/IMDb dataset analysis in CSV format. You will get that dataset. Okay. So now let's execute it. So now first here for this exercise, we are using a couple of packages like pandas, text blob, NLTK, RE package, then we are using Spacey. If you want to know about Spacey, you can check the great learning links for that, okay, and you will find great tutorials for that, okay. So in text block, the format or the way we can find out any sentiment of a text is with the help of text block, then providing the text inside this brackets, then dot sentiment, okay. So when you do this, you will get two things. One is polarity and the another one is subjectivity. Similarly, you execute this and then you execute the third one, okay. So now if you see, you are getting polarity. He is a very good boy, okay. So it's a polarity. Polarity means what is, whether it's a positive one, it's a negative one, okay. So it ranges from -1 to 1, okay. On the other hand, subjectivity ranges from 0 to 1, okay. So what does polarity gives you? Polarity gives you what is the sentiment of that sentence, okay. And what subjectivity gives you? Subjectivity gives you whether it's an opinion or not, okay. If it's an opinion, then the subjectivity score will be more closer to 1. If it's a positive, it will be more towards 1 in the terms of polarity also. In terms of polarity, if a text is positive, it will be towards 1. If it's negative, it will be more towards near -1. On the other hand, subjectivity provides you whether it's an opinion or not. If it's an opinion, then your subjectivity score will be higher. And if it is not an opinion, your subjectivity score will be lower. He is a very good boy. That means there are so many people praises this boy, okay, or praised this boy. That means it's an opinion from a group, okay, and he is a good boy. That means it's the sentiment is positive and it's an uh, opinion from people, so that's why its subjectivity score is higher. He is not a good boy, so your polarity is like -0.35. That means it's a negative sentence, but its a subjectivity is 0.60. That means it's an opinion from people. Let's move on to the next sentence. That is, everybody says this man is poor. So polarity is again negative because they are saying that this man is poor. So it's a negative sentence. On the other hand, the subjectivity score is higher. That means there are so many people. Since it is written everybody says, that means it's an opinion. So your subjectivity score is higher. So now for this, let's load the data. So for this, we will be using pd.readcsv to load a CSV file. So let's execute it. Now we have our data. Now we will be using, since it's a 40,000 data, and we will be lowering this data to 5,000. So lower that. So now we will be training the data, getting the data. So now we have 10,000 data. Here there are two labels, 0 and 1. 0 stands for negative, 1 stands for positive. So for data pre-processing, the first step is to check whether the your sentence, whether the text has null values or not. So for that, we will use train.isNull.sum. So this is our train data. We'll apply that data. So we see that there is no null values present here. Okay. So then we will use NumPy, okay, and we will use regex here to replace if there is a space, okay. So what happens in NLP in text is that, let's say your text is something like that, then this is space, and if it is a value, then that will not be considered as a null value. But since it's a blank value, so for us it is not making any sense. We need to remove them off, okay. So we can do this with the help of with the help of this regex function. So let's drop them off if there is anything. So how we can remove skip sequence? Okay, so \t, \n, \r, these are nothing but these are space sequence characters. Okay, we don't need them. So in text, when the text getting encoded, these are added to the text, so we need to remove them. So we will use this. So we have removed them. Again, we will check that. Okay, so this is our text data. Now what we will do, we will remove the non-ASCII words. For that, we will use your text.str.encode ASCII, and rest you can ignore. Then how you will decode? You will decode it as ASCII. So this way we can remove that. Similarly, we can remove the punctuations. Okay, so before we go into that, let's see what is punctuation. Okay, let me just create a space for you. Import string, then we'll use. So these are nothing but these are punctuations. Okay, so for that we will write a function remove punctuation. Inside that we are importing a package, then we are using a for loop, and if punctuation is there, we are replacing with no space. Okay, and then we will apply this function here to a Jupyter notebook. Now it is executed. Now let's see how train data looks. So this is our train data. So the data is same, but we have removed the uh, characters. Like for example, Mr. Lincoln. Okay, see, Mr. Lincoln is, the period is now removed. Okay, so we discussed the stop words. So these are some of the stop words which are famous stop words, and we can remove them off. Okay, so we will remove them off. But since we are doing a sentiment analysis, okay, and just take an example. He is not a good boy and he is a good boy. Okay, and if we remove not from that, let's suppose our text is he is not a good boy. Okay, what will happen? The sentence will get changed. Since we were saying this is a bad boy, now he is a good. So we need to take care of these kind of a thing, and these stop words, like I mentioned, is a use case dependent. Okay, so you need to look into your use case to identify how you can remove the stop words and what are the stop words you need to remove. Okay, so we will remove this from this stop word list. Okay, not and no. Okay, now we will create a function for that. Okay, it's a pretty straightforward function, so we will execute it. Now it will take some time. Now execute it. Train. So now if you see, there are no stop words here. Earlier if you see, I like 8704 I have. Okay, so if you see, never, I have is removed. Okay, now we will remove the special characters. So we will use regex for that. We will remove HTML characters. Sometimes we get URLs in our text, so we can remove those URLs with the help of RE package. So we'll remove it. Next, we will remove the numbers or integer from the text. So now we have removed it. Now we will remove alphanumeric character. Let's suppose some ID is there, SK012397J6, or someone's PAN card number is given. So we don't need those numbers. So we need to remove those alphanumeric characters. So with this function, we can remove it. We will create a first, we will identify that words, okay, the digits. Then in that digits, we will remove the string and digit. If string like alphabets and numbers both are present in a text, we will remove that with a space. Okay, let's execute it. So now if you see, our text is clean. Okay, so the next step which we are going to do here is we will be applying limitization. Now our limitization is done. So we are all good with all the pre-processing of the data. So now let's use the text blob sentiment function to get the sentiment from the sentence. So this is our sentiment. We are storing the sentiment into a column known as sentiment, and for that we will be using trained text. We will be applying that function with the help of lambda. So we will use that. Suppose we are that text, each text will get into tweet, and this tweet will go into the text blob, and then we will get the sentiment from it. So now let's execute it. This will take some time, so we'll need to be patient for that. So I'll just wait for that to execute. So now this is executed. Now if you see train, so what will happen for that, for all the text, we will get sentiment. Okay, and we will get a tuple. Okay, one is like we discussed earlier, polarity, and another one is our one we will get this polarity, and another one we will get specificity. Okay, subjectivity, sorry for that. We will get the next term as subjectivity and polarity. So now we have the list of that. So what we will be doing, we will be storing these values into a list. Okay, so now let's execute it. Okay, and we will create a new data frame known as df1. Okay, so now let's see how our df1 looks like. df1. So if you see, polarity is a one column and subjectivity is another column. And then we will do the concatenation of train with df1. So now we have that. And now we will remove the sentiment. Okay. And we will use the log function to, if the polarity is greater than or equals to 0.03, we will consider it as a positive and we will store it into a new column known as sentiment. If it is lesser than this, we will store it as into a sentiment as a negative. So now let's see. This is our polarity, this is subjectivity, and our sentiment. So now we can label them. If your label is 1, sentiment label will become 1. If your label is 0, sentiment label will become 0. So let's execute it. So we have that sentiment label, and we have sentiment, and we have subjectivity, we have polarity. So this way we can perform sentiment analysis using text blob.
What exactly is your understanding on unit? What is happening in unit? Okay, fine. So what are we doing here is, let us say we have an image. Okay, let us say this is an image, and I want to convert this image into some kind of encoded structure, which is smaller in size, yet it retains all the information over there. So when I have such kind of problem, what do? We always go ahead with convolutions. So what I will do, I will take a larger image, I will do convolutions, max pooling, I'll convert it smaller. So just imagine the height is the dimension. I'm just reducing the dimension one by one. All right. So I'll do multiple layers of convolution pooling, such a way that I can say that the information that is stored here, I have shrunken it down to this much. This process is called encoding. Alright. Now what is the use of these things? Where do we use this? First of all, it could be used to store. So if in case you want to compress the images and store it, yes, you can do this. Second thing is there could be certain applications where a larger image or having a huge data multiplication not possible. So in that case, we will try to give this image and try to recreate something out of this bag. That was nothing but autoencoders. Do people remember? We got, if you remember the numbers and all, we had original image, and the answer that we got was a very vague kind of downsampled, or I can say vaguely sampled images. Even though from the looking at the image, we can make out the numbers. So it was not so bad. So whenever you want dimension reduction and all, this thing could be possible. But in today's case, we are not looking for that application. What we will do is, I will now try to recreate this image back. So any idea how can I do that? So let me first put the figure so that from there you get to know what we are doing. Alright, till I get back to the original dimension. So what I'm doing compression, decompression. So I can say this is encoding, this could be decoding. Okay. Now, my question to all of you is how we can do this? How is it possible? The convolution part, you people got it. We understood the possibility, how you can do this. Let me show you guys something on the visual part of it. So say, I originally had a triangle. Alright. Now what I did, when I encoded it to a smaller triangle. Yeah. Now my aim is to bring that triangle back such a way that it is almost similar to the original one, something like this. Yeah. How to do that? Very simple. What you do is you start. So let us say there are some pixels. Okay. So you expand those pixels. Say that might be, this is my current range. The nearby pixels also will be of the same range. So this could be one operation. On the top of that, you do one more operation saying that, okay, let me expand this. On the top of this, say one more, something like this. So you keep expanding or going in reverse direction such a way that till you reach your original shape and size. Okay. So this is your very basic concept. But if you want to look at from image point of view, let us say this is an n cross n image. Now what does this image have? Please remember only numbers, nothing else. Now after encoding, what I'm going to have, let us say I have my encoded data as 2 cross 2. It could be 1, 2, pixel numbers, 4 and 6. After encoding, after going through multiple layers of convolution, let us say we end up into this. Now how do I recreate it back? So what I will do, I will try to create something like a pad around it. We'll start doing padding around here. And in this padding, what I will do, let us say I add one layer of pad, for example. Now when I add one layer of pad, what's going to happen? We will get new values. Right? So what if I say that the points near to this will get this value? The points near to this will get this value. So this is 4, this is 4, this is 4. Points near to this, 6, 6, 6. 1, 1, 1. Yeah. So now can I say yes, there are some numbers around it. Like this, I will keep increasing my values one by one. Yeah. Now this looks convincing over here, but are you able to find a problem here? There could be some problem here. Because of using the same pixels, I am replicating the same color. Correct? Because of this issue. So actually it looks like an issue, but yes, we have got a solution here. So why is the solution? So now keep this in mind, this type of concept, and we'll come back to this. There could be certain times where you don't need to identify what is there in the image. See, in this image, if you observe, what all we can get out of this. So if this image was passed through your YOLO, so your this week's week 4 content, YOLO will give you many object detection saying this is a house, sky, It will give you all the cars, and you would have seen this kind of stuff on YouTube and LinkedIn also, people posting it. People are walking and YOLO and SSD are able to identify them and in the image. Yeah. What else you can see? You can see houses, you can see a pole, you can see a building, a lot of things you can see. Yeah. Sometimes our application does not need these kind of sophistication. I will give you an example where. Let us say you are having, again coming back to your parking slot problem. I think I have explained you earlier also. Let us say there are some parking slot which has sensors. Now sensors, putting a sensor there is very costly sometimes because of maintenance and all lot of issues, maintenance, hardware and all this. So what if I remove this sensor and I put a simple camera over there, and this camera is connected to one of our uh, deep learning networks. Yeah. Now what it does is the camera captures an image of the slot. Now is it necessary for me to, let us say there is a car parked over here. Now the only intention to show here is whether this car park is full or empty. It has to detect and display it in a display board down the line, so that nobody comes and wastes the time over here and go back. Yeah. So what is our job here is just to identify, is there some object on this or not. What is the object, what color, what company, what type of car, we are not interested in. So applications where you don't need to detect like this, but yes, you need to separate the object by color or by any of the other methods. You can say segmentation will be in use. So this is called semantic segmentation, where you are trying to give a color to similar type of objects. Do you people see that? All the cars are almost purple colored. Sky is one color, road is of one color, and because of the difference, this is one color, and the ground is of one color. Now try to bring that encoding decoding concept over here. So what is going to happen now is, we will make an algorithm such a way that if this color is red, if it is an encoded stuff, what I will do is I will see to it the neighboring stuff, neighboring pixels to this also gets the same color. But in this case, our segmentation is giving purple color. Yeah. So I will see if this is purple. I will try to give purple almost everywhere till I find this image is in scope. Correct. And also you will see there are some borders you might find the color is coming apart from that. So this is the way you can say that yes, the image could be encoded down, and then when you are decoding back, there are chances that we can get a very similar color around a simple object. Okay. So this is a application of encoding decoding. Now you may ask me, fine, apart from this parking slot, where else you need it? Let us say you are working on this Google car, self-driving car. So what does a car need to see? The car has to do two things. First of all, it has to drive. Right? Now where will it drive? Obviously it has to find a road. Yeah. Now if, let us say this is the image given to the car, there could be lot of confusion. There could be one road going over here. The car will not come to know sometimes because of lot of objects present in the image. We are not sure. So what I will do for that time is, to solve this problem, I will put an algorithm saying that wherever I find a road, first of all, Google will see an image like this. And whenever there is a road, you might find one particular color, follow that. I don't care about any other object around me. I only care about one thing, which is road. That's it. Yeah. So there are algorithms in which we can blacken this up. So whatever you see here, no. So if I say, okay, I'm focusing only on the road part of it, I can wipe this out into one color. Let us say whatever is not road is red color. Okay, something like this. So imagine a picture where this is happening. So there are only two colors, one is red and one is black. So Google, the particular self-driving car will come to know that yes, that's all is my road. Now wherever I keep finding this black color, I will keep following. And there could be one more application on that, if there is something on the road, it has to stop and manage the speed. In that case, you can say that yes, I have detected a person or I have detected a car like this or something, which should not be that much complicated as compared to the driving part. Yeah. So this is one example of semantic segmentation. Now there are various types of semantic segmentation. We have instance and we have semantic. So let's start with the semantic part. So as I said, if you observe here, there are two buses. Okay. So when the image was shrunken down and when we get back the image, what's going to happen is the pixels are going to basically say that, okay, this is a part of the same family. Let us use a same color. So let us say this was my first pixel. 1 minute. This could be my first pixel. Then I would have drawn a bracket around it. More same color pixel. More. Like that, I started increasing, and I finally got wherever there is bus. If you observe, there is a green color. Wherever there is no bus. It is followed by a black color. Correct? So I can easily come to know that when I look at this, there are two buses. That's it. So this is called semantic segmentation. And there is something called instant segmentation. Now in this also, if you want classification, because this is one type of bus, this is another type of bus. In that case, you can say this is double decker and this is single. Okay. So all we need to do is, we need to have a very good corpus, that is your training data, and we need to have your target data. Are you able to get it? We have to train them. First of all, saying that if this is the scope, you have to do this. Or if this is the scope, you have to do this. Wherever you find these kind of buses, you color them. So I need to have original images and I need to have target images. Alright? Anything else possible here? Apart from these two. See, if in case you train the image saying that I just want to detect this. I don't want to detect this, the double decker. So in that case, this also will become black. This will be identified. Okay. So once you progress onto that, you can have a lot of other applications onto this. If you look at the unit structure, what are we doing now is, if this is my original image and this is my convoluted image, what can you say about these two? What is present in the convoluted image? So we'll have a list of filters available with us. Agreed? And what are these? These are one of the most important features per filter, right? So just imagine that an image is broken down into a very simple encoded part. So just imagine this is a list, or I can say a combination of lot of convoluted filters. So can I say these are one of the most important features from the image? Remaining stuff we don't much care about it. Correct? Next, what I do is, if you observe, now we are upscaling. So we are picking up each filter, and as I showed you people, that if this is one filter, pad it up. So if you observe the size of this and size of this, definitely there is an increase in this. So by padding, what are we doing? We will say that instead of max pooling it, we will replicate this by the same pixel. So if the pixel number is 1, that means it represents a color. This also I will put the same number. Alright. So this is the way we are expanding. So now if you go back to that bus, let us say in that bus part, if this was one of the filters, let us say, let me pull out a color. Let us say if this was one of the convoluted filters. So what would have happened? The color which is represented here will be replicated around the line. But from the training part, we have pushed that this should be the color. So in that case, green color will be put on to the complete box that you see. So it will be now completely green color. Now I will go to the next one. I will do the same job. I will go to the next filter. I will do the same job. Alright. So when I come here, it has been learned that if this is not the object that we are looking for, this is something else, it has been learned that it is from the black side. So whatever is there, you replace it by black. Alright. So this is how they do it. So this is a very ideal image I have shown you. So today in the case study, you will actually come to know it is not this accurate. If you observe here, there is a line, exact same line. It is not very accurate, to be very frank. But yes, you will be able to pull out separate objects. Okay. Moving on. So this is what is unit. Again, I would say give some time to this. These are not straightforward things. And if they were, then it won't be, you will not find a very handful of people who are actually working on units. They can design the unit without any references and issues. So This is what is unit, and if you observe, this is not only one part. Like this is not the only possible solution. You can mix match a lot of convolutions, all stuff over here to move and you have to make your own unit. But please be careful. Sometimes what happens is image, let us say in this case is of this size, the image that we got out could be of a different size. So if you are expecting that image is perfect replica of it and all, then you need to design it such a way that all this, basically this and this should exactly match with each other, opposite of that. That is what we did in autoencoders. Alright, but in this case it is not perfect. It is like some size and output is going on to some size. So you can combine, so it's not always necessary that I'll only use unit. You can use ResNet or something like that to have a lot of replications, and finally we make sure we get the image of same size. Or in other case, you can use my logic from autoencoders. The autoencoder is a very simple logic. Whatever is here is over here. Whatever is a shape and size here is the shape and size here. That's it. Alright. Now, let us say the doctor wants to understand which of these cells are cancerous, which of them are not. So what if I can use these things to locate certain part of that image, saying that this is my cancered one and whatever is around it, the black zone. So whatever is there, definitely there are cells around it, but we are not interested where is it. Now, if the image is not of the same dimension and all this, there will be a lot of issue in identifying the place. Alright. So in those cases, yes, I agree. It is needed, exact replication. Sometimes we don't need it. So whenever you are designing this, take a decision on your how do you say, depending on your application. Alright. Good. Now coming to mobile net. So what I will do, we will look at the case study and then we'll come on to the mobile net. So mobile net is again a different part. Yeah. So I will actually in mobile net we will do a lot of maths today. I'll show you how I can reduce my number of multiplications from VGG or normal convolutions to mobile nets. Alright. Okay. So just for starting purpose, what are we going to do today is, we have got a set of images like this. Okay, just let me reload it. Yeah. The whole intention today will be to let us say this is one image that I have. Okay. Now I want to find out, say, I want to convert them into some kind of mask or some kind of segmentation. Yeah. But if you observe here, there are so many objects. So there is a car, there are some buildings, there is some, vegetation over here, there are pathways, there is a road, there is sky, a lot of things is there. And also this image is not that clear. Why? Because I've used 128 cross 128. That's the only issue. Otherwise, if I use 1024 cross 1024, it would have been better. But at the end of the day, what is my intention? My intention is to convert it to like this. Very simple. So why do I need this? Let us say the forest or I'll say environment department wants to know how much vegetation is present on each road. So if you look at this, it clearly shows us that overview that there's a good amount of trees present over here, for example. Or else, what is the current traffic level at particular time of the day? So I don't want to, basically look at other objects. I just want to look at my car and the road. In that case, you can just look at it. Yeah. So this is what is the purpose of today's case study, where we convert this to this, as simple as that. Or if I go down and show you some of the outputs, I want to convert this particular image to this image. Okay. Now, from one of my other batches, I got a very good question that what if we can map up? So how are these colors coming up? First of all, these colors are coming up because this is my original image, okay, and this is my masked image, or I can say my tagged image. So already somebody has provided us. So from this, we are getting the mappings. But yeah, so the purple color for the road is coming from something like this, the learnings. So what I'm going to do now is, they ask me, okay, fine, if we can find some kind of relationship between the colors in the original and the colors in the segmentation, should be good. So yes, I will show you guys something next week or next to next week. So I'll start coding onto that. And I will show you guys what is the relationship between the color and this, and how these guys have done. But overall, in this case study, it is all dependent on our masked image or tagged image. All right. So now let's start. So this is the place where you can download the data set from. And for our Collab people, if you can use the above code, I will start from here. So the first thing is I have to define my shape and size. So now one question to all of you. Let us say I have defined 128 cross 128. Or else if some of you would have done it, say 256 cross 256. Or one of you, let us say having GPU has done 1024 cross 1024. Will it make some kind of difference on the quality of my output or no? So whatever extra spills that we are seeing, no, you will not be able to see that, because if the image has more samples or more pixels, the difference between the colors will be farther. Yeah, so please remember that. To choose an optimal image size, for ease, because my epochs otherwise will die over here. So for ease, I have chosen 128, 128. When you get this code, try on a higher dimension also, nothing wrong. Next is, I'm listing all the set of images that are present in my training images. That means my original images, this ones. Yeah. So if I look at it, this is how it looks like. Now, why is it important? Because here, the person who's prepared the data has given the same name to the original image, and the same name goes into the masked image. So if you observe here, I'm printing the original image and the masked image. Original image, masked image. So when I do that, if you observe, the names are perfectly same. So that we'll come to know which is the target image, or the, how do I say, reference image for the original one. So this is original, this is masked. Yep. So the first thing that I have to do is, just to keep a check, everything is good, I have to sort both of these. So this is my independent set of data, this is my target set of data. Correct? So if I sort both of them, common sense is going to come to same name. So basically we'll be able to put it in same hierarchy. Alright. Next, we are using OpenCV. So OpenCV is, again, is a library which could be used for a lot of importing images, printing images, and all this part of it. And here for displaying part, I'm using simple matplot. The first thing that I have to do is, I have to now differentiate X and Y. So guys, one more thing. There are various ways in which you can do segmentation. Please remember, there is not one way. I am showing you an easy way to do it. I am not showing you a heavy manual way. There could be one more way beyond this, where in 7-8 lines of code you will be able to finish it. Alright. So the videos that you are seeing on your Olympus, that could be one possible way. This could be one possible way. And in future, if you read some of the blogs where it's very simple, that also could be. So the way we are taking you through various, approaches is so that you are comfortable with almost everything. But I will still prefer have a simplistic version. I don't want you guys to write all manual stuff. Input the data, then concatenate. Fine, that is good to understand. But once you have got your understanding, don't do this. Come on to the industry side and write simple, straightforward codes. Okay. So here, the first thing that I am doing now is, I am saying this is my independent data, this is my target data. Now, first of all, I am creating empty lists, empty NumPy arrays, which are full of zeros. Okay. What should be the length of it? How many of them I want it? It should be exactly in size equivalent to our mask and original. So there is a folder called original, there is a folder called mask, and all the images are stored in these. So total number of images, how many I have, I want that many number of matrices. Inside that matrix, what should be the row and column width? Should be 128 cross 128. And do you want colored? I will say yes. So put it 3. And what I need let us say the data type should be float. So now I have got two arrays full of zeros of this dimension. So this is something like your HDF, where there are a lot of images of 128 cross 128 size. Okay. Moving on, the first thing that I have to do is, I have to give the index of my file. So what is the first index? Let us say index is 0 or -1, whatever is the original index. Next is where it is located. So I'll give my path. After that, I will import it. So from this particular path, read one image and load it in the form of image in a for loop. So I will go around this for loop for how many times? For the number of images that are present in the folder original. Okay. After that, I will say try if resizing this image using OpenCV to 128 cross 120. Okay. Normalize it. Next is your mask. So we have read the original image. Now I'm reading the mask part of it. In the mask, what you do is do the same concept. Read it, resize it, and normalize it. Perfect. And if you have exceptions, go back to the original part. This is what it means. So first try this. Still nothing is possible. Move ahead with the next one. Alright, but so far we did not get any exception, so it's okay. Any idea where we will get this exception? I hope you people got the second part. What do I mean by exceptions? For example, say there are 200 original images, that means your independent data, and there are 199 target images. What is going to happen? Or mask, I will say in this case. What's going to happen? This is not going to run for sure. It's going to give you error. If it gives an error, there's an exception. Go back and check the path. So it will show you that there is an exception E, and plus it will give us the path. As simple as that. This is the issue. This is the place where error is occurred. Yeah. Now moving on, if you look at the shape and size of X and Y, 200 images we have in total, 128 cross 128 cross RGB. Now we'll try to pull out one image. So IM.show, let us say first one. So this is how it looks like, and the same Y of it, when you print here, you get it like this. Good. This is it. If in case this was, you wouldn't have used try and except, for example. What else we can use? From the coding part. Let us say I don't want to use try and except. Then what I could have done? Can I say if, yeah, this particular image, so whatever I have downloaded, if image is equal to true, agreed? If it is true, do this. That's it. Correct or not? So if there is some value into it, definitely it's going to show you true. If it is true, enter. If it is not true, it will not even go ahead. Alright? So if you want, if anybody wants to simplify it, you can do this way. Okay. Good. So now moving on. Okay. Also was trying to show you just in case how the original image looked like. The original image was 375 cross 1242 cross 3. So that was the reason we make it to 128 cross 128 standard one. So if you observe, we are losing certain data if I'm not wrong here. So if you look at this image and if you look at this image, so what is the difference between both the images is, there is one car which is over here which has been cropped because of our thing, plus I think this particular ground is shown over here. Yeah, and this one if you observe has been shrunk, and there is a tree present here which is again chopped off. So please be careful. Try to find out the optimal shape and size of it and then choose 128 or 256 and all. Now you may ask me, fine, how do we come to it? What you can do is you can use the max function, something like that. Find out, use a for loop to go through each and every image and find out the maximum out of it. Which image is having maximum size and which image is having minimum size. Then you can go ahead and choose about it. That whether you will pad the minimum image or you will remove the stuff from the maximum image. Perfect. So just ignore this. I was just trying across. Got some black image. So ignore it. Now comes the concept of transferred learning. For our unit, basically, for our segmentation model, we are getting from this particular command. Alright. So it will take some time. So please be patient here. It will take some time and sometimes it might throw you errors. I'm not sure. For me, for the first time, yes, it threw me error. What I did was I restarted my kernel and from a fresh Python this thing, I did it. Or else you can use pip3 or you can use conda, whatever you like it. More or less, this should work. If it is not working on any of you, do let me know. Okay, we'll try to solve it up. So I'll ping you right away. If you want in the break part, you can just try down. So what are we getting now? So first of all, we are having a segmentation model. From there, we are importing unit. Okay. So what is a segmentation model? What we imported here. Okay. Next is from segmentation models, we are importing backbones. Now, this is a new concept to you guys. Backbone is a network which will run on the backside of your original network. So let us say in this case, my backbone is RESTnet, but my original network is a combination of unit and fully connected, for example. Yeah. So I'll show you. We'll see down the line how the architecture and all happens in this. Next is, I usually use both of them, so I have manually copied it, but we are not using Jacquard loss and IOU over here. So if I explain you what is Jacquard loss, is a type of loss function which we use in optimizers. And what is IOU? It's very simple. Let us say this is one image, and let us say this is one triangle. So you are designing one computer vision code where you are supposed to tag the object. So let us say the person who has designed the corpus has tagged it like this. All right. Okay. Okay. 1 minute. I tagged it too thick. It will not help me today. Let me tag it a little thinner. So let us say this is your triangle. And if I go back and tag it, change the color. Let us say the person who has designed it has tagged exactly, perfectly tagged it. Now, when you ran your algorithm, whatever you have designed onto it, let me change the color. So you tagged it like this. So your algorithm was able to tag this as the object. Yeah. Now, how do you find how good is your tagging? So for that, what we'll do is we will use the concept of intersection over union. That means, do people see that both of these boxes are intersecting at one point? Are you able to see those boxes? The intersection area divided by the whole union area. Correct? So let us say the intersection area is 90% and the whole union area was 120, for example. Because of this extra stuff, we can say it's more. In this case, we can say that yes, the model performance is designed by this one. So this is the accuracy score that we used for object detections. It's not in our this module, but yes, in next week's module you will be seeing this IOUs. Next, we are having Keras. So we are having input, convolution, and we are defining Keras model to get our to define our models. Next thing is you split your test and train data. As simple. The first thing that I'm doing here is I'm bringing RESTnet. Can I say there are certain time chances that you will get early outputs. Your output will not travel through all the layers. It will, but the first output that you get might be a very faster output. Agreed? Okay. So in that case, if I wanted, this could be a very complicated yet easy network to put it across this. So this will give me some kind of speed, I can say. Now tomorrow, if you don't like RESTnet 34, you can put RESTnet 52. Now what do you mean by RESTnet 34? You have 34 different deep layers. That's it. 52 means you have 52 deep layers, and then you are bypassing each other. Something like that. Alright. So my backbone is currently RESTnet. So what I'm going to do is whatever output unit gives me, it will propagate through my RESTnet. Alright, for my classification. To be very simple. If you don't want to use backbone, it's okay. I just gave you an option here that even you can do this rather than using a single network. Alright, so if you are not comfortable for now, you remove it. And later on, when you're comfortable with the unit, bring back the backbone concept and use it. Next thing is your training part of it. So whatever I have defined on RESTnet as my process input, I have to put my train and validation data on it. Agreed? We are saying that I do not want to manipulate the weights over here because it's a ready-made RESTnet 34 backbone network. Okay. Look at the shape of my training data 170, validation data 30, same 128, 128, 3. Now coming to your unit. So guys, this is the simplest way you can define it. It works perfectly. You might find various architectures where this goes pretty complex. Okay, I welcome that, no issues. But I'll say don't jump onto that immediately. Start with something simple and then move up. Right? So anyway, today's case study, we are getting an accuracy of only 54. So anyway, I'll ask you guys to improvise this. We will see to it how you guys can do it. All right. So the first thing that I'm now doing is giving my training shape of my first trained data, the shape of my first training image to n, storing it as n. And later on, I'm bringing that over here as my input shape to my unit. Okay. Now, after backbone, I'm saying this is my base model. What is my base model? Unit. From where I got unit? From segment models. What is segmentation models? That we downloaded live. Alright. So this is how the connection is coming. So from unit, I'm saying my backbone name is nothing but Inception version 3. So if you remember, Inception 1 was one of the architectures. And the weights that we are putting onto that is ImageNet weights. Okay, so this is my input I'm giving. Next one is my layer. So let us say I am defining my layer number 1. I'm convoluting it, 2-dimension convolution 2D. Next thing is I'm saying there are 3 filters. Each one is 1 cross 1. Okay, on what we are applying? On your input. Then comes my output. So this is my base model. So whatever model I'm using unit, so I'm using my unit onto my layer number 1. Alright. After that, layer number 2. So I'm again doing convolution, 3 kernels, 1 cross 1 each on our output channel. And finally, I'm implementing my Keras model. I'm saying bring out my Keras model on my input with respect to my L2. So I'm saying this is my input and this is what I'm supposed to bring it out. Name of the model that is going to run is nothing but your unit, your base model. Okay. And post that I'm printing the summary. So if you look at the summary, there are no parameters in input as of such. There are 12 parameters in output. Okay. And next thing is when we are bringing the unit, okay, using Inception V3, we are having a huge number of parameters here. All right. So if from these parameters, we can say that these many parameters are non-trainable, a very fixed version, and these parameters are trainable out of this. Okay. Now, if you ask me, fine, how did we get it? Since we are getting ready-made material, I have no control over this, which is a non-trainable, which is trainable. Since we are getting a ready-made part of it, right? So this is how the network, this is how the summary looks like. And if you want to look the summary of the base model, your base model is nothing but your unit. Just look at the size of the unit. It is very heavy. All right. So we cannot, it is impossible from our side to manually code this or manually construct it. So we do transfer them. Now coming to running our optimizers and defining them. So what are we doing is we are having binary cross entropy. We'll use Adam and I would use TF TensorFlow to do some calculations onto our accuracy function or metric function. So the first thing that I will do now is, if you remember our optimizer, what all we used to put? We used to put the name of it. Then we used to put a loss function. So what I've done now is we have defined our own loss function. You can use the standard ones also, no issues. But in this case, say just to show you guys it is possible to define it, we have done it. And second thing, we have defined our own dice coefficient. So this is something like your accuracy. So you remember I showed you IOU concept? Intersection over union. You know that the one which I showed you about. Multiply our predicted versus actual and divide it by the union of it, for example. Okay. And we'll use TF to reduce the sum. So if in case there is a huge amount, we'll try to reduce it and narrow down the stuff. Or else, even you can put, what do you say, how do we reduce decimals, guys? What is the function for decimals? If I have 3.2468, if I want to reduce it to 2, 3.24, what is the function we use? Round, exactly. Yeah, you can use a round function to do that. Or else, a simple version of TF will be TF dot reduce underscore sum. So we will come back to this special kind of accuracies and losses once we go down, we deep into this. So probably in 5th and 6th week, we'll come back and revisit this topic. But for now, just imagine this is your metric, and using the same thing, we are defining our loss. Okay. Now you may ask, okay, what is this epsilon? Epsilon is nothing but 10 power minus 7. Yeah. So this is my loss. This is my coefficient. I will call it whenever I compile my backpropagation. That's it. And finally, I'm fitting my model. All right. Onto and defining also my validation data, 100 epochs. It took a lot of time for me. On Collab, I think you guys will be pretty fast. Batch size I've taken, say, approximately 13. Use it more to be faster. And I think this all you people know. So if you observe here, instead of accuracy now, I'm having my dice coefficients. Right? So that is 54. And for validation, dice coefficient is 53.9. That is again 54 itself. So the model is stable, but I feel it is not that accurate. Yeah. So there could be one reason. The first reason is we have done 128 cross 128. First reason. Probably there is a lot of pixels which are shrunk. So what if I can increase the size of this? So please remember, try doing that and then report back what accuracy you got. Second reason could be, I will say, number of epochs that we are running. Yeah. So if you observe, there is not much change. I agree to that. But retry running more epochs. You should be able to move ahead. Okay. So this is it. So this is the problem I am giving you guys. Try to solve it up and let me know how much you are able to pull it up to. But do it only in Collab. Otherwise, on Jupyter, you have to wait a lot of time. Yeah. Even though it's showing 3 seconds and 15 milliseconds and all, but yes, ending up takes a lot of time. So till here, it might run fast. The last epoch will take a lot of time. Guys, have you seen that? I'm not sure if you have noticed on Jupyter. The last epoch now, the ETA will show, say, 0 seconds, but still it will be running and it will not come out of the execution loop. Any idea of what is happening here? Observe it. If you have not observed it, try observing that. Okay. So there is some delay probably, I feel. Even though we are getting a number over here, but yeah, there could be a delay. Now moving on, or else one more thing, just in case if anybody is very much interested in timing it, there is a function called TQDM. I've shown you guys this earlier also. You can use TQDM here. TQDM is a very effective way of noting your time. You come to know how much time your epoch took to run. Finally, we are predicting it. So when I run my prediction model, so we'll come back to saving the weights later. So when I'm doing my prediction on our model, so whatever I get as my, let us say I printed the original image and this is the predicted image. If you observe and if your intention here is to just to find road, then yes, you can say that you have got a very good color. But the problem I see here is there are some vehicles on the road, and because of our low accuracy, even they are of similar color. So this is going to be a problem. So let us say if you are running car onto this, Google car is running this, it will not be able to identify this. It's going to go and bang, basically. Yeah. So try to improvise it and see if we can. All right. Now coming to an important concept of storing your weights. I think I have done this already. Something new I'm showing you guys as JSON. So you have 4 options available: JobLib, Pickle, JSON, and HDF. You can use any of these to store the weights so that tomorrow when you open the code again, you need not to run this. You can directly load your model or your weights directly from this. So all you need to do is, next time when you run this code, you need to say, let us say, new underscore model. And when you do that, what you can do is, you can say, h5 dot loads or load, can be loads or load, just check it out. And in that, you can give the name of the file, which is nothing but our model.h5. Right? So this is going to load the complete findings onto new model. And from next time you can say new underscore model dot predict, and inside that whatever is your image you can give. That's all. Alright, so that's the reason we use this, so you don't have to keep retraining your data. So this was a simplistic version of industry-based unit. Let's move on to a new type of network, and we'll try to reduce some of the computations out of our convolution and all. Let's see if I can reduce the number of computations. So to do that, now my first question is, say you have a phone, for example, and in this phone, say you have clicked a picture, and the functionality in your phone is it can detect certain objects. So let us say first of all it detects your face, and from now every picture you take it's going to detect it is you. Nowadays almost every phone has it. Yeah. Now first question is, how do you think what type of algorithm will be running in the phone? So please make sure that this phone is having some kind of RAM, some kind of storage, and some kind of, say, I will say graphics card or whatever you call it, right? So how exactly this image processing is happening here? Any idea? Do you think we'll be able to load VGG and all onto this? Why? Because how many parameters were there in VGG? If I'm not wrong, it was around 60 million parameters, right? So even if I pickle it, or even if I try to load, basically take the weights and make it a pickle file or some kind of function that from tomorrow when you just run it, it is going to run, right? It is not possible to have it on a handheld device. Now, let's see. Still, these people that do it. So now, there is a need of an algorithm, okay, which is a lightweight of convolution. It is a convolution, but could be a lighter weight. So let's try to reduce the. So let us say if I reduce the number of parameters by say 95%, then you think the phone will be capable enough to load it up? I will say yes. Correct. So let's see. So this gives us a need of a new network. So we will define it as mobile net. The compressed version or a very simple version of our complex models is this. Now, if somebody can help me out, say I don't want to show you screenshots. So what I'm doing now is, let's try to build this up in a very, 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 so this is something like revisiting our concept of, how do you say, revisiting the concept of convolution, plus you will derive the mobile network. Okay. So say this is my image, and this is an M cross N image. Yeah, 3 channel M cross N image. So just imagine that these are the number of channels in total. Okay. Now, what do we do onto that? We multiply it with some kind of filters. Correct? So let's try to define the shape and size of all of these. So let us say you have got image height of say df and image width of df, and then you have got some kind of channels here which are nothing but m. Is everybody okay with this figure? This is how an image looks like in Python. Now let us say this is a filter. So I define say dk cross dk as a filter size. It's always a squared part of it. Yeah. Now, what will be my output? So when I take this through multiple layers of convolution, max pooling and all, let us say my output looks something like this. Say diminished version, but I will have a lot of feature maps. Agreed? So let me join them up. 1, 2, 3. Alright. So let us say the size of this feature map is dg cross n. Alright, this is what we do in convolution. Everybody agrees? So can I write here? Convolution happens here, and at the end we are getting n filters out of it. Yeah, so when you put n filters onto that, at the end of the day, we are getting dg cross dg cross n, right? Total number of feature maps. It is there in our week 1 PPT. Please store it. Have a look at it once. Now, if I ask you guys, so let's build some equation here. If I ask you guys, question? No. Okay. If I ask you guys, what does one convolution multiplication look like? Can somebody tell me? One multiplication looks like dk square, dk into dk cross m times. Agreed? Okay. How many multiplications you are going to do with respect to total number of kernels? How do we determine that? dg square, dg into dg square into what? dk square, total number of the dimension of my kernels, into total number of filters that I am having. Agreed? So this is how one convolution works out. Look at it, how heavy it would be. So if the size of my dimension is 1024, just imagine how heavy it's going to be. Agreed? So this is where our mobiles and handheld devices will not perform good, or they will become little slow because of this. So please remember, convolution is nothing but multiplication. Yeah, I will say multiplication is heavy. Then what could be light? If I want a lighter version of it, what mathematical function should I put? Guys, think about it. If I am saying multiplication is pretty heavy for me, there should be some mathematical function which should be a little lighter version of this. Okay. My question through here is, multiplications are heavy. Do you agree with this? This is a heavy task. Do you agree? If the image size is in megapixels, do you think this is going to take, this is going to be immediate? No. So now, what if I replace our mathematical function with something else? Can I say plus could be one option? Agreed? If I have additions, if I want to add 1024 cross 1024, I know you will say, okay, fine, it's one cycle only, I agree to it. But 1024 square into say 650, whatever, 612 square, this becomes still heavy, the number, the total number of parameters and all this part. Yeah. So what if I can say that, okay, let me introduce something into plus, and what if we are able to reduce the size of it? So for this reason, what we'll do is, we will come to a new concept called depth-wise separable convolutions. Depth. This is a convolution only, no change. But the way we do it will alter it. Depth-wise separable convolutions. Okay. Now let's see. Now this thing is divided into two steps. So the step, we will put step number 1. So the first step is called depth-wise convolution. Depth-wise convolution. So what if now I have DF and DF? So this is the dimension of my thing, and M is number of channels I'm having. Okay, and what I'm going to do is, my ultimate solution will be, so when I convolute it, what's going to happen? I'm going to get, convolution will remain same. There is no change into it. So I'm going to get some N images over here, or filter maps over here, something like this. But the only change I will do is, I have not defined my filter yet. So if I define my filter right away, then you guys will come to know what is the difference in depth. So let us say my filter size is dk cross dk, for example. Okay, and I am saying that I will, df and dk will be perfectly same. The shape of these two will be perfectly same. So when I get my output, it will be dg cross dg cross m. Did you get it? I have m channels. So how many times I have to go through? If I'm saying the size of df and dk is almost similar, that means I'm taking the whole depth as one filter, I have to just run 3 times. Agreed? So if I come to the math now, so whatever bracket we did in the above one, if I do the math for this, if you ask me what is one multiplication look like, one multiplication will look like dk square. Agreed? Multiplication per channel. So if I have a multiplication per channel, how it is going to look like? It is going to look like dg square, d is this one, okay, into dk square. Alright? And if I ask you guys multiplication per kernel, yeah, so if you take one particular kernel, how is it going to look like? It is going to be dg square into dk square into total is m. So what we got here, m cross n, now we are having m, basically. Alright? So I can say this particular thing will get multiplied with one whole channel. This is what it means. Did we get this? We tried to eliminate one larger value called m here. This is what is the aim of doing depth-wise. Okay. Now let's try to do the second one, which is called point-wise. Now comes the second one. So now when we build the second one, then you'll get the whole picture. You'll get why are we doing this. So let me rebuild our image. Now what will be my image? I said there are two steps for this. So if the output of step 1 is this will go as an input to my step 2. So let me not redraw it. Let us say this is my input image. Okay. Now what am I supposed to get out of this? I am supposed to get the same stuff out of it, which is dg. I will not rename it, otherwise you will get confused. What is dg and dk and all these things. Let us say this is our output we are expecting. dg cross dg cross n. So now I am expecting n number of output. Now I am not saying that one filter per channel. I am not saying that. Okay. Did we get it? Now what I am doing is I will redefine my filter. So here what we did, we made one channel. Now what I will do is I will have a 1 cross 1 filter, and it will go to how many channels? It will go to all m of my channels. This is how my filters will look like. This is m. Understood? 1 cross 1 filter only. But we have to make m number of filters. So when I do these two together, I am going to get dg cross m. Sorry, n. Please be careful. There is no more n here. N. Okay. Now if you ask me what is one multiplication look like here. So let us do. So this is called point-wise. Point-wise. What is the next parameter? Multiplication. Yeah. So what it will be? dg square into 1 cross m. Perfect. And now if I ask you what will be my final multiplication, you guys will say n into this number, dg square into n. Agreed? Yes. Simple. Now as I said, this is synchronous process. This is a sequential process. Sequential means what? So if I want to find out my total computation, how should I do it now? I will say total is equal to depth-wise plus point-wise. What is my depth-wise? This one. dg square into dk square into m plus m into n into dg square. Agreed? Now what are we going to do? We'll take out the commons. What is commons? Can I say m into dg square is common in both of them? So I'll pull it out. M dg square. What am I left with? dk square plus n. Everybody is clear till now? Now we will see how we will compare this computation. So can I say this is the answer of my depth-wise separable convolution, and this is the answer of my total convolution, right? Yeah. Now if I want to compare these two, what should I do? Can I divide them? I'll take a percentage. This divide by this. See, it's like you want to say that okay, my current say for example salary is X, yeah, and let us say you change your job and you got a salary X and your current salary was Y. So how do you do it? This by this, you will get a percentage of rise. Very simple. So in this case, what I will do is I'll just divide this by this. So we'll just see the computation here. So m dg square dk square plus n. So let's do that. We'll have m. 1 minute. So I will put numerator. I will put depth-wise. Denominator I will put whole convolution. Okay. So whole convolution is nothing but dg square into dk square into m into n. Agreed? And on the top it will be m into dg square whole multiplied by dk square plus n. Right? Let us check whether I have written correctly or we misplaced it. M into dg square dk square plus n. Perfect. Now we'll start cancelling. So can I cancel dg? Yes. Can I cancel m? Yes. What am I left with? dk square plus n divided by dk square into n. If you separate the LCM, what am I going to get? Can I say I'll get 1 upon n plus n upon... Now can I say the equation which was full of multiplication, now we have kind of put addition onto it. So I'm not saying we have transformed it, it is just a percentage, but yes, we have got some addition. Now you take an example. Now you take an example saying that the total number of output you get is say 1024, for example. Yeah, you have this many number of filter maps, and say your input or your filter dimension say was, usually we use 3 cross 3, right? So let's say put 3. Okay, how much you got? 0.1. So the answer that I got is 0.1. Now can somebody explain me what does this mean? The numerator is 10% of the denominator. So can I say I have reduced my computation by 90% by following these steps? This is one way of developing your network. So tomorrow when you guys go into industry, say 5-6 years of only computer vision experience, then even you will be, it is possible from your side to build up your own network in a deep use. It's all about the way you put the convolutions here, and also about matching the sizes. If you follow these rules, definitely you can do mix match of anything and try to find the solution. Right? So now why did I do this in detail is because I did not find a very good solution to this thinking. That's the reason I went deep. This PPT is good, but I will not say it's ultimate. So yes, now if you look at these things, you will perfectly get it what I was talking. Okay. Yeah. So this is what is the final slide. You have to. This is what we did. Finally, we got a similar. See what happens is if I directly start showing you these things, these are not very simple things to visualize, to be very frank. So that's the reason I went a little bit on scratch. Now when I deliver this PPT, it should be good. Okay, good. So we have depth-wise, same concept, point-wise, same concept. Step 1, step 2, and then finally find the computation power. So this is how a mobile net possibly looks like. So if you want to convert, say, if you are inputting 224 cross 224 cross 3 image, this is how you have to go ahead and do this. Yeah. It's now coming to something very interesting. So this is what we do in industry. Yeah. So now whatever you are going to do, you are going to implement it. If you are working on computer vision, yes, you will use these algorithms very often. So now comes the real CV. What is faster parsing now? If you guys are okay, shall I delete this, or we are not referring this back, right? Question to all of you is, we just proved that we can make convolution networks faster. I just proved it. We can do the same task, 100% same task to be done in 10% of computation power. Now, what if I'm still not happy with mobile? What if I'm still say, okay, fine, I still want to do faster part of it. Or else, let us put this way. Let us say there is an image like this, okay? And say there is a person in there. Eyes, nose, hair, neck, shoulder, arms. Doesn't matter. It's not that great. Yeah. Okay, some person like this, yeah. Now, my intention is to, if my device is supposed to focus on the face, so my convolution neural network algorithm should give me a beautiful box around the face. Yeah. Also, using some kind of generic stuff, I can say that, what if I draw a box like this? Don't you think the box is going to cover the face of the person anyway? Yes. I don't want to do that. I don't want my algorithm to go spread like this. I want my algorithm to be very precise. Where is the face of the person? And just to tag only the face, not the generic one. Yeah. Why do we need it? There could be multiple applications where you need to check who's coming in, who's coming out, or for facial detection, or for any other thing. Yeah. So in this case, my convolution neural network will work good definitely. But can somebody tell me how many, first of all, we can detect it's a face using our classification so far what we have done. How should I put a bracket around it? I have to put a line. Or else, if to show you guys what I mean, I hope you would have seen this flying around. If you see this is a very simple stuff where you have got a lot of people and then they are tagging. Yeah. So how should I get this line? How should I get these lines? So classifier will find out that yes, there is one face. How should I find out? How should I draw that box? So one answer is segmentation. Good. And then we can say that on an average, for a human being, this is the distance on both the sides, and we'll imagine and put a imaginary line. So I will say, how do you define that? I will say point and next point. So what I will do now is think this way. Yeah. Let us say I have this image. So what I will do is, in a very simple way, I will randomly, first of all, I will choose one filter size. Okay. Could be any size. Sorry, not filter, a box. And I will start running this box all over the image, like this. Randomly, I will put this box over the image. Okay. Now what I will do is, when my filter box goes and sits on an image, I know the dimension of the filter. So I know what part of the image I'm talking about right now. So from which cell to which cell I'm talking about. So I have an idea of the geography of the image. Now what I do is, I take this as an output feature map of your convolution. And I input this to a fully connected neural network to detect. I will tell my fully connected, check if are you able to find a face in this? If it says 1, yes, I will say that whatever I tagged, yes, this is a simple. All of these will get FCNN output as zeros. These all will get FCNN output as 1. Agreed? Simple? Yeah, but there is one challenge here. If anybody is able to spot that challenge. How many of these tools generate? Don't know, right? The normal RC in convolution neural network says it will randomly put 2000 of these windows in the image. Okay? It says an image can be scanned by putting these 2000 windows. So the challenge here is for us, first of all, to maintain these dimensions of 2000 windows, locations. Second is to get it passed through FCNs. But yes, it works very well. So apart from the 3 solutions that we got, 2 solutions we got, we can do this one also. It is called regional convolution neural. Okay. So I will just give you an idea because for the three content, we are not going deep into it, but it will make your videos a little easier. So, yeah, just have a look at RC. So what we have done here is this is my input image. We are randomly putting approximately 2000 proposed regions. We are saying that these region could be, there could be an object in this region. Yeah. Now, it is not necessary that when you take a region, pass it through CNN and fully connected, you are going to say you are going to get an image object out. Not necessary. Some of them will fail, but yes, the ones which have passed through, the only good thing here is we will know the location where to put the box. That's it. Simple. This is called convolution. Okay. So I think you are now week 4 videos. This is what is the base of it. Okay. Let us talk quickly on fast RCA. Now, we found out the problem. Problem is time. Now, I am very eager to use this. How should I improvise on time? Can somebody think about it? How should I improvise here? What is time killing stuff over here? This 2000 is a time killing. How should I improvise on this? So the fast RCNN consists of somewhat of your answer also. So let me show you one fast RCNN. What we are doing now is, instead of increasing the size of the total filters, I am saying we will increase the length of the filter. So I can say I will have one filter like this, another filter is given by the red, and third filter could be something like this, which covers the whole image. Now what I do is I have 3 zones. People agree with that? I have knowledge of 3 zones. What I will do, I will take one of the zones, I will put it through convolutions. First convolution, I will divide it into 2 parts. One will be my softmax, which will decide whether there is a face or not. Another one, so if there is a face, yes, another one will give me the dimension of this line that I made. Got it? So regressor is to find the x and y dimension. Softmax will be used to get the face. So if both of them are, if this is positive, definitely put it together and say that draw a circle or draw a line or a square around this particular region because we have detected softmax output, that is face. So put a small comment here that face detected the line. Correct? So the larger ones that you see here, the larger filters that you see here are nothing but ROI, region of interest. Okay. Still I am not happy. First of all, one question to all of you. Now, do I say my speed is increased? I would say yes, because I don't have to now do 2000 computations. I just have to take 3 different filter computations. Still, if I'm not happy with it, if I want to increase the size of it, can I do something further in the same architecture here? Let me give it away. What if I want to still improve something? So what I will do is, rather than these 2, regressor and the classifier being in parallel, like this, you think this parallel? Yes. Instead of being parallel, what I will do is, I'll make them sequential. So I will say, this is my image, this is my convolution layers, this is my feature maps. These are nothing but the squares that we have proposed. Go and put it into one variable called proposal, and when you do this, classify it. Once you classify it, if there is a correct output, pull that out. So yes, there is not much difference between this and this, but the only thing is here we are not having parallel process, we are having a synchronous process. The same proposals are going in for clustering. So computationally, this will be little faster as compared to this. And if we look at the standard timings that they have measured and published papers onto, CNN, we have no depend on the application. RCNN takes 40 to 50 seconds for one image to be classified. RCNN, fast RCNN takes 2 seconds. Faster RCNN takes. Yeah. So we'll see down the line. So I know some of you will be confused how this is. We'll see down the line. But at least go to the videos that will make some clarity, and post that we'll check on how this works. So If we now felt this was complex KNN, just imagine how complex this is going to be. And the next week is also going to be little. Coding now I feel is going to be out of bounds.
So now we are going to see that what is machine learning, right? So if you don't have idea about what is machine learning is basically a subset of artificial intelligence, right? And that allows the system to automatically learn and improve from experience without being explicitly programmed, right? So what does that mean? So basically after you make your model, right, so what you need to do, you just need to check your model is working perfectly or not, how your model is going to predict. If you see your model is predicting nicely, for that you don't need to go for like doing the programming from the scratch every time. What you need to do, you need to just provide the new data to your model just to predict. So this is actually the machine learning all about. So we just need to train our model, and after the new data we got, we just need to test our model, right? So types of the, let's see what are the type we have in machine learning. But before that, let's have a look at what is the difference between traditional and machine learning, right? So in the traditional programming, if you want to predict your data every time, you need to code, right? You need to like write the code from the scratch every time. But for the machine learning, your model will do everything for you. So after you make your model, after you know your model is actually working well with the new data, so you don't need to write program each and every time. You just need to provide the new data to your model, and your model will do all the work for you. So this is why machine learning is actually getting the popularity in days, like respect to traditional programming, right? Okay, now we will see what are the type of machine learning we have. We have supervised learning, we have unsupervised learning, we have reinforcement learning. So what is supervised learning? Supervised learning is basically your model will learn under a supervisor, right? So basically when your model is learning, that time there will be a supervisor who will say your model, no, you are not right. So this can be an option. For that you are wrong, right? But on the unsupervised learning, your model need to learn from itself. There will be no supervisor. So in supervised learning, we work with the label data, when your data is labeled, okay? And in the unsupervised learning, your data should not be labeled, right? Your model needs to understand by itself what is the group of the data, right? This is the difference between supervised and the unsupervised learning. And the reinforcement learning is basically like if your model is going to predict wrong, you are going to give a penalty for that. And if your model is predicting right, you are going to give a reward. So these are the basic 3 types of machine learning algorithms we have. And in these types, we have several types of algorithm, right? So today we will work with the unsupervised learning, right? So now comes the recommendation engine. So what is recommendation engine? But before that, I got some of the, okay. So I got a question from Akalpita that it will be better if we can have a Q&A after the lecture. Yeah, sure. We can do that, but okay. Okay, so I got a question from Shikhulali that how we train a model and why do we have to split our data set. So basically we split our data set because we don't want to provide our machine the full data. Your machine doesn't have idea about the test data set, and in that what your machine will do, your machine will actually learn from the trained data set, and the test data set will be unknown for the like your model. Okay. I got a question from Anana. Is machine learning related to data science? Yes, Anana. Data science is basically like machine learning is the like subset of data science, right? So when I just say the life cycle of data science, you can see in the last, when we need to build our model, that time we need machine learning algorithms, right? Okay. So what is a recommendation engine? Recommendation engine is like a recommender system, predicts the choice of the users, right, and helps user to discover new products or content according to their past like the past data they have used. And if it's like system is not going to say this is can be suppose we are all familiar with Amazon recommendation system, right? So what we used to get, suppose let me give you an example, you are going to buy a mobile phone, right? So that time the Amazon is going to say maybe the mobile cover or the headphone that actually connected with your phone, right? So this can be your choice, right? This is how you don't need to go for explicitly, you don't need to go for searching the other things. Automatically it comes under that you may like in the portion, right? This is how actually recommendation system works. right? So the recommendation system actually helps the user like experience, like with the shopping experience, and it helps the company to boost their sales as well, right? So this is actually the like part of product recommendation system, you can say. So now we will see what types of a recommendation system we have. Before that, let's see what are the application, what are companies they are using a recommendation system. Like LinkedIn, Netflix and Instagram, I just give the some of the like application and which are the company actually using, and there are multiple company they are using recommendation system right now. Okay, so LinkedIn's is actually job matching algorithm has improved the performance by 50% using recommendation system. Okay, and Netflix values recommendation system at $500 million to the company. So we all quite used to with Netflix or Amazon Prime videos, right? After you actually search for any movie, after you search for any movie, it will recommend that these movies also are there in the list, maybe you can like them as well. So this is how recommendation system works. And for the Instagram switches to use algorithmic feed, right? So it's something that there are some you're like, let me give you an example. Suppose you go for some advertisement, right? In that case, you saw some feed, and according to your feed is going to say these are the advertisement we have, and you can see maybe these products you can like, right? This is how actually recommendation system are using each and every company to boost their sales. Now we will see what types of a recommendation system we have. We have user based filtering recommendation system and content based filtering recommendation system. So let's have a look what are these two actually stands for, and take a like as a use case how these are going to work, right? Okay. So user-based filtering system is building a model from users' past behavior as well as the similar decision made by the other users, right? Suppose I saw a movie and the other person also saw a same movie. So basically there can be a reason, like there can be a reason that we both have a same choice. So in that case, the machine actually will calculate that what is the similar taste maybe we have, and according to that the machine is going to give you a recommendation, maybe this movies you can like, right? So this is how actually user based filtering works. And this model is okay, so this model is basically based on the users similarity, right? Not the movie what movies have, right? So it's basically used on the like user similarity. Okay, so this model is then used to predict its item that they may have a interested in, right? So what we say that this two suppose the two people are actually like watching the same movies, and that time the model or the recommendation system can think that maybe this two can be a similar choice, and whatever the movies they are watching, that can be a similar choices for them, right? This is how user based filtering are working. Okay, so now see what is content based filtering. Content based filtering is not at all user like what other user are actually watching. So what actually it does, suppose you have watched some movies, so it will go for the content for that movie, the heroes of the movie or the director, or what type of a movie, maybe it's a horror movie, maybe it's an anime movie, right? So it will go for other ratings we have for the movie, so it will go for the other like other feature or the hidden features of the movies, right? So this is how content based filtering are working. So these are the two filters actually works for the recommendation system, and these are the two main difference between them. Okay, now comes Netflix. How actually Netflix works, which system they are using, right? So in Netflix they are using hybrid recommendation system. They are using both the concept UBCF and CBF, right? The user based collaborative filter and the content based collaborative filter. So these are the two, they are actually combining two recommendation system to actually make a more effective recommendation systems, right? Okay, so yeah, we all know that Netflix and Amazon Prime actually give us a maybe you can like these movies based on the our past choices, right? This is how actually they are using hybrid systems. So now let's have a look at user based collaborative system filtering, right? So basically this algorithm finds a large group of users and also searches user with a similar taste. The same thing I have told, right? And algorithm looks at different things. They like the like and combination them to create a ranked list of suggestions. Okay, and what are the someone asked me that what are the algorithm we can use for UBCF or the recommendation system. We are going to use for K nearest neighbor, that is a unsupervised learning algorithm, like machine learning algorithm, and we can use Pearson correlation. These two we can use to make our own recommendation systems, right, when it's come for user based collaborative filtering. Okay, now comes like let's have a use case, like how can you do that. Suppose we have a girl called Lisa, right? Lisa just watched a movie Joker. We all are quite familiar with the Joker movie, right? So if you guys know about Joker, just let me know in the comment section that yes, you all know about Joker. Okay, so I got a question from Shikulavi, that what do you mean when you refer to hidden features of the item? Will data part of the features on the dataset or will be unknown feature? So basically hidden feature I want to mean by, so suppose you have the data, right, but when you have the data but you don't know how your data actually behaves, right? So suppose I have a data of online transactions, but I don't know how this data behaves when it comes to fraud transaction. So getting those hidden feature, that maybe there will be an outlier, maybe there will be some spread of the data will be changed when the actually your transaction is a fraud transaction. This is actually want to mean by hidden pattern. Okay, fine. So fine, I got a question from Abdullah. Yes, please provide the notebook of, yeah, you will get the notebook and the presentation as well in the Great Learning Academy, and you just need to go and register for the course and you will get all the material over there. Okay, fine. Okay, I got a question from Raghavendra, ma'am. Is it necessary to learn data structure and programming for every language? So basically data structure is a part, and it's a basic part when you start programming. So you have to have a basic idea about the data structure, not maybe the competitive programming data structure, but the basic idea about data structure you need to have. Okay, so yes, I got a question from Vikas that how much time it takes to learn machine learning. So taking time for machine learning, it's depending upon you. If you want to know the mathematics behind all the algorithm, it will take some time. But if you want to go for only the coding part, it will not take a long time, right? Ajay, are we going to analyze some data in the video? Yes, we are going to analyze some of the data in the video as well. Okay. Okay. Aman is, will see Python code for building recommendation system. Yes, we will make a recommendation system in Python notebook. Okay. Okay. So I got a question from Vanita that KNN is a supervised algorithm. I mean K nearest neighbor, right? So in that case, we actually use the unsupervised technique as well. Okay, so for her, that the recommendation system comes under which category? So basically it's come under unsupervised learning part. Okay, fine. So let's go back to the presentation. So Lisa is just watching the Joker movie, right? So let's see how the recommendation system engine works, recommends her the next movie, right? So we have actually they generate a list by machine of user who have seen the following movies. Suppose Sam, Joy and Ratan, these four actually watched Joker. Okay, but for Dave, maybe he didn't like watch the Joker, but again the machine is maybe thought that it can be a similar one they actually saw their like previous movie, right? So these four they have listed down. Now let's see how can you like these are the four movies they all four already have seen. So under these four, which one can be recommended by the system, like by the system for the Lisa for the next movie, right? Okay, so in that case you can see we have seen that Sam, Jay and Ratan, these three people actually saw Joker. Okay, for Lisa saw Joker, right? But she didn't see any of the other three movie, right? The Book of the Life or Avengers or the other one, right? So now let's see like what can be the next movie for Lisa. So in that case, we are going to go for the voting, right? So list of Lisa's watch movie, find the same taste user. From the user similarity, found the probable movie of Lisa. Like suppose it can be Avengers, which gets more vote, so it gets recommended for Lisa. So you can say we get almost two votes for Avenger, and we get one vote for the Book of Life and one vote for the other one, right? So this is how the recommendation system thought that Avenger can be the next movie for Lisa, she can watch, right? And she will like it. So this is how actually user based collaborating filter are working. So just let me know if you have any doubt in that. Okay, so now let's come that okay, so what actually it does for the contents as central entities work with the data that the user provides either explicitly or implicitly, right? Based on the data the suggestion are given to the user, engine's accuracy increases with more input given to it. So when it has a more input, your system will become more effective, right? So if you don't have much data, your system will not working or performing well with that, right? Now comes the content based filtering. Let's have the same example with the Lisa. So Lisa have watched Joker, then see how can a recommendation system is going to use the CVF method to recommend her the next movie, right? So they actually generate a list of the features like actors, directors, theme or story or the characters, right? So now this part they are actually going to looking for the internal part of the movies, right? Okay, so here you can see we are going to compare columns for of each movies with the column of the movie Joker. So you can see we are going to see hero, horror movie, theme, IMDb rating 8 plus and comedy, right? So Joker has a hero, obviously it's not horror, it has theme. IMDb rating is most probably not 8 plus, I just need to check, I'm not sure about that, and it's not a comedy, right? So in that case, what are the same similarity we have in the Book of Light, right? It's have a hero, horror no, theme yes, IMDb rating is yes, but comedy yes, right? So we got most of the similarities with the Book of Life. So the most common movie is the Book of Life, so the machine is actually going to say this can be your next recommended movie. Okay, now we will go for demo of movie recommendation system. So I told you we are going to use Google Collab, and I will show you how can you use Google Collab for that, right? So what do you need to do? You just need to go to your favorite browser and just you need to write Google Collab, right? Okay, so you can see I got the first link for Google Collab and you just need to click on that, right? I'm going to click on that. Okay, so lastly what you need to do, you just need to click on new notebook. That's all you need to do when you are going to use Google Colab for your any notebook. So someone was asking that he has the Mac and he doesn't know how to install Python, right? In that case you can go for Google Colab, you don't need to go for any installation and you directly can use start writing your code in that. So yes, okay. So I got a question from Easy, that was the easiest way to learn Python. Easy, basically Python is very easy language. There is nothing easiest way to learn Python. If you start like learning Python, you will love it. Yes. Okay. Okay, so you see I got our notebook. So I have made my notebook previously. So now we are going to do the recommendation, basically a movie recommendation system using machine learning. So already I got my data from Kaggle and I have uploaded them to Dropbox. So I have two data set. One is ratings.csv, one is movies.csv data set. So all the data set you will get in the Kaggle itself. Otherwise you will get the notebook as well, and you don't need to go for downloading the data directly. It will fetch the data from Dropbox. So I have used wget function, so it will directly, and I need to give the path of the data set, right? So from that it will directly fetch the data set from the Dropbox. So let me just execute that. Okay, Now you can see, I just want to see my ratings.csv, what we have in our data set, right? So in that we are going to use pandas data frame. This is a library of Python. Well, like using Python, using pandas, you can go for many data mining course, like data mining techniques. So pandas is one of the most popular library in Python, you can say. Okay, so in that case we are going to use read csv function to read ratings.csv, right? So I got a question from Nikhil. This coding is done in Jupyter Notebook. Yeah, you can do the same thing in Jupyter Notebook as well. For me, it's quite handy to use Google Colab. So it's up to you which ID you want to go for, right? So you can see, I'm going to just store in ratings detail variable to the ratings csv file, right? So you can see I use .head function. It will return the first 5 rows of your data. So I got user id, movie id, rating and timestamp. Okay, so I have the movie id, I have rating, that how much rating the user gave, and the user id for the respective user, right? So now I am going to take the movies.csv from the Dropbox itself. So it will fetch the data same way. Yes, you can see it's already fetched the data. Now I will do the same thing. So I am going to use movie details in the variable name, and I will store the movies.csv on that variable, and with the head I will get the first 5 row from that. So I have movie id, I have title, I have genres for each of the movies, right? Now I'm going to, like, as I have the both data, let's have a look at the what are the shape we have for each of the data set. So I have ratings dot csv already in the ratings details, right? So if you want to see the shape of the data set, what you will do, you just need to write dot shape function, right? Yes, so you can see I have 100836 columns and 4 rows. Okay, okay. So I got a question from Ria. Can you please explain wget method? So we use wget to fetch a data from any like suppose you have a link, the data link. So we use wget to fetch that data from that link. It will directly fetch that. It's a command line command, you can say. Okay, so I got a question from Ankit. What is the use of Panda? So Panda is basically used for data mining techniques. If you want to manipulate your data, if you want to clean your data, or if you want to learn your data easily, you can go for Panda. So Panda is one of the most important library in Python, right? Okay. Now let's see. We already got the shape of the rating details, and we just want to see the shape of the movie details, right? Yes. So yes, we have 9742 columns and 9742 rows and 3 columns, right? Okay. So this is the shape of our data set, and now we are going to use dot describe function to have a good understanding of our data. Okay, so dot describe is basically will return you all the basic statistic part of your data, right? So dot describe. Yes, you can see I got this, and if I want to see this in a data frame, that is also available. Yeah, so I got count, the mean for each of the column, standard deviation for each of the column, 25%, 25 percentile, 50 percentile, 75 percentile, and the max. We got these are the basic statistic for our state data set, right? Now we are going to see the same for the movie data set. Okay, so if you want to add some new code in your notebook, you just need to click on the plus sign on the Google Colab, right? So movies, we have movies details dot describe. Okay, so I got an error. Okay, it's movie details, right? Okay, I got a question from Prashant that from where we get the get this data which you are using. You will get this data from Kaggle, Prasant. You don't need to go for any other. Well, we all use the data from the Kaggle. Okay. From Gulam Murtaja, yes. Can you give this data set? Yeah, you will get the data set. You just need to go to Great Learning Academy and you just need to go for registering the same course, and you will get all the presentation and the notebook as well. That is also free of cost. Yes. So yeah, we see the describe for the movies details as well. So we have a movie ID and we have this. You can see, right? These are the describe we already got for this. Okay, so yeah, let me just execute this once. Okay, so why am this? Yes, now we are going to merge the data set. We have the ratings, we have the movie details. Now we are want to use merge the data set, two data set. But how can you merge that? To merging the data set, you need to go for dot merge function. We use pandas dot merge function to merge two different CSV file, right? So we have ratings details, we have movie details, right? But we want to merge those two data sets on the basis of which column, right? So on the basis of movie ID, we want to actually merge those. We want to concat, you can say. We want to actually merge those data set, right? So basis of movie ID. So movie ID will be our basic primary key for this data set when we are going to merge them, right? Okay. So yes, you can see we got so if you want to get the last 5 rows from your data set, we are going to use dot tail function for that, right? So basically, to get the last 5 rows of your data set, you actually need to use dot tail, and getting the first 5 rows from your data set, you need to use dot head, right? Okay, so already we have merged our data, right? We have in our data set, we have user ID, we have movie ID, we have rating, we have timestamp, we have the title of the movie, and we have the genres of the movie, right? Now what we need to do, we just need to change our timestamp into the proper date time. So how can you do that? So doing that, we need to use date time function or date time library, and we can just say that pd dot, that is also part of pandas, pd dot to date time, and you need to provide the data set of the which column you need to change. So I want to change my timestamp column to the date time, right? So I'm providing that data set of timestamp column, right? Okay, so let me just execute that. Okay, now let's see what we have in the data, like what is the shape now we have in our data set, right? So as we merge our data, we actually add a one date time column as well. So now we have almost 100836 like rows and 7 columns. Okay. So I got a question from Prashant that when do we use scikit-learn in this scenario? Basically, scikit-learn we use to split our data set to make the model from the make model and machine learning. That's all the predefined algorithm is there in scikit-learn. Okay. Fine. Okay. Avinash is asking why can't we use concatenate? So yeah, if you want, you can use concatenate. I use merge function. It's up to you which one you want to go for. Okay, fine. So let's see. Now we want to see what are the non-unique. What are the actually using n unique. So it will actually return you how many unique data you have. Maybe we have the same user for just to rate the different movie, or for that, right? Just I want to see how many unique customers we have in our data set, right? So let me just use, and for that we use dot n unique function, right? So you can see for user ID I have 610, for movie ID I have 9724, but our data is more than that, so we have repetitive data as well. So maybe our one user can see lots of movies, so they are going to rate for that movies as well, right? Okay, so let's see the describe of the dataset, merge dataset. What we have for the count, we have 100836. We see that we have mean value, standard deviation, 25 percentile and 50 percentile and 75 percentile, right? Now what we need to do, now this data manipulation part came, right? So now what we need to do, we need to group by our data to see the average rating for each movie. Now I want to see, suppose I have Joker movie, right? I want to see what is the average rating we have in our data set for that particular movie. So how can you do that? So I actually take a variable. In that variable I have stored our full data set. Now I want to group by my data. So a dot group by, group by function is used to group your data according to the column. Suppose I have a title of Joker, right? So in the title I have Joker. So what it will do, it will actually group all the ratings and all the data we have according to Joker, and it will do same for the each and every title I have, right? So this is why we use group by function. Okay, fine. So in that case, you can see I'm going to provide title and rating. I want to see title, like first Joker, and then the rating, how many rating it has, and then I want to take a mean of that just to get the average, just to get in order to get the average for that particular movie, right? So you can see I already got that. For title Hellboy, I got 4 rating, right? For XXX2 002, for that I got 2.77 ratings, right? So this is how you will get the average rating for each and every like movie we have in the data set, right? Now we are going to see the short, we are going to short our data set, right? So we are going to see how many movies has actually 5, how many movies has 4, how many movies has 3. We want to just short our data set in a descending order, right? It will start from 5 4 3 2 1. Okay, so to get the data set in the, like, sorting the data set in a descending order, in order to, what you need to do, you just need to write ascending equals to false, right? This is how you will get the descending order data, right? So let's see. Yeah, so already it's stored in sorted ratings wise movie. Okay, so let's see what we will get. Yeah, we get like Curlson returns is 5, and the Beast of Hollow Mountain is 0.5, right? So you can see we already got the data which is actually in a, like, the first 5 we got the 5 ratings data. Now we got the less, right? This is how the descending order works. Okay, now we are going to see the total number of rating for a particular movie. For a particular movie, how many numbers of rating we have. Maybe some of the movie is actually getting a high ratings, but the like rating of the, like rating of the customer is not high, right? Suppose a movie is rated by a customers, like 10 customer, they rated 4, right? And one movie is rated by 2 customers 5. So obviously the movie rating for that 2 movie will be high, right? So for that we need to check what is the count of the users we have for each and every movies. Okay, for that we are going to use the same technique, dot group by. Okay, we are going to use the dot group by, and then we are going to group by title and the rating. Okay, and we are going to use dot count function for that. Okay, so you can see for XSS 2002 we got 24, for State of Union we got 5, for existence we got 22, right? So I just get the last 5 rows of my data set, but for all the movies it's actually giving me the rating, how many ratings it has particularly, right? Now we are going to make a new data frame, right, where we will have the average rating, we will have the title of the movie, and we will have the count of the total rating. It will actually help us to analyze our data more easily. So in that case we are going to make new record. I got a question from Avinash. Can we use print A in group by syntax? I didn't get you. Can you just more explain it? Like, can you give more explanation on that? I didn't get your answer. Okay. Okay, fine. So I got a question from Likhit that shouldn't we use mode here instead of mean? So maybe it's something like up to you. If you want to use mode function just to understand your data, yeah, you can go for it. So I use mean for that. Okay. Okay, so now we are going to see how can you make a new data frame. To making a new data frame, we just need to call pd.data frame. Okay, pd.data frame, that how you can call a new data frame, and the new column of my like the new data frame has a column called average rating, right? So I want a column average rating, and I'm going to provide the A has the all the average rating for each of the movies, right? So let me do that. Okay, and for the new record data frame, I'm going to again add the count of total ratings, right? So in this data frame, I will have 3 columns, right? One is title, one is average rating, one is count of total ratings, right? So let's see our new data frame. Yes, we got title, we have got average rating, and we have count of total ratings, right? So for 712104, I got ratings of 4.0. For round midnight, we got rating for 3.5, right? And count of total rating, it's 2, this is 1, right? We have in our data set. Now what we need to do, we just want to see and we just want to visualize our data. For that, we are going to use matplotlib library. Okay? So we are going to use matplotlib library and the seaborn library both. Okay, fine. So in that case, first let's see what are the columns we have. So you can see I got a column for average rating and the count of total rating, but where this title goes, the title is basically the part of index. Your index is titles, right? Now I want to see what is the graph of my count of total ratings. So let me just, okay, so from the output you can see the most of the movies has received less than 50 ratings, right? Most of the ratings like less than 50, while the number of movies having more than 100 rating is very low. I mean, more than hundreds we even can see them, but more than 50 is also very less, right? So this is how you can judge your data. So 0, 1, 2 are more, you can see these are the more, right? Almost 6,000 data are almost 0, 1, under 0, 1, and 50, and you can see 30, 40, maybe it can be under 30, 40, these are also more, but more than 50 is very less. So maybe for that you can use more like a big data set. I'm not using a big data set. So if you want, you can use a big data set for that, to just to get a proper like efficient model, right? Okay, so now I'm going to see the average rating. I want to see a histogram of the average rating. To get the histogram, what we need to do, we need to use .hist function. Okay, the .hist function actually return us the histogram for that. So I use the average rating column, and I am going to use .hist function for that. Let's see what we will get. So you can see this graph. For we have the integer value have a taller burst than the floating values. Since the most of the user assigns rating as an integer value, that is 1, 2, 3, 4 or 5. And furthermore, it is evident that the data has a weak normal distribution. So using this data visualization part, you can understand your data more efficiently. You can say your data is weak in the normal distributions, right? With the mean of around 3.5. And there are few outliers we have in our data. So if you want to remove those outliers in your data, you can do that, because when you actually remove your outliers from the data, your model will start performing very well, right? So it's actually data visualization is one of the most important part in your like when you are going to model build a model, right? So yes, from the graph itself it will start saying so many things to you. Okay. Okay, so yeah, so you can see like I'm going to plot one more thing, that is using joint plot, that is the part of seaborn library. So for the X I'm going to use average rating, and for the Y I'm going to use count ratings, right? So let's see. Yeah, so we got this graph. So this graph actually shows that the general movies with higher average ratings actually have more number of ratings, okay, compared with the movies that have lower average ratings. So from that you can see this is actually saying the same thing. The movies with the high average ratings actually have more number of ratings, and the compared with the movies that have lower average rating, like suppose a movie is actually getting 1, right? So in that case you can see the number of ratings is less for that movie. So you can see in this count of total ratings and the average ratings, right? Okay, fine. So now we are going to use actually how can you make your recommendation system. So in like before this part we are actually understanding our data, what actually our data wants to tell us, what actually the spread of our data set, right? So now I am going to show you, we are going to use dot pivot table, right? In that pivot table we are going to use user ID, title and the rating. Okay, and what we are going to do, we are going to check all the columns and the head as well. So first let me just print that. You will guys get that what we have in movie matrix. So you can see in the columns we get all the movie name, right? We make a pivot table where the column is actually with the movie names, right? So you can see I am going to again execute that. Yes, so we have the columns, right? We have the columns. Now what we need to do, we actually need to take that XXX2002, right? So we are going to use the movie name XXX2002, where actually you will get all the movie, all the ratings and the average ratings for XXX2002, right? So we are going to check what are the similar movies we have like XXX2002, right? Okay, so yes, for that I'm going to take all the ratings from movie matrix to XXX2002 ratings variable. Okay, just now let me check what we get in that. Yes, we get that 3.5, 2.0, the ratings we have for each users they have given, right? Now we are going to see find the similarity. What are the similarity we have for other movies like XXX2002? So checking the similarity, we use dot core with function. It actually give us the correlation with the same movies we are actually passing to it. So in that case we are using XXX2002, right? So it's going to give me that what is the similar movies we have in this data, in this like movie list, right? Okay, so let me just execute that. Yes, you can see we got that Hellboy, and these are the actually correlated movie we got. That is, you can see State of Union, and yeah, and you can see XXX2002 is actually getting the most correlation, like correlation is 1. Suppose correlation with 1 with the similar one is always 1, right? So you can see that XXX2002 we get the correlation is 1. So this is how you can see actually it is working perfectly when you are going for checking the correlation of the particular movie with the other one, right? So here we are going to use the heat map just to check the correlation in a visualized way, right? So here we are using matplotlib for that. You can see all these are 1 1 1. Suppose rating के साथ rating is always 1, right? And user ID with user ID is always 1. This is how we actually calculate all the correlations. Okay, right. Now we will see what is the correlation we got in a data frame. Okay, so here we are going to pass our movies similar to XXX2002 and we are going to use a correlation column for that, and we want to drop all the nan value from the data frame, right? To dropping all the nan value from the data frame, we use drop in a function, right? So you can see XXX2002 correlation dot drop in place equals to 2. So let's see. Yes, you can see 500 days of summer has a correlation with the XXX2002, that is 0.83, right? And 10 items or less 2016 has a correlation of 1. So this can be the next recommended movie for the particular user who have actually watched XXX2002, right? And maybe the next one can be 500 days of summer. Okay, so we actually got I actually print the head. So if I'm not going to print the head, if I'm going to print the whole part, so let's see. Yeah, you can see some of them have the minus as well. So there is the meaning of minus is basically there is no correlation between that two language. Okay,
let's get started with a quick did you know about Python, right? Now, Python is a fantastic programming language. It should really not come as any doubt to you that it is one of the most, one of the most sought after programming language today, right? It is in fact considered as the world's #1 programming language today. Now, there are many reasons for that. You can talk about any domain, be it data science, be it artificial intelligence, be it, in terms of data analysis, be it web development, be it game development, user experience development. So you can talk about these wide array of domains where Python might not have a direct footing, right? Yet Python is the programming language that again powers through all those domains as well. That's one of the reasons why, it's considered as a very, very popular programming language today. That, and of course, millions and millions of people use Python today. Perfect. Now, since you guys are watching this on YouTube, if you're watching this on your browser, you might have watched certain TV shows on Netflix, platforms like Amazon Prime, Z5, Hotstar, and all of these things, right? So if you've ever used that, did you know that all of these actually work with Python in the backend? Even though directly you're not seeing Python code, that's because of user experience, but in the backend, right? If you're using, for example, a Firefox browser, Mozilla Firefox, it uses somewhere around 230,000 lines of code that are absolutely written in Python, and that is what gives the functionality, and that is what makes Firefox work, right? Similarly, YouTube uses a little bit of Python, Netflix uses a ton of Python. In fact, Prime, Hotstar, all of these guys, wherever they're trying to use recommendation systems, wherever they're trying to push a product across, they definitely are using Python, because it offers a ton of benefits for a lot less time that you have to invest in it, right? Okay. Now, one fascinating thing about Python that I always get asked is, why did the inventor of Python name it after the snake? Well, we know the snake, right? Python is a type of a snake. It's a venomous snake. So basically, the founder or the inventor of Python, Guido van Rossum, was a person who was, a very big fan of a famous TV show called as Monty's Python Circus, Monty's Flying Python Circus, or on the likes of that, right? So basically, as this, it is basically a comedy sitcom type TV show, is what I've heard. Of course, I haven't watched the TV show. This was way back, at least 50 years ago. So when you take a look at it, Guido van Rossum actually wanted to pay tribute back to the TV show that he loved so much, and that's the reason why he named his programming language after the TV show, Monty's Flying Python Circus, right? Monty's Python Circus is the reason why you see Python as the name of this programming language. How fantastic is that, right? Now, quickly, let us discuss the third point that's seen on your screen. In fact, did you know that, for the domain of natural language processing, or NLP as it's called, Python is extremely popular there, right? Now, when we talk about NLP, I'm sure that if you've clicked on this video and if you're willing to build your own chatbot, you might know a little bit about NLP, right? Natural language processing is basically how the machines understand everything that goes on, when we converse or when we talk in a natural language, right? Be it English language or any other language. Now, if you take a look at it, chatbots entirely depend on natural language processing, right? It's not like I'm telling out zeros and ones in terms of instructions and the machine is sort of figuring that out. No, I'm whenever I say, hey Google, what's the weather like tomorrow, I am basically using English language. I'm using a natural language, a language which is basically natural to me, of course, right? Now the computer has to understand all of that, and it has to give me valid answers after understanding the language, the question, and everything that the question asks for as well. So this is another reason why Python is considered, because again, it has multiple libraries here that will give you uninterrupted access to some of the most amazing functions that you can use to build your chatbots in a really easy manner, right? So I hope this quick did you know helps you get aligned with what we are about to learn in today's session, right? Perfect. Now, let us quickly get started by taking an introduction to understand what chatbots are, right? Now, what are chatbots? I just actually gave you an example in the previous slide when we were discussing the did you know, right? So whenever we think about chatbots, in fact, in the previous slide, I already gave you the name of a chatbot, right? Now, think about Siri, think about Alexa, think about Google now, think about, there's a lot of chatbots out there governing today's world. And in fact, you might not even notice that you're talking to a chatbot in real life, right? Now, before we come to that, let me discuss what chatbots are. Now, Chatbots are basically we're trying to simulate human beings on the other side of our display, where we're trying to get our machine to understand, process, and give us vital answers and perform specific tasks by understanding human languages. Now, this is the most fascinating concept that in fact, I think this was long back. We're going to discuss about the history of chatbots, but you have to understand that this has been a concept for 100 years, and right now you can see the extent to which chatbots are having an impact around us, right? It's very simple. The first chatbot came out. It was created by this person called as Joseph Weizenbaum in the year 1966. This chatbot was named Elisa, and in fact Elisa is still active. There are certain websites where if you just type in Elisa in Google and just type Elisa chatbot, there are websites where you can actually practically talk to Elisa and sort of see how it was way back in the late 60s, right? That's a very fun thing that you guys can do. Now, an interesting thing about chatbots that you have to understand is that it is not just a simple transaction where I say hi to a chatbot, the chatbot says hello back, and we are done, right? It has been so sophisticated in today's world that chatbots now can so they have the capabilities. Whenever you're talking to a chatbot, right, you will not know that that's a chatbot. That is how good things have gotten now. They have become so human in a way in their conversation that we have the capability to judge either it's a chatbot or if it's a human, and sometimes even the best of the best are fooled into thinking a chatbot is actually a human being on the other side. How fantastic is that, right? Now we are making our computers intelligent enough so that they are discernible whenever you compare it to a human being, and that again as a pathway to achieving artificial intelligence and of course opening up 100 doors for the future is definitely something the world of chatbots is contributing into, right? But then, okay, so we know what chatbots are. We know a little bit about them. We have used them in terms of Siri, Alexa, Google now, and all of that. But then, what are we talking about when we, talk about history? First of all, we saw Alexa that came out in 1966, right? But then, even before the first chatbot ever was created, there was this fantastic mathematician called as Alan Turing. He was, in fact, he had a very strong, impact on how the course of the Second World War in fact happened, right? So again, that's another story of its own, and in fact there's a movie based on Alan Turing as well. I think it's called The Imitation Game or something like that. You guys definitely should watch that. So basically what Alan Turing did, he asked a question saying, can machines think like humans? If they can think like humans, do we get to know that that either we're conversing with a human or a machine, right? Now that led to a test called as the Turing test. A Turing test is basically a test where a human is on one side and there's a computer on the other, but the person doesn't know that there's a computer. So as and when he asks certain questions, as and when the human asks questions, if the computer is able to provide answers to a degree where the person doesn't know that it's a machine doing it, but rather he or she thinks that it's a human doing, that is when that machine passes the Turing test. As in, that machine was intelligent enough to fool the human being sitting there into thinking that, into tricking the person, basically knowing that, hey, this person actually was talking to a machine and not another human being, right? So that is when people were thinking about how best can you make your machines think in terms of align its thinking in terms of human beings. So at the end of the day, whenever you're talking to a chatbot or whenever you are talking to an entity that has passed the Turing test, of course it's very simple to pass the Turing test now for computers and machine learning algorithms, but back in the day when you had something that passes the test, that is when things really got exciting, because that was when people started realizing that you can bring together a whole world of technology that never existed, right? Now, for example, I'll tell you this amazing application. This is done by the people at Google, right? Now, they have a chatbot which has the capability to call a restaurant and book a table. Maybe you want to go out to dinner with your better half, with your wife, family, whatever it is, right? You can say, hey, Google, book my reservation for that hotel at that particular time on that day. And boom, it's not like it'll it'll remind you to do it yourself. Google will actually call up the restaurant, talk to the manager, make a booking, ensure that the booking is done, and in fact it'll even remind you later saying, hey, I had booked this for you, you have this. How fantastic is that, right? They actually did a demo. The people at Google did a demo on this, and it orders food and it books restaurant tables, and you never know that you're talking to what could be basically a simple piece of code on the other side, right? That is how fascinating the world of chatbots has been, and it's just that we are at the stepping stone where we are still looking towards how best can we apply them and use them. Right now, this is a domain which, again, in the world of chatbots, is basically evolving in a very rapid manner. As you can see, there was a time when you could just say, hey Siri, tell me what the time is, hey Siri, set my calendar, and all of that, right? Now you can do whatever you want. You can ask Siri to guess whatever song is playing in the background. You can take an image, you can click an image and send it to Siri, and Siri, Google, Alexa, you can ask it to sort of take a look at the image and think, tell you about what it thinks of the image. And like, guys, the amount we can just go on and talk about these applications and how best the domain is improving, but at this moment of time, I think it's clear for all of you all that it is super important to analyze that the growth that is being shown in the chatbot domain, and of course the number of applications itself for the future, that should give you a positive trend, and that should give you a fantastic trend in case if you guys are very serious about, in fact, maybe building a career around chatbots in Python, right? All right, perfect. Now let's quickly take a look at the history of chatbots, and let's try everything, try to line everything up down from the 60s to the latest standards, right? Right. As we saw, Eliza came out in the year 1966. Then we had another chatbot called as Parry in the year 1972. We had Alice in 95, and we had Smarter Child in 2001. Now there's a good chance you might have not heard of the first four, but there's a very good chance you might have heard of the next three, right? Siri, Apple's chatbot, came out in the year 2010. Google Now came out in 2012, and Alexa came out in 2015. Now if you take a look at it, I've been using Siri since the day one, ever since Siri came out, from 2010 till today. It's been what? It's been 11 years, and it's an absolutely fantastic ride of how they developed this particular platform. And of course, the person who voices Siri is also very famous. Her name is Susan Bennett, the US female version of Siri. Now they have multiple people voicing these chatbots. It's not like you get a robotic artificial voice when you talk to the chatbots now. It's literally a human voice on the other side, right? That is again a fantastic process of how they get it done. Now it's not like a human will say all the words that are present in the dictionary and then a chatbot is built. They pick up certain syllables, certain words, and that's how they get the human being to record the voice for the chatbots. It's again a very interesting process we can discuss some other time. Now that we've understood this quick introduction, now that we know a lot about Python, now that we know about the history of chatbots, it becomes super important that we talk about the various types of chatbots that we have today, right? Now, the chatbots is basically a concept where you can sort of divide it into multiple different things. You can have 5-6 different types of divisions, and it can get confusing and a little complex. To keep it really, really simple for to keep the entire scope of audience in mind, we've sort of given you two very, very important types of chatbots that every other chatbot is based on, right? So we have text-based chatbots and voice-based chatbots. Now, the chatbots that you might have used in terms of Siri, Alexa, Google, they are both text and voice based chatbots, right? So you can either talk to them or you can even text with your keyboard open, right? So maybe you've seen this. They're all text based chatbots as of how they work. Whenever you try to say something, the message is actually printed again on the text, and the text is what is understood by the chatbot, right? But then of course, there are many chatbots where it will only recognize whatever you say, as in it knows how to recognize voice, it knows how to understand who is talking, what is being spoken, what is asked of it, and what's needed to what's to be provided, right? So this is text based and voice based chatbots. Now if you are aligned with maybe in the shopping in the online world a lot, you will come across these chatbots a lot, be it either you're ordering food on Swiggy or Zomato, or you're talking to you're chatting with an Amazon customer support portal thing, right? So there again, at the start start, 99% of the time, you will always be talking to a chatbot. In fact, some of these applications will even tell you that you're talking to a bot right now, and it will help you with everything that might solve your problem. Right now, there are things which might not solve your problem. If the chatbot runs out of options, it will not say, sorry, I cannot help you. It will tell you, hey, can I connect you to a human representative so that you can have their help for this particular query, right? So it's a very well-rounded world where there is no jagged edges. No matter what sort of questions you ask, a chatbot, a very well-rounded text or even a voice-based chatbot has the capability to give you well-rounded answers on that. The text-based chatbot will give you a textual output, while the voice-based chatbot, of course, as the name suggests, will sort of read out the answer to you or read out whatever it is that you asked of it, right? So these are the important types of chatbots. But then when you're thinking about designing a chatbot, this is where you have to again sort of split it into two more types of chatbots, what we call as the rule-based chatbots, and of course we have the self-learning chatbot. Now if you take a look at rule-based chatbots, as the name itself suggests, rule-based, right? So it has certain rules that it has to follow to answer all the questions that is asked by the user. So every answer that it will sort of give you to your questions is already available in a group of details, or let's say it's basically called as rules. So it uses those rules, and these rules are defined by the user himself or herself, that way that this chatbot can use all the data that's present there and sort of give you simple to even pretty complex answers, right? So if you have a ton of rules and if you just provide it a lot of information, well, at the same time your chatbot becomes super intelligent on its own, right? Correct. Next, you have something called as a self-learning chatbot. Now, self-learning chatbot is an even better game to play because self-learning chatbots are mostly based on machine learning models, right? So they're basically created using machine learning algorithms. So this is a bot which will have the capability to communicate, to learn new things, to understand new things by using the power of machine learning. It will use it to learn new things, assess what's happening, what's required from it, and give you the answer to the question that you are asking, right? So it's a fantastic thing when you take a look at the other side of it. Now, when you talk to a non-technical person to talk about the types of chatbots, you'll probably talk about textual based and voice based chatbots. But now, since you are on the verge of creating your own chatbot, you definitely need to understand two more divisions out here, which is basically the rule based chatbot and of course the self-learning chatbot. Both of them are super popular. Both of them have their own advantages and disadvantages, and they have their own niche applications, right? Now, as soon as you look at it, you might be like, hey, a self-learning chatbots looks more fascinating and looks more sophisticated just because it uses machine learning. So is it more powerful? In some cases, yes, it is more powerful. The self-learning chatbot is more powerful, but that does not mean that for all the cases it will work fine, right? So for some places, like you will need to understand that there is you need to understand first of all that rule-based chatbots also are fantastic. They're super efficient, and if you provide a good amount of data, there is no beating the efficiency of rule-based chatbots, right? So again, these are two other types of chatbots that I wanted to discuss with you now that we are involved in the process of building one, right? Perfect. Now that we understood, we had an introduction, we looked at the history, we also understood, how these chatbots work, the types of chatbots and everything. Now we've come to a point where we can go ahead and discuss some of the top applications of chatbots, right? Now, when you are usually taking a look at top applications of chatbots, well, in fact, when I was researching for this video a couple of weeks ago, you definitely have to think about an important thing. Every application I looked at when I was, taking a look at chatbot was every application was fascinating. It really is very difficult to say, hey, these are the top applications, because I have found use for everything that you see on your screen right now. In fact, if you're a person who has used the concept of smart homes, smart lighting, and all of that, you will definitely understand that, hey, you can literally do whatever it is that you want by bringing together the world of chatbots and Internet of Things, IoT, right? And most of the chatbot application is basically that they have a smart IoT device which also works with a couple of your chatbots. That is what makes the entire thing to be smart, right? Now, anyway, coming back to the top applications of chatbots, first of all, yes, there's hundreds, if not thousands of applications that we have today. But again, these are some of the things, the applications that we're going to discuss are some of the things that you might have already used, right? Now, take a look at the first one. It says help desk assistant. As I mentioned, maybe your food was running late on Swiggy or Zomato, maybe your order was running late on Amazon or something like that. You usually talk to a representative, right? You usually open a chat portal, there it'll ask all the details for it. It usually asks the same questions in a form of a template. Whenever you have an issue, you have to pick from multiple options, and it'll try to see if the chatbot itself can solve your problem. But then, yes, there is only so much that the chatbot has in terms of functionality. So if it cannot solve your problem at the help desk assistant, it'll basically raise the ticket so that a human representative, an expert on the other side, can connect with you and help you out with your problem, right? So that's one type of chatbots. Then we have the email distributor. Now, email distributors are absolutely fantastic. If you're a person who likes to keep your emails very structured and make sure that they're labeled, they're ordered in a nice way, there again, we have multiple chatbots working. Now, these are the newest applications, but we do have some of the classic applications where, think about spam filtering, right? Spam filtering is again something which is very much required, because you require a chatbot to read through the mail that has been sent to your inbox and then make an assessment, say, hey, this is an important mail, this is a junk mail, spam mail, this has a virus, whatnot, right? So that part of the thing with respect to chatbots is also taken care of. And then take a look at home assistants. Home assistants are absolutely fantastic, right? So I have this vacuum cleaner called as Roomba. Roomba basically is like a robot vacuum cleaner which just goes around the house and cleans your house, and eventually it will know where all the walls are, where the unclean spots are. It will go clean it. Eventually it will just dock by all on its own. You might have seen videos on Instagram where there are cats or dogs which are riding on this tiny robot which is the vacuum cleaner, right? So again, those are very intelligent, appliances, or let's say home assistant entities, where you can actually have a lot of programming in them, add a lot of functionality, and use them to their fullest. Right now, you do have something called as home automation, which is extremely popular these days. So let's say if you have a theater at your home, all you have to do is you have to open the door and say, "Hey Google" or "Hey Siri," turn on the home theater. Right? So it's going to turn on the air conditioner, turn on your projector, turn on your speakers, turn on your computer. It's going to turn on so many things, and it's going to ensure at the end of the day that while you walk in to your theater, right, the temperature is also taken care of, the lighting is taken care of, there's music playing in the background. So it just gives you an entire well-rounded feeling, is what I want to say, right? So home assistants, there's various types of home assistants again. And then we have something called as an operations assistant. Operations assistant again can somewhat relate to the same example as we spoke about for Zomato, or in fact you can have a chatbot where you can ask technical questions to the chatbot and the chatbot can give you technical answers on how to solve something as well, right? That can be operations assistant. And then you have phone assistant. Phone assistant, of course, every other assistant that we have been discussing right now either uses an assistant which is built for your phone, or it trickles off of that technology, right? So basically, yes, Siri, Google, Alexa, all these things are phone assistants. Again, I don't think I have to explain a lot about them, right? Perfect. Next, we have the entertainment assistant. Now, entertainment assistants are again super important in today's world. When you think about it, you can actually, especially I've heard that this is extremely popular in the world of football and basketball, where you can actually have conversations with respect to chatbots. You can ask questions about what it thinks about the match, its predictions, who'll score a goal, what will happen, at the end of the match, and you can do a lot of these things where you can not just talk to your chatbot, not just talk to your assistant, but get your assistant to predict the future for you, right? Now think about sport, think about predicting what will happen at the end of it even before it has begun. And I just gave you one example, right? Of course, you have ton of other assistants, in literally every other form of entertainment sector today. But at the end of the day, when we're discussing about some of these applications, I thought that it'll always add value to highlight that one super popular application that you might have, already known about. Now we've discussed a lot of these things about chatbots itself. Now we're going to get right into the heart of the concept now. We will have to take a look at the architecture of chatbots, as in what makes a chatbot what it is, right? Now that's a very important concept that we have to take a look at. Right, guys. Now, whenever we're taking a look into understanding the architecture of chatbots, it must be very important that there are certain concepts, there are certain elements that builds a chatbot that is considered as common regardless of the type of chatbot, regardless the type of application that it is trying to solve as well. Right now, when we discuss the architecture of chatbots, I'm going to bring in the general image. I'm going to bring in a bird's eye view of this particular concept. Right now, if you dive right into the details of how they work, Siri works extremely differently when you compare it to how Google now works. Google works very differently of how Alexa works and all of that. So instead of just confusing you with all of these convoluted concepts, let's take a look at the entirety of governance of how a chatbot works. Right now, there's multiple different entities that the architecture should consist of. First of all, let's take it from the front end to the back end. Right, you have the chat window or the session. This is where you're communicating to the chatbot. Right, maybe you open up your phone and you just swipe up and Google now opens. That is your chat window. That is your session that just got created. Right, or you're talking to an Amazon chat related service, or you're talking to Zomato, you're talking to Swiggy and whatnot. So you have a user interface to basically talk to the chatbot. Right, that is the chat window. And as soon as a chatbot is active, it creates something called as an active session that it uses. Right, for example, if you're talking to a chatbot, there are certain chatbots where if you not talk to it for a while, it'll ask you if you're there, it'll try to ping you, it'll try to see if you are still around. Right, Tesla's cars do this when it's on autopilot. The driver always has to have his hands on the steering wheel. If not, it's going to start giving you alarms. It's going to start asking questions saying, hey, you know what, are you awake, are you like sleeping or something like that. I just gave you a funny example, but yes, so having this kind of a interface where you're directly working with the chatbot, that's what the chat window or the session means. And there has to be an interface between. This is not the interface that we use, this is not the user interface, this is a bridge between the NLP model and the chat window. Now let's talk about the NLP model so we can talk about why we require this interface first of all. Right now, when we're talking about the NLP model, NLP stands for natural language processing. This is a model which is again built either using a neural network or machine learning algorithms in a way where it has the capability to first of all have certain points of data to use to basically give out answers. The second thing is it will also have the programming necessary to ensure that it can basically understand the question for which it has to pick the data and give you an answer. Right, that is all that fancy stuff, all the heart of it, all the brain of it, or you can in fact talk about a lot of different things, but you have to understand that without this particular entity, NLP model, this entire thing about chatbots will not be as sophisticated as we have today. Yes, you can still have chatbots without having a very fancy model. In fact, we're going to actually demonstrate that you do not require a super complex chatbot for whenever you're programming from scratch. So this is still required. At the end of the day, you can get away with it, but again, since we're discussing about everything, it becomes vital that we have it here. Right, ladies and gentlemen? Okay. Now, the next thing that the NLP model, whenever you're expecting a model to train, what is it that it's required? You require data. Now, in the world of chatbots, we usually call data as corpus, as dictionary, or as there's a lot of names that we actually go on to provide to this. But whenever you hear those terms, corpus, dictionary, data, understand that there's a good chance it always means like it's basically a repository of information. Right? It is the data that the chatbot uses to give you answers upon. That's corpus. We're going to discuss corpus in detail in the next slide. Right? And then you see application DB. Application DB talks about the database which hosts, first of all, your application. Second of all, it hosts details about how you will have to bridge a gap between the application to send it to the NLP model, and the NLP model eventually, now I'm talking about the interface, the NLP model eventually uses the interface to just push out those answers either in a textual form, in a voice form, or whatever it is. Right? That is where the interface sort of comes into the picture, and then it just pushes the results out to the chat window. This is basically the entire working of a chatbot architecture, guys. Of course, in the NLP model itself, if you want to take a detailed look into it, you have a lot of different things of how the NLP model works. Now, I know that at this point of time, you might be like, okay, so we do not know how the NLP model works. Well, can you explain, right? Well, don't worry. That's exactly what we are going to do in the next section, where we're going to try to understand this process of what happens from corpus all the way to building your own, having a functioning chatbot that works as required, right? Perfect. So we're going to take a look at just that. Before we go on to do that, we have to check out how a chatbot works theoretically, right? Now, take a look at the screen right now. I have provided you with 7 very, very important steps, right? Now, this is a step-by-step discussion that we're going to have for this section, where right from the first step, which is importing your corpus, all the way to the last step, which is one hot encoding, these are certain standard steps, standard methodologies of how we can use natural language processing. And of course, not just natural language processing, use Python, use the foundational concepts from the architecture of a chatbot to see how things work, and eventually to build one ourselves, right? Okay, so what is step number 1 that you see on your screen right now? It says importing the corpus. Let's talk about importing the corpus for a second, right? Now, corpus, as I just mentioned, is the training data that is required for your chatbot to learn. Without a corpus, it's also called as a knowledge base, by the way. Without the knowledge base, without the corpus, without the data, without the dictionary, all of these are the same names, but without any of these, it becomes impossible for your chatbot to learn anything and to give you something useful in return, right? Now, if your chatbot does not know what an apple means, and if you continuously keep asking it questions about apple, do you think it can give you an answer? No, because it does not know. We are intelligent enough to research, right? Now, as soon as we want something, we know that, hey, just head to Google and type it in, learn something on your own, right? Computers sort of cannot do that. They can do the process of it, but when it comes to learning, they do it very differently compared to what we as humans do, right? So again, that is an important thing you have to consider. We require a corpus. We require the data compulsorily, without which a chatbot will not work. Why will it not work? Because it will not have any answers to the questions that we get asked, right? Now, if there is an examination and I've never attended college in my life, let's say, and I just go there with a textbook in my hand, and of course I've never opened that textbook, do you think I can clear the examination without any knowledge about the domain? Some of you might say maybe, you can do it probably, right? But then the majority of you can say no, it's not possible, because you have not learned anything to, in fact, go on to showcase what you have learned. There again is the exact analogy of how the corpus works. Now, once you understand corpus, it means that at this moment of time, either we have textual data, voice data, we have in a database our data that's needed by the chatbot. But then, as always, data is a raw entity, data is a messy entity, and it takes a ton of efforts to pre-process your data and to keep it ready for the further stages. If you do not do it, I'll tell you at this moment of time that, your NLP model, your machine learning algorithm, whatever type of, intelligence you're trying to impart into your chatbot, that will not work if your data is not clean, if your data is not accurate, right? Because if you just provide inaccurate data, your chatbot will not understand that. It will not be able to discern it. It will just give you inaccurate answers back, and you might be thrown off by that, right? So that's an important thing. Pre-processing the data can be done in many ways. In fact, one very important way that we're going to be doing is text case handling, right? Now, the data that you might have, textual data, it can have a lot of sentences, it can have a lot of paragraphs. So if you just copy all the text and paste it somewhere, you'll realize that there's capitalization everywhere. There is lowercase text, lowercase characters in most of the spaces, but there are certain uppercase handling that's needed as well, right? So to make sure that we avoid any sort of misrepresentation, or in fact even misinterpretation of these words, we just take all the data that we have in the corpus, basically these hundreds and hundreds of lines of sentences, and we either convert everything into lowercase or we convert everything into uppercase. And yes, Python will know which is being done, either uppercase or lowercase, so that later if everything is made into lowercase, when the chatbot replies, it will know to capitalize the first word for us, right? It's a super intelligent thing. We might think that, hey, is this all required required. But then when you take a look at it, when you yourself talk to a chatbot like Zomato, Swiggy, Amazon, whatever it is, you will understand that it is as close to a human as it can get. So text case handling, without which to process a chatbot becomes extremely difficult. So this step is very much vital. Right now, after we convert all the text into either lowercase or uppercase or anything like that, this is just a sample on your screen with a process what we call as tokenization. Tokenization is when we have sentences. Right now, I just said we have hundreds and hundreds of sentences in this particular document called corpus. Now we have to break those sentences down into each individual word, because without that you cannot just have your chatbot give you an entire sentence as it is as an answer all the time, right? Especially if you're working on a chatbot and you have user experience in mind, you have to make sure that it will give you an answer that sort of answers this rather a specific question rather than just answering a random question out there, right? So look at this on your screen right now. Tokenization, as I just mentioned, yes, it is a process of how you can take a sentence, break those sentences into individual individual characters. You can see that it's written, this is a blog. From this particular statement called this is a blog, it has been split into 4 separate entities. This is a blog, right? So this is the structured process that we use to convert sentences to individual collections of words. Because if you have individual collections of words, they can be jumbled upon to make a sentence of its own, which again works pretty well in the English language, as we have seen with Python. And then you can have your chatbot give you fantastic answers based upon that, right? That is tokenization. Once we finish with tokenization, we come to another concept called as stemming. Stemming is fantastic. If you guys are fans of etymology, there's a good chance that you might have heard of this concept, right? Take a look at the chart on your screen right now. It just said original word, root word, and similar word. In the original word, we have a couple of words here. Jump, jumped, jumps, jumping, right? We have 4 words. But all of these 4 words have one common root word. What are we talking about? Jumping, right? So jump is the common root word. So using this root word, you can actually form all these 4 words. Yes or no? Yes, right? So with stemming, all we're trying to do is, instead of just thinking about millions and millions of words, we just try to find the root word. Now, if you're a fan of etymology, there's a very good chance you know that this is an extremely powerful concept all in itself, right? So basically, knowing the word jump and knowing where all it can be converted into and used will help you a lot. Now, if you are a person who has ever prepared for competitive examinations, maybe like GRE or GMAT, where they have a literature section, there's a very good chance you might be using any of these techniques to make sure you have a high score there as well. Understanding the root word, so that every other word, maybe 10 or 20 other words that come below that root word, you're already done with just because you know one word, right? So stemming is this process. So where we try to find similarities between the words, we find the same root words, and we ensure that we can have this split up, and also teach the chatbot saying, hey, this is how it is. So you're basically making a chatbot not just more efficient at the same time, but also more intelligent as well. That's an important thing you guys have to know about. Perfect. Once we're done with stemming, we have one more fantastic concept called as BOW, or it's also called as bag of words. Now, it seems like a very funny concept, bag of words, but when you literally take a look at how it works, let me explain it first. Bag of words is literally like, let's just say I'm holding a couple of words right now, English dictionary words, and I just take it all and I just put it in a bag, right? That is literally bag of words. So with bag of words, what we are trying to have in concern is that we do have a lot of words. We do have words that can be used to answer a question. But at this moment of time, after stemming and after breaking it down into every single word, do you think order will matter? No, right? If I have, if you remember back when you were kids, used to play a game called Scrabble or something like that, right? Scramble, Scrabble, something like that. So that game, again, if you take all those individual blocks, if you just put it in a bag and give it a nice shake, do you think the order of what is happening in the bag is important? No, we just want the words. The words are there in a bag right now. They might be random, they might be arranged, we don't know. But that's the entire magic of this, right? Now, for example, let's take a look at the same thing that we've broken it into single words, right? This is a blog that you see on your screen right now. Now, what happens for a machine learning algorithm, or what happens for a deep learning algorithm when it takes over this particular stage, is that it does not understand English words as it is. So these English words must be broken down into mathematical vectors for these particular algorithms to understand. That's the reason you see this is a blog is basically split into 4 words, and you see zeros and ones that are given there, right? So when when this statement has to be passed on to the machine learning algorithm, this is a blog. It basically takes this vector that you see here, 1 followed by 4, 3 zeros, and this entire vector and matrix, right? So this entire vector gets assigned there, and of course there's another process of how you stitch them together, where you'll be using something called as a dot operation, a matrix multiplication dot operation, where you'll be bringing 2 vectors together and sort of working with that as well. Again, the process of it working can get super complex, but the main advantage is when we try to implement this in Python, it still is pretty simple and easy to work with, right? But yes, this is generating bag of words. You have to understand, you're going to take a couple of words, you're going to find the root, you're going to stem it, you're going to separately cut it out into individual words, you're going to put all of them in a bag, give them a jumble, and right now you're going to assign numbers to make sure that, if there is a sentence, that sentence will have a vector that can be understood by the machine learning algorithm, right? Perfect. So this is bag of words. Now, after bag of words, there is one last process called as one-hot encoding. One-hot encoding is basically the process where we're taking all of these categorical variables and converting into a form where the machine learning algorithm just uses, as I just mentioned in this previous process, bag of words, right? So bag of words creates a vector, taking a vector and passing it to your machine learning algorithm for that, for your machine learning algorithm to understand that, hey, this is this particular sentence, that is another sentence, right? So it needs to have a way of how it can discern sentences itself, discern words itself. Even though the order of words is not important, all the individual words are still important, right? So that is why we require this process of one-hot encoding. Now, if you ever are curious about when you type something into a chatbot, right? Now, if you say hello, if the chatbot in the opposite side says hi to you, hello to you, how are you, what's up, or something like that, one-hot encoding is the response is responsible for a lot of these responses that we actually get, because at the end of the day, your chatbot must be intelligent enough to go through the entire data, pick up something which is meaningful, and to find it as a reply to your to find it as a logical reply to your question. All of that works in the back end basically with this process called as one-hot encoding in itself. Now we've had a chance to take a look at the theoretical aspects of, we took a look at a lot of things to understand a ton about chatbots, right? So now is the right time. We'll actually go into, checking all these out practically. Now guys, the goal of this particular demo is to make sure that you guys can understand that you can also create a chatbot in Python. You can build a chatbot from scratch without having to put a ton of effort. Now, at this moment of time, you might think, okay, if I need a decent enough chatbot, will it require hundreds of thousands of lines of code? If you're thinking on the lines of Siri, Alexa, and all of those things, maybe yes. But right now, we do not have to write hundreds of thousands of lines of code to build a simple chatbot, right? That is exactly what I am going to demonstrate with this particular demo. So let's basically open up Google Collab. Google Collab is nothing but a simple Python Jupyter notebook hosted on the Google Cloud platform, right? So let me just open up Chrome. Right, to access Google Collab, all you guys have to do is type Collab on Google, guys. Okay, as soon as you type Google Collab, it's basically called as Collaboratory. It's a fantastic thing. I am a huge fan of Google Collab, and I use it all the time, regardless of if I'm at home or even before COVID when I was traveling, right? So it basically is a lifesaver. Alright guys, so basically I've just loaded up the Google Collab platform out here. I've already written down all the pieces of code that's required, that's just been put on here, that's ready, so that we don't have to sit and type it out as we go together. But then let me explain how all of these work, right? So let me zoom in a little so that you guys can see all of this screen better. Now, whenever we're working with a chatbot or anything as such, the first most important step is to ensure that we can bring in all the libraries that we're going to be using for that particular use case, right? Now, in this case, we're going to require 4 important libraries. The first library we're going to require is NumPy. NumPy is basically used for numerical computations in Python, an extremely popular library for data science. And then we have NLTK. NLTK is a superb library for natural language processing in Python. It's one of the most amazing libraries that you get to work with if you're very serious about working with chatbots. And of course, we have 2 other libraries as well, String and Random. String is to ensure that it can process and handle strings in Python, and Random, basically, you're going to see why we require Random as we go ahead as well, right? So as soon as I click that play button, as you saw, now I have imported NumPy, NLTK, String and Random with just a click of a single button. I can do this on my phone, I can do this on my iPad, I can do it wherever I have an internet connection and I can open a browser. How fantastic is this, right? Now, what's the next thing that we're going to have to do? Now, the next thing is again another 4 or 5 lines of code. It's very simple. Let me explain. The first 2 lines of code, basically f equal to open, raw doc equal to f dot read and dot lower. With these, all we're trying to do is we're trying to bring in our corpus, right? Our corpus is basically in the computer. I'm going to show you how we created the corpus also. So we're going to take a look at the corpus. We're going to make sure that our program has access to it. We're going to bring it, make sure our algorithm, basically our working environment has access to it. It can read it. Fine. That's first 2 lines, right? The next couple of lines, if you see line 3, 4, 5, what we're trying to do here is, first of all, you remember pre-processing where I told you either convert everything to lowercase or uppercase. Here that you can see with this particular dot lower function, I am taking the entire document, just bringing it down into its lowercase. Once it's been put into its lowercase, then we're going to be using this concept of the tokenizer that we discussed right now. In this case, you might see that we're using one particular tokenizer from the NLTK library called as the punct tokenizer. Now, punct tokenizer is basically a pre-trained tokenizer which has the complete capability to sort of, build a model around what's required and to give you an answer, right? So tokenizer as the process itself, you might be wondering why we are only using the punct. Now, there are many other tokenizers in the picture that we have. We have the tweet tokenizer, we have something called as the regexp or the regular expression tokenizer that you can go on to use. But in this particular case, we're not trying to assess or we're not trying to import the corpus maybe from Twitter. If you were doing that, if you were maybe analyzing hundreds of thousands of tweets, you need to just copy all of them and bring it together, right? That is when you'd be using something called as a tweet tokenizer. We're using the punct because it's already pre-trained. It is very easy and fantastic to work with it, right? Okay, perfect. Now, the next couple of lines that you see is basically how we are converting all the documents that we have right now into a couple of sentences, and all of these sentences into lists of words later, right? So we're going to have 2 documents created. Basically, it's called as sent tokens and word tokens. Sent tokens means they are sentence tokens, and then we have word tokens where each individual element is a word. In sentence token, each element is basically a sentence, right? As simple as that. All we're trying to do is split it into sentences, splitting into words, and bringing it into our working environment. Now, as soon as I click run on this will not run. It will give me an error. Why? Because it does not have access to that particular corpus file. So it's in my desktop. Let me quickly open up the corpus file in my desktop. Now, while that is uploading, I'll tell you how I created the corpus, right? So basically, I just went to Google. I typed in, data science Wikipedia, and Wikipedia just gave me this particular page for data science, right? So all I did was I copied everything from first line here till the last line, and I put it in a text file, and I call that file chatbot.text. That's it, right? So this is literally everything that's copy pasted from our Wikipedia. Now, this is a very simple chatbot, but I just want to give you a demonstration to show what the corpus itself looks like, right? Now, let me run this again. It should run absolutely fine now. See, I told you, right? So it just didn't have access to it, and now that it has access to it, it can do it. Now what we'll do is we'll print a simple sentence token to see if the tokens are working fine, right? Now you can look at this. Data science is an interdisciplinary field that uses scientific methods, processes, all these. This is one sentence, right? So you can see below there is another sentence. Data science is related to data mining, machine learning, and big data. So with this piece of code, what I did was I printed 2 sentences out from the sentence tokens. Similarly, what I want to do is I want to print out the word tokens. Now I just want to print 2 words from the entire corpus that I have. Simple. I just printed the two words data and science. So basically what I'm trying to do to print this is to not showcase that you can print it. Of course you can print it. I'm just trying to verify if my data that we have actually created. Let me just scroll up here. Here when we created this particular document where we are converting it into list of sentences and list of words, I want to see if it works or not. That's the reason why we have that, right? Now once that is done, the next step in the process is to basically pre-process the text, as I just mentioned, right? Now Limitization, stemming, all of these processes are something that we took a look at, right? So this entire process of pre-processing basically works in this way. Either we're going to convert everything to lowercase or uppercase, and then the other thing what we're going to try to do is we want a normalized vector as a result of out of these. We can have a regular corpus data sent into it, and we want tokenized vectors. So we'll have to remove so many different things. Right? So first of all, there might be sentences which are not broken down into words. And if your sentences are broken down into words, what is happening to the punctuation marks? Did you guys think about that? Commas, full stops, and all of that, right? So you have to think about that as well. So to process all of these things, we'll be using a WordNet. WordNet is basically a dictionary that's already inbuilt and included with the NLTK library when we work with Python, right? So it makes this entire process of, if it weren't for this particular, these couple of functions that we're using, or if it weren't for WordNet, we would have to write a lot of code for this particular segment for pre-processing, right? Now, as soon as I click on it, my data is pre-processed. Next thing is the fun part. Now this is the function where we are trying to build a greeting function. Now a greeting function is very simple. What does it mean when I say greeting? When I say hello to my to my chatbot, I want it to give me a reply, but then I will not just say hello. I can say so many different things. I can say hi, I can say sup. Sup is basically the millennial short form for WhatsApp, right? I can say what's up, I can say hey, I can say a ton of different things there, and you can understand that these are the inputs that I'm going to be giving it, right? It doesn't mean that I have to give it all. I can give any one of these inputs and it'll understand that, hey, this person is greeting me. And when I input either hi, hello, greeting, sup, what's up, and hey, it will give me a response back saying, hey, hi, nods, hi there, hello, I'm glad you're talking to me, right? So it'll give you any one of these responses. This is why we require the random function at the start. You remember? Let me scroll up. Import random. Why we require that library is when I myself give it an input, it will basically give me a random output. Look at this word, random.choice, right? So it will just try to find my response, and as soon as it finds my greeting response, it's gonna my greeting input, it's gonna give me a greeting response, right? As soon as I run this, now it knows how to greet people, right? And what have we done? We have used 4, 5, 6, 7, 8, maybe 20, 25 lines of code, and we've come to a point where our chatbot can already say hi and bye to us, right? Now the next thing that we're gonna have to do is get some responses to the questions that we ask. To do that, we basically will be using two concepts called as the TFIDF vectorization and something called as cosine similarity. Now to quickly explain what this means without going into a lot of detail, TFIDF basically stands for term frequency and inverse document frequency. Term frequency, as you might guess right now, talks about how many times all the words, each individual word is repeated in your corpus, right? That's term frequency, the frequency of occurrence of words. And then you have the IDF, the inverse document frequency. This is an absolutely fantastic metric because, see, to find term frequency is very simple. Just find out all the words, list them out, see how many times they're repeated, add them. It's a 10 lines of code, and you can do it simple, right? But the IDF part of it is very interesting because here we are not just trying to pick up words and say, hey, this is a word that's repeated 10 times, but here I'm trying to attach a sentence of attach a component of how rare the word is. That is why we require the inverse document frequency. How rare is the occurrence of the word in the corpus, right? Now there are so many words which can occur so many times. For example, if the word is data science, or if it is data, let me search for this. See, there is 120 times the word data has been reused, but it is not very rare or something like that, right? It's used 120 times. But if I try another word which is not so popular, like the word explorer, it has been used, but it has only been used once, so it is super rare. The IDF picks this up and it realizes that, hey, okay, these words are rare, these words are repeated so many times and all of that, right? Cosine functionality does that. Once we have bag of words, once we have everything ready in terms of ones and zeros, it takes all of that and gives us a normalized output. Now, if you do not follow the technicalities of it, absolutely do not worry anything. So basically what we're trying to do is to find the number of times a word is repeated in our document to ensure that, we can have and map the rarity of it. And the third thing is we can have the normalized vectors so that whatever we are doing right now, our machine can understand that, right? That is the simple aspect of it. Now, the next process that we're going to do on the same lines of response generation is to make sure that we provide certain data to it and it gives us an answer. We've already provided the corpus, so now it has to give us the particular answer when you're building the entire neural network and giving us an answer out there, right? But then you also have to think about certain situations where you try to type in something your chatbot doesn't understand, so you have to also write. So if TFIDF is 0, it means that your chatbot does not understand what's written on your screen or whatever you just gave it as an input. So there it will basically tell you, hey, I'm sorry, I don't understand whatever you are saying, right? So basically it can greet right now, and the next thing is it can know what it can understand and what it can not understand as well, right? So let me zoom out a little for the next one, and basically for the last piece of code, right? So we are already at the last piece of code and we are not writing hundreds of lines of code here, right? Okay, perfect. Now this is where we're going to be defining the start and end of a conversation. The start of the conversation is basically a for loop where the bot will continuously keep waiting without any sort of timeout. It will forever wait if I do not talk to it, right? But then there also you can change. Maybe if the user has not responded for 30 seconds, you can actually close the bot. You can do a ton of these things. This is the most basic bot, just to showcase the power of how you guys can go on to use Python to get to at this point as the goal here, right? So let me actually in fact run this. Here all we're trying to do is as soon as you're trying to, the user says hi, it'll start talking to you back. If the user says bye, it's going to quit, and eventually it's going to give us all the responses in between that makes our chatbot intelligent, right? Let me run this piece of code. Now the piece of code is run. Let me just read what it says. It says, my name is Stark, let's have a conversation. Also, if you want to exit anytime, just type bye. Well, let's just see if the exit thing works, right? I'll just type in bye. As soon as I typed bye, it says goodbye, take care, and a small heart. That part of it, the code is right here, right? So when I said bye, it understands that this person wants to leave. Let me run it again. This time, you know what I'm going to say? I'm going to say hello. So when I say hello, it nods, as in it's shaking its head. It wants to listen, right? If I say hi, now it'll give me another reply, hey. So it basically is randomizing all of these inputs. Whenever I say hello, hi, greeting, what's up, and I say any of these things, it's basically giving us an output for this part of it, right? Okay, now hi worked, hello worked, and all of that worked. Now since we're talking about data science, let's try to see if we can find out something about the corpus itself. So when we want to try to ask what is data science, right now the model is not, chatbot is not that intelligent enough where it'll understand all the questions directly. But if I wanted to print me, let's say the foundations of the data science, let's see if it can print something like that using the corpus, right? See, it found so many things when I said the word foundations. It says data science is an interdisciplinary field focused on extracting knowledge from data sets, which is typically large data sets, applying knowledge and deriving actionable insights to solve a wide range of problems or applications. Look at that. I just said I want the foundations of data science, and it basically gave me a one-line answer to what it understands as an answer to what data science is, right? How fantastic is that? Maybe I want to ask another thing. It says impact at third point here. I'm going to say impact of data science. Enter. And as soon as I have an impact, look, it gave me one more fantastic sentence. Of course, there are certain warnings which says your stop words are inconsistent because we do not have that big of a corpus to train. It says, as big data continues to have a major impact on the world, data science does as well due to the close relationship between the two. So it's telling me that, hey, big data has a huge impact in the world. Data science also has a huge impact into the world just because these two are tied very close to each other. I asked it saying, what's the impact of data science, right? And it gave me another answer. Now what happens if I just type data science? Now, if I just type data science, it says that, hey, it just picked up one random sentence. Now, this is where the bot might not give you as accurate answers as you might think. But then, hey, this is a very, very, very simple bot. It says, however, data science is different from computer science and information science. So basically, this is the line it first picked up from its corpus, and it's just giving us that particular answers, right? Now, maybe if I want to find out techniques in data science, right? Let me just type for techniques. And look, it found something in this particular domain called as technologies and techniques. They said there are varieties of different technologies and techniques that are used for data science, which depend on the application itself. Okay, this is a very good answer, right? So apart from one or two answers, you can see that once I quizzed it with 5-6 questions, it answers all of these things. And ladies and gentlemen, okay, let me just say bye to the chatbot. Let's close it first. Let me say bye to it, and it says goodbye, take care with the heart. Okay, cool. Now let me actually go on to clear all the outputs first of all, and let me zoom out to show you how much of code that we have written, right? 4 lines, another couple of 6 lines, 10, 11, 12, 18, 24, 25, 26, 36, 46. All of this is less than 60 lines of code, guys. 60 or maximum 70 lines of code, and all of these are very, very simple pieces of code, right? Take a look at that. We have not done much. I'm just scrolling through it. If you can look at the scroller on your right, and all of this is an entire chatbot on its own. Of course, this chatbot is not as intelligent as Google. It is not as intelligent as Siri. But at the end of the day, this is a chatbot that is going to give you, all the important answers that you require for your questions. And we never put in a lot of effort to go on to, showcase this, right? So yes, at this moment of time, the goal of the demo again is to not run through each and every line of syntax to tell you why this is called lem tokens, why is it not called anything else. No, my point here is to showcase that you can build a chatbot in Python without having to put much effort, and I think that was showcased beautifully with this particular demo, right? Perfect.
So what exactly is Python? So if you are new to Python, if you're new to this programming language, let me just give you guys a brief intro. So Python is a free and open source software. Now, what do I mean when I say it's a free and open source software? It basically means that you can download it and you can immediately start working with it. There are no prerequisites at all. You don't have to pay for this language. And it's also cross-platform compatible. And that basically means that irrespective of whatever operating system you have, whether it is a Mac, whether it's a Linux, or whether it is Windows, you can go ahead and download Python onto your system. And Python is also an object-oriented programming language. And an object-oriented programming language basically means that you can implement the real-world entities in the programming paradigm. So when you look around you, you would notice that you are surrounded with objects. The laptop which is there in front of you is an object. The mobile which is there in your hand, that again is an object. The wallet or the headphones which are there beside you, they are again objects. And if you'd want to represent all of these real world entities in the programming paradigm, you would need an object-oriented programming language, and Python is one of the most popular and most widely used object-oriented programming language. And the best part about Python is it has a huge standard library. So it has libraries with respect to NumPy, Pandas, Matplotlib, Seaborn, so whatever you would want to implement. So if you want to perform data analysis, Python will have a library for that. If you want to do data visualization, Python will have a library for that. If you want to create a website, Python will have a library for that. If you want to implement artificial intelligence, Python will again have libraries for that. So that is why Python has a huge standard library. And if you want to install Python, you can go ahead and install Python from this particular website over here, python.org.downloads. Let me just go ahead and click on this. Let's just wait for this to start. And this, what you see over here, download Python 3.8.5. And when you click on this, Python will be automatically downloaded. And since Python is platform independent, you can download Python for either Windows, Linux, or a Mac system. And once you download Python, we would need an IDE. So what exactly an IDE? IDE stands for Integrated Development Environment. And if you have worked with other programming languages such as Java, C, or C++, you would know that an IDE is just something, you can consider that to be a development kit which would help you to perform all of your codes in a much more smooth manner. And one such IDE for Python is known as PyCharm. And to install PyCharm, we would have to go to this particular website over here, jetbrains.com, PyCharm. And when I click over here, we have the download button, And over here we have the professional version of Python, and we also have the community version of Python. And since we only need it for general purpose Python development, I can just click on this and this PyCharm will be automatically downloaded. And mostly for data science purposes, we use this toolkit called as Anaconda, and it's the most widely used Python distribution. So when it comes to PyCharm, it is only an IDE, but Anaconda is a complete distribution. When you download Anaconda, it will give you an IDE called as Jupyter Notebook, and also you don't have to explicitly install some libraries which are there in Python. So if you download Anaconda, you will almost have all of the libraries which are there in Python, such as you don't have to download libraries like pandas, matplotlib, seaborn, numpy, and so on. To download Anaconda, you'd have to click over here, and when you click over here, products, when you click on individual edition, you have the download button over here, and when you click on download, again you will see that you can download Anaconda for Windows, Mac, or Linux. And since I have a Windows system, I will click on this and I can download the 64-bit graphical installer. So this is all about Anaconda, and this will give us an IDE called as Jupyter Notebook. And to work with Jupyter Notebook, you'd have to go ahead and select this. You'd have to, if you're using a Windows system, just type in Anaconda prompt. Select this Anaconda prompt over here, and you would have to type in Jupyter Notebook. And when you hit enter, you will get this home page. This, what you see, is the Jupyter Notebook over here. And if you would want to create a new Python notebook, click over here, and as you see, I have this new Python 3 notebook. I will click over here, and this is how this new notebook looks like. I'll just go ahead and rename this. I'll name this as, let me just give in simple Python. And if you want to go ahead and print something over here, all you can do is just type in the print command, add in some random gibberish over here. When you hit on run, it'll be printed over there. So this is how you can work with Jupyter Notebook. And if you want to save a Jupyter Notebook, you have the save as option. And if you want to download this, you have the download as option over here. And normally whenever we are working with a Jupyter Notebook, we will download this as a .ipynb file, which stands for, so over here, IPython Notebook, that is the extension of this. And this, what you see, this is known as a cell. And if you want to add a cell above this, you can just click on insert. You can add a cell above it. Similarly, if I want to add a cell below this, I'll click over here, and as you see, I have a cell below this. So this is all about basic introduction to PyCharm, Anaconda, and Jupyter Notebook. Which one is better, PyCharm or Jupyter? I personally prefer Jupyter Notebook because it's a web-based interpreter, and if I would want to share this with someone, I can easily share it. And also PyCharm is a bit cumbersome to work with, and when I directly install Anaconda, I have all of the libraries pre-installed in Jupyter Notebook. I don't have to explicitly install most of the libraries, so I personally prefer to work with Jupyter Notebook rather than PyCharm. Can I use Visual Studio? Absolutely, you can use Visual Studio. That again is another IDE for Python. Basically stating that she is new to data science and which part of Python she needs to focus more to learn data science in the best way. So if that's the case, then I would recommend you to focus on these three primary libraries, which are NumPy, Pandas, and Matplotlib. NumPy is a library which is the core library for numerical computation. So that is something you would have to have expertise on. Then you would need Pandas, which is the core library for data pre-processing and data manipulation. So it gives you two objects. The first object is known as the series object, and the next object is known as the data frame. And most of the data sets which we'll be working with will be in the form of a data frame. So Pandas is a must learn when it comes to implementing data science problems with Python. And then if you once you analyze something, you would have to show it in the form of beautiful graphs. And that is where you would need visualization libraries. So you will have two visualization libraries. The first one is Matplotlib and the second one is Seaborn. Again, I'd recommend you to learn both of them because both of them are equally important and both of them have their own pros. So these are the four libraries which you need to have expertise on if you want to learn Python for the sake of data science. So it will be NumPy, Pandas, Matplotlib, and Seaborn. What degrees are needed with respect to Python developer in big company? There aren't specific degrees with respect to Python. So if you have a BE or BTech in computer science, or maybe even if you have a BCA or MCA, that will be more than enough. After that, it's all about your skills. Once you have the basic degree, it boils down to how much skills do you have, how much have you worked on open source projects, how many Git repositories you have, how much you have. Where do you rank with respect to the different projects in Kaggle? All of that matters. So once you get your degree, you can go ahead and work on more open source projects that will be more beneficial to you guys. What is the best way to practice data science and machine learning? That's a very good question again. 4 pillars of data science or machine learning. The first pillar is statistics, as statistics forms the core component of data science, machine learning, and artificial intelligence. And if your statistics concepts are not clear, then in that case you will not be able to properly comprehend the machine learning or data science or the AI concept. So that is why it is extremely important to have your basics in statistics clear. You would need to know what are measures of central tendency, you would need to know what are measures of deviation, you would need to know about different probability distributions, and there is a probability distribution known as normal distribution, and this is an extremely crucial point when it comes to most of the machine learning algorithms, because you would normally prefer our data to be in the form of normal distribution. So once you're good with statistics, then you will head on to programming. Now, when it comes to programming, you have two main languages with respect to data science, which are Python and R. And again, I'll repeat this. This is not a case of either or. I would recommend you guys to learn both Python and R because both of them are equally important and it would depend on the project. So in big companies out there, it would depend on the project. So one project, maybe you will be using Python, and immediately for the next project, you will be using R. So it totally boils down to what project you're working on. So the first pillar is statistics, second pillar is programming language, then the third pillar would be machine learning algorithms. So you would need to understand. So if you are good with the stats part and the math part, then you will be able to easily understand the underlying concept of these machine learning algorithms. You will be able to properly comprehend what is linear regression, logistic regression, decision tree, random forest, Naive-Bayes, SVM, and all of the other machine learning algorithms. And so basically these are actually the 3 pillars: stats, programming, and ML algorithms. And once you're good with this, this would be the proper roadmap or the proper path to get started with data science. Is there any similarity between MATLAB and Python? That's interesting. The outcome, I'd say MATLAB is more towards computer vision. So if you want to perform more of anything related with computer vision, then you can go ahead and prefer MATLAB. I remember I had done a project in my final year of engineering, which was with MATLAB. So it was about the scriptures which are there on a palm leaf. So we had all of these scriptures over there, but the problem was the most of the text, either some of the text was missing or the page was torn a bit. So we had to find out how much of those scriptures, how much of those scriptures where the text was missing, and we had to put in boundary boxes over there, and we had to sort of predict what would be the next word. If let's say there's some particular sentence over there in Sanskrit and a couple of words are missing over there, then with the help of MATLAB and computer vision, we would have to predict what would be the next word over there. So I'd say if you want to work with MATLAB, it is more towards the computer vision side of things, and Python is more towards the deep learning side of things. But then again, computer vision is again a subset of artificial intelligence, so you can use both of these tools. Can we do doctorate in data science? Absolutely. A lot of people do masters and a doctorate in data science itself. So the top Ivy League schools such as Stanford, Harvard, MIT, all of them do provide a doctorate course in data science, artificial intelligence, or computer vision. Dr. Sarkar himself has his PhD from Stanford, and he has his PhD in statistics. Apart from NumPy, Pandas, and Matplotlib, how much programming in Python do I need to learn in data science or ML or AI domain? Well, I'd say that would be more than enough, because these comprise of the main libraries in Python. And if you have a very good understanding of NumPy, Pandas, and Matplotlib, that should be enough. But these are the core libraries. But if you actually want to implement data science, then there's another library called as scikit-learn. And with the help of scikit-learn, you'll be implementing different algorithms such as linear regression, logistic regression, and so on. And if you want to implement deep learning algorithms or artificial intelligence concepts, then you would need to work with frameworks such as Keras and TensorFlow. What exactly is TensorFlow? So TensorFlow is a deep learning framework with the help of which you can implement neural networks. So we have something known as artificial neural networks, and if you want to implement these artificial neural networks, you would need these deep learning frameworks such as TensorFlow or Keras. How to install NumPy and Matplotlib in Jupyter? So it's very simple. I'll just show you over here. So if you want to install a library, all you have to do is type in pip install and then give in the name of the library. So if you want to install NumPy, give in pip install NumPy. If you want to install Pandas, you'd have to type in pip install Pandas. Similarly, if you'd have to install Matplotlib, just type in pip install Matplotlib over here. So that is how you install different libraries in Anaconda. 4 pillars of data science or machine learning. The first pillar is statistics, as statistics forms the core component of data science, machine learning, and artificial intelligence. And if your statistics concepts are not clear, then in that case you will not be able to properly comprehend the machine learning or data science or the AI concept. So that is why it is extremely important to have your basics in statistics clear. You would need to know what are measures of central tendency, you would need to know what are measures of deviation, you would need to know about different probability distributions, and there is a probability distribution known as normal distribution, and this is an extremely crucial point when it comes to most of the machine learning algorithms, because we would normally prefer our data to be in the form of normal distribution. So once you're good with statistics, then you will head on to programming. Now, when it comes to programming, you have 2 main languages with respect to data science, which are Python and R. And again, I'll repeat this. This is not a case of either or. I would recommend you guys to learn both Python and R, because both of them are equally important and it would depend on the project. So when big companies out there, it would depend on the project. So one project, maybe you will be using Python, and immediately for the next project, you will be using R. So it totally boils down to what project you're working on. So the first pillar is statistics, second pillar is programming language, then the third pillar would be machine learning algorithms, So you would need to understand. So if you are good with the stats part and the math part, then you will be able to easily understand the underlying concept of these machine learning algorithms. You'll be able to properly comprehend what is linear regression, logistic regression, decision tree, random forest, naive. My Twitter developer account hasn't been, it hasn't been yet restored, so the code will be pretty small over here. So what we'll do is we'll quickly go ahead to the code for Twitter sentiment analysis. We'll see what is happening over there. So this, what you see, is the code for Twitter sentiment analysis. And before all of this, we would need an API. We would need the Twitter developer API. So we would need the Twitter developer API. Just type in Twitter developer API over here in Google. Select this link. This first link which you see, this will open up. You would have to click on apps over here. And when you click on apps, you will actually get an option to create a new app. But my Twitter developer account was suspended for some reason, because maybe I was taking a lot of live sessions with this Twitter account. So that is why it would have been suspended. So what happens over here is, once we create a Twitter developer account, it would give us an option to create a new app. So this, what you see, when you click over here, you will be able to create a new app. And when you create a new app, you will get 4 things over there. The first is known as the consumer key. Then you will have something known as consumer secret. After that, you will have access token, and you will have access token secret. So you will need the values for all of these. And since my Twitter developer account is suspended for now, I will not have the access to these. So I'll just explain what this code does. And unfortunately, I'll not be able to show you or extract the tweets from Twitter because my Twitter developer account is suspended right now. So I'll just explain this entire code to you guys. I will start off by importing all of these required libraries. So the first library is obviously TweePy, and with the help of this TweePy library, we will be getting access to this Twitter developer API. If you want to access Twitter through Python, then we would have to install this TweePy library, and the command will be the same. You would have to go over here, you'd have to type in pip install TweePy, and this is how you'll be able to install this particular library. Then after you have installed this library, you would also have to install this library called as Authentication Handler. And with the help of this Authentication Handler, you'll be basically able to authenticate your consumer key, consumer secret, access token, and access token secret with Twitter. So this is, you can just consider to be an authentication check which Twitter does. So here, once you have these, Twitter just ensures that your key, secret, token, and all of them are actually verified. And to verify this, you would need this. And to actually understand the sentiment of the tweets which you extract, you would need the text blob library. Again, to install, you'll just go to Anaconda, you'll type in pip install text blob, and once you install this library, you can just go ahead and import this. So here you will type in from text blob import text blob. So now that we have all of our required libraries over here, and once we create our app, we will have the values for consumer key, consumer secret, access token, and access token secret, and you will just go ahead and add all of those values over here. And once you add all of those values, you would have to authenticate your tokens. So to authenticate your tokens, again, you would have to keep that in this exception handling bracket. You will have try and accept. And you will do this because, let's say, if your authentication fails, then you would have to print out something. So here what you do is you will use this OAuth handler, and you'd have to create an object of this. So to create an object of this, you will have OAuth handler, and inside this you will just pass in consumer key and consumer secret, and that you will store it in this object called as self.auth. And once you have this object, you will set the access token and secret. So here you will have self.auth.set access token, and inside this you will pass in access token and access token secret. Once all 4 of these are set, you will type in tweepy.api and you will pass it the object which you have created. And this is how you will set the authentication with Twitter. And once the authentication with Twitter is done, we have this Twitter API over here. So API.search, and whatever you would want to search, whatever term. So let's say if you would want to analyze the tweets of IPL, you will just type in IPL over here. And right now we have a lot of YouTubers just booming up with Binod. So let's say if I maybe just type in Binod over here, I'll get all of the tweets with respect to Binod. Similarly, maybe if I want tweets with respect to FIFA, I'll just type in FIFA over here and I'll get all of the tweets with respect to FIFA. And that is something I'll go ahead and store in this object called as tweets. Now this tweets object will have all of the tweets with respect to FIFA, and what I'm doing over here is with respect to the for loop, I will be printing out every single line of the tweet. And once I print out every single line of the tweet, as you see, I have this text blob method over here, and with the help of this text blob method, I will be able to analyze this. So this result, what you see, analysis, will give me three things. This will tell me whether my tweet is positive, negative, or neutral. So the rating will be between 0 to 1. So if it is 0, it'll actually be between -1 and 1. So if it is -1, then it will be extremely negative. If it is +1, then it will be extremely positive. If it is 0, then it will be neutral. So this is something you will get with text blob over here, and this is how you can perform Twitter sentiment analysis. And if you want the code for this, I believe if you have already registered over here, then you will get the code for this and also the sessions PPT. And if you are somehow not able to access the code for this, you can just send us a mail and we will forward it to you. How many months are required to become an expert in DS? This is again an interesting question, and I'd say that is very subjective and that would differ from each individual person. And that is because, let's say, what I learn in 1 month would be completely different with respect to what someone else can learn in a month. And it would depend on how much you practice. So I can just tell you what are the different things you can, you need to have expertise on, and it will totally depend on you, how much time it is required. So the first part is statistics. You need to be absolutely perfect with statistics. Once you're good with statistics, you need to be good with both Python and R. And once you're cleared statistics, once you have expertise with both Python and R, you would need expertise with all of the different ML algorithms. So in ML, we again have supervised learning algorithms and unsupervised learning algorithms. In supervised learning, we have algorithms such as linear regression, logistic regression, naive-Bayes, SVM, and so on. And in unsupervised learning, we have algorithms such as k-means clustering, hierarchical clustering. Then we would also have principal component analysis, LDA. So these are the different techniques which come under unsupervised learning. So once you have expertise with this as well, you can go ahead and combine all of your knowledge, and then you can work on more of open source projects, and that is when you can improve your expertise. You can go to this site called as Kaggle and keep participating in more of data science contests over there, and you'll have more of expertise. So I'd suggest you need to have expertise over all of these. But if you ask about the time duration, that is totally a subjective question, and that will totally boil down to you. To run the code, sure, I can run this, but we will not get the result because, as you see, I don't have these values over here. The consumer key, consumer secret, access token, and access token secret, these are the values which I'll get if I have an app. But since my Twitter developer account is suspended over here, I will not have values for these. So I have run this, and when I click on over here, as you see, I get unexpected indent. I'll also remove this. I'll remove all of the indentations. But even then we'll get an error because these are not the actual access keys and consumer secrets over here. I would need some real values. This is also done. And here an indent does not match. So let me actually put in some proper indentation over here. I'll keep it over here. Let me remove the space from here. Let me also remove the space from here as well. Let me give in one single tab over here. Let me keep it at the same indentation. This also I will give it at the same indentation over here. Now if I hit on run, you would see that authentication has failed. And we get this because we don't have the right consumer key, consumer secret, access token, and access token secret. So if you have a proper Twitter developer account, you will have access to all of these. You can go ahead and put them up over here, and you will your authentication will succeed over here. What point of learning we can start taking part in Kaggle contests? Once you're good with all of the Python libraries, so once you know that you're good with all of the Python libraries, and once you are good with all of the ML algorithms as well, so you need to know at least maybe around 3 to 4 supervised learning algorithms and around maybe 2 to 3 unsupervised learning algorithms. So I'd say that is when you can go ahead and start competing on Kaggle. So there's this very simple there's a very simple contest called as Titanic Dataset. So that is what most people start off with on Kaggle. So you can go ahead and start working with that Titanic contest on Kaggle, and it will be easier for you. There would be a lot of entries, so you can just submit your entry and see where you rank over there, and you can keep improving your model and see how does it improve. What exactly is a Kaggle? So this is analogous to websites such as HackerRank or HackerEarth. So HackerRank and HackerEarth are coding websites where you have contests with respect to data structures and algorithms. So similarly, if you need contests, if you need data science contests, then these data science contests happen on this website called as Kaggle. You can consider this website of Kaggle to be the mother home of data science, and you have a lot of contests over there. And most of the companies actually recruit from Kaggle. So if you maybe in some of the contests, if you rank in the top 10 throughout the world, then the top companies directly hire from Kaggle itself. Is R language necessary for DS or Python? And as I've told you guys, I'd recommend you to learn both R and Python. This is not a question of either or, this is a question of Python and R. And also it is not difficult to learn another language if you know one. If you know Python, you can easily learn R, and if you know R, you can easily learn Python. What does text blob do? Please repeat. So text blob, it gives you an analysis over here. When we pass in this text, this will basically give us 3 things. Those 3 things are positivity, negativity, and neutrality. And we are storing that in this object called as analysis, and the result will be between -1 to 1. So if your result is closer to -1, then it would mean that your tweet is negative. Similarly, if your result is close to +1, then it would mean that your that tweet has a positive sentiment. Similarly, if the value is close to 0, it would mean that the tweet is neutral. What is the strategy for practicing ML algorithms? It's the same strategy. Make sure that your statistics part is extremely good. And once you're good with all of the statistics concept, and it's not only statistics, it's also probability. And there's one very important concept in probability which goes by the name of normal distribution. So for all of the folks who would want to start learning machine learning algorithm, you would definitely have to learn about probability distribution and normal distribution. Keep this in mind, because when you're implementing machine learning algorithms, most of the algorithms, they would require your data to be normally distributed. So this is something which you definitely have to learn. Then after that, you have a concept in statistics called as central limit theorem. And this is also something which you need to understand properly. Then you have concepts such as hypothesis testing, p-value, and so on. And this hypothesis testing would help you to put up a problem statement and come up with an answer to that problem statement. Once you're good with statistics, then you have to learn programming languages. That is when you'll be properly able to understand all of your machine learning algorithms properly. Can we use Hadoop in Python or not? So Hadoop is totally different. So Hadoop, it mostly deals with big data, and it is a storage system. It is not an analytic system. So Hadoop is more of a storage system, and it would help you to store terabytes, petabytes, and exabytes of data in a proper place. That is where Hadoop comes in.
Let's start with introduction to machine translation. For this, we will be taking an example. Suppose you work in a MNC firm and your company wants you to go from India to France to attend a business conference. And the thing is, you don't know any other language other than English and your native language. So suppose they gave you a boarding pass and they asked you to travel to France. So now you boarded the flight and you after 12 or 13 hours, you reached France. And now the moment you reached there, you felt that you are hungry. Okay. So now you are feeling hungry. So then suddenly you saw a pizza outlet there. So the moment you entered the pizza outlet, you saw everything is written in French because it's a France. So a natural that most of the thing will be written in French. So everything is written in French, and you don't have any other friends who knows French, and they are with you. Okay. So what will you do? The moment you get the menu, you started scratching your head. So then suddenly you got an idea that yes, you can use the Google Translate or Bing Translate or any other translate application. So you open your browser and then you typed the keywords that are written in French and then you can translate them into English and then you can order it. Okay. So this make your life easy. So this is all about machine translation. So machine translation is a field of AI which enables or which gives the ability to a machine to translate your language from like from one language to the another language. So some of the examples of AI driven machine translations are Google Translate, Google Assistant, Facebook Translate, Grammarly, Siri, Alexa. Then there are a couple of browsers which allows you to translate whatever written in a browser from one language to another language. Now let's discuss some of the machine translation techniques available. One of the most predominantly used or most widely used machine learning translation technique is statistical machine translation technique. So what is statistical machine translation and how it works? So let's see. Statistical machine translation uses parallel corpus to train a machine translation model. So what does it mean? Let's say there is a language X and there is language Y. Okay. And we want to translate from X to Y. Let's say X has A, B, AB, AC, C, D. The corresponding values for Y would be, for the training set would be, let's say 1, 1, 2, let's say 1, 2, 1, 1, 2, then it will be 1, 1, 4, or let's say 1, 6, okay. Then C would be 6, or it would be 14, 1, 4. Then D would be 9, okay, and so on, okay. So there will be for each corresponding data points, there will be the value for Y, okay. So it will translate in such a way that for X, what is the data point and corresponding data point present in Y, okay. So this way it will translate the or it will train the model, okay. So the goal of SMT is to translate a sentence from source language to a target language. So mathematically, suppose that we want to translate a Hindi sentence that is Y given a sentence X that is written in Tamil, okay, or the that the speaker is speaking in Tamil, okay. So this will use this formula that is nothing but a Bayes theorem, okay. So it will be, if we just elaborate it, it will be arg max of Y, P of X, Y, and P of Y. So this will be your probability, or we can say uh, machine translation model, and this will be your language model, okay. So let's try and understand how this function works, okay, with an example. So let's suppose Rohan was supposed to study with me. I called him, but he did not. Then there is a blank. Okay. Now suppose we want to fill this word and want to complete the sentence. Okay. So based on the probability of this word, or the most suitable word, we can find out with the help of, let's suppose we have corresponding corpus. Answer, well, good, go, study, have. Okay. And then there can be more words like that. Okay. So like with did not, what is the word whose frequency is highest? Okay. So if we see and since we know English language, so we can understand that have has the highest frequency. So if we write did not have, okay, so with the probability we are able to fill this the next word, but is it making sense? No, this is not making sense. Okay. So what can be the answer? So let's suppose that highest probability was answer. Okay. So in that sense, answer is the correct word which we get. Okay. So there is a probability, or we cannot say that it's a fixed that we will get the correct next word which will fill this blank. Okay. We can fill it with have, we can fill it with go also. Okay. So it has been seen that although statistical machine translation model works well, but in some of the cases it does not perform well as it is expected from it. Okay. So in order to tackle this issue, we have a model that is known as neural machine translation model. Okay. Now let's see what is neural machine translation model. Okay. So SMT model was very complex, and we saw with the example that some of the time it does not perform well. Okay. So then come neural machine translation model. Okay. So neural machine translation model uses sequence to sequence architecture, which involves two RNN. Okay. Then encoder encodes the sentence and feed this encoding to decoder, and then decoder produces the target sentence. Okay. So let's try and understand this. Okay. So what happens that there is a input. Okay. So this goes to a black box. Okay. This is a black box. Okay. So this black box is neural machine translation. Okay. And for that input, it gives you output. Okay. So now further break this down. What is happening? Let's say we have input. Okay. This input goes to here, this sequence to sequence model. So here we have encoder, we have decoder. So I'll just write E and D for the same. Okay. So it goes to encoder, then encoder encodes it, send it to decoder, and then decoder decodes it and produces the output. Okay. Further, how this happens, let's elaborate it furthermore. So encoder encoded it into a contextual vectors. Okay. And that contextual vector goes to decoder, and then decoder decodes it and gives us the output. Okay. We will go and discuss this, what is the structure of encoder, what is contextual vector, and what is decoder, and how it produces the output, how input goes there. So we will discuss those things later in this slide. Okay, so we just wanted to discuss that what is encoder decoder on a broader picture. So before we go and discuss what is a sequence to sequence model, let's recap and try to understand the natural language processing concepts in deep learning. So there is a concept of text vectorization. Any machine learning model, be it random forest, be it logistic regression, or it's a CNN, or it's a RNN, LSTM, GRU, you name any model, they work on numerical data. And since NLP deals with textual data, so we need to transform the textual data to a numerical data. So text vectorization is technique with the help of which we can transform or we can convert our text into numbers. So some of the predominantly used or most important text vectorization techniques are bag of words, TFIDF, word embedding, and character embedding. So, what is word embedding? Or let's start with what is bag of words. So, bag of words is nothing but bag of word is a technique in which from the entire text corpus, let's say we have a raw data and then we do the processing. Okay, we do processing, and after processing we get a data. Okay, so this text data will go into a box. Okay, for understanding, we can understand that it's a bag. Okay, like a bag of coins, it's a bag of words. Okay, then there each word will go and corresponding their IDs will be there, so that whenever we want to identify or we want to convert that from text to number, we can convert it. Let's take an example. This is car. This is my bat. Okay, so what will happen? Each word, this is a car. Since this is already present and is also present, my will be the next term and bat will be the next term. So correspondingly, they will get some values or they will get some IDs to uniquely identify them. Let's suppose it will get 1, it will get 2, it will get 3, this will get 4, this will get 5, this will get 6. Okay. Then suppose there is a new term comes. This cat is not mine. Okay. So when we will translate it into vectors, what will happen? This will get 1. Cat, since we don't know cat, and in our vocabulary, cat is not present, so it will get 0. Is will get 2. Since again not is not known to the model, so it will get 0. And mine is also not present known, so this will get like this. Okay, like similarly, if we translate this car is mine, how we will get the vector form for that? This will get 1, 2, 3, 4. Similarly, this will get 1, 2, then 5 and 6. Okay, so this way we do the transformation using bag of words. Okay, so let me erase this. So now let's try and understand what is TFIDF. So TFIDF stands for term frequency inverse document frequency. So what it does, in a very crisp words, we can understand that those documents which are present in the corpus and they have less frequency of occurrence will get higher precedence or will get more weightage than those words whose frequency are higher in the corpus. Okay, so now let's move on to our next slide. What is word to vec? Okay, so word to vec is a word embedding technique. Okay, now we discussed a bag of words. Okay, so what typically happens that in bag of words or in any normal model when where we are uniquely giving IDs to each token and then we are creating it. Let's suppose that we have a corpus. Let's say C is the corpus that has total 10,000 unique words present. Okay, and if I write this is my bat. Okay, so what will happen? We will get a 1 is to 10,000 size vector. Okay, so this will be translated something like that into, there will be some values. Okay, similarly, let's suppose a total number of document we have 1 lakh. Okay, so the vector size or our vector will be cross 10,000. Okay, so this will be a sparse matrix. Okay, so this sparse matrix is very difficult to pass through the model and train a model which can perform well. Okay, so in order to tackle those issues, word embedding came into picture, and one of the techniques of word embedding is word to vec, where we, instead of uniquely identifying or uniquely giving weightage to each word, what do? We do the word embedding, or we do the word to vec with the help of features and the word. Okay, so let's suppose the how it works, we can understand that there is a king plus boy minus queen. Okay, so what does this means? Okay, so to word embedding or to word to vec, since we are passing king. Okay, so king has certain properties. Some of the properties would be power, army, land, money. Similarly, gender of king. Okay, similarly, boy has certain properties, like what is the color, where to which location he belongs, who is the father of this boy. Then similarly, what like what is his gender. Okay, since like this is male, this is male, and minus queen. That means this person is not female. Okay, so predominantly we can say that he is prince. Okay, so this is the way by which word to vec work. Okay, so there are two types of word to vec available. One is C bag of words and character based bag of words, and another one is skipgram word to vec. Okay, now let's move on to our next topic, that is character embedding. So character level embedding uses character level composition and provides a numerical representation of words in one dimensional convolutional neural network. Okay, now let's try and understand what is RNN. RNN stands for recurrent neural network. Okay, so why RNN came into picture? Before we go and discuss the architecture behind this and how it works, let's try and understand why RNN came into picture. So before RNN, we had CNNs. Okay, so in CNN models, they are very good with the image kind of a data, or data where we don't need the information from the previous state or the from future state. Okay, so if we have the present state, then in those cases CNN works well. Now let's take an example of text data. Suppose you are watching some Marvel series movies. Okay, now since you know that the Avenger series, in Avenger series, what kind of like what happened in the last season or what happened in the last movie. Based on that, you can understand that what are happening in this situation. So now suppose we train a CNN model on top of that. So since CNN model does not know or does not hold the previous information, since they don't have any holding technique, or they don't have the memory, so what typically happens that in CNN models, they do not perform well with the text data. So in order to tackle those issues, RNN came into picture. So RNN stands for recurrent neural network, as we discussed. So RNN has a memory state to grasp or to hold the memory. So if we try and understand that what happens here, so in any RNN cells, okay, we have two inputs. One is our input vector and the other one is hidden state. Okay. So if we try and understand it, what happening here, that there is a input, then there is, once a model it starts with hidden state 0, or we can say H0. Okay. So this input vector 1 goes there. Okay. So these goes to the model. Okay. So this model, and then correspondingly your output will be generated. Okay. And your hidden state 1 will be generated. Okay. So this continues. So if we see here in this example, let's say this is nothing but a, we can say, a breakage, or how this works. It is shown here if we unfold it. Okay. So it starts with ht minus 1 hidden state when t minus 1. The input vector goes there. Okay. And xt minus 1, the hidden state goes there. Okay. And we get output t minus 1. Then this vector goes here, and this xt will goes there. Okay. This will generate qt, then qt plus 1 will be generated in this state when we will be providing ht plus 1 and xt plus 1. Likewise, it holds the previous information and the previous state. This enables, or this allows the RNN to keep the information with itself. Okay. So this way, RNN outperform CNN in textual data. Okay. Now let's move on. But we have seen that there is a exponential gradient problem in deep learning. So what is exponential gradient problem? Exponential gradient used to update the weight in the right direction with right amount. Okay. So when your model is training, so with the help of understanding that how much your model is not performing well, error gradient are used to update and to just tweak the model weight to make it like better, so that it can perform well. Okay. So in RNN, during training, some of the time what happens that this RNN, this error gradient accumulate and may update the weight with very large gradient. Okay. So as a result of it, we see a like explosion. Okay. This explosion disturbs the model's state. Okay. And due to which models completes training, although, but it does not perform well as it is expected from it. Okay. So in order to tackle those issue, then LSTM and GRU came into picture. Now let's try and understand LSTM. Before we go and discuss the architecture of LSTM, let's try and understand LSTM with an example. Suppose you are watching television. Let's suppose you are watching FIFA. Okay, it's a match between Portugal and Argentina. Okay, so then suddenly your mobile phone starts ringing. Okay, and look who is there. It's Rohan. Okay, and Rohan is calling you after a very long period of time, that is 5 years. Okay, so the moment your mobile starts ringing, you pause your or you mute your TV, and then you pick up the call. Okay, and you started conversing with Rohan. Okay, so what did you do? First, you stopped the television or you pause the television. So by this, what unintentionally you did, you just get away from the state where you were there, and then you start conversing with Rohan. Okay, then you guys started discussing how did you guys studied during the college, and how is Professor Sumanto, or how is like Roop sir is doing and all. Okay, so then the moment you guys started the conversation. Okay, so what happens that with the all the information or the data which Rohan is providing you, then you're recalling those things. Okay, and based on those recalls and based on those information, what you started responding to the opponent or to Rohan. Okay, so now let's understand the same example with this LSTM architecture. So this is known as cell state. This is known as your forget gate. Okay, so this is the cell state where you were there before talking to Rohan, watching television. Then this is forget gate. The moment you started conversing with Rohan, you decided what to keep and what not to keep. So you decided that I will not be watching the match. So you stopped the match, or you stopped the information which you are getting from the live match. Okay, so this is how gate works. Then there is another gate that is known as your input gate. Okay, so based on the forget gate, okay, you decide that it's a sigmoid function. Like you decide that what to take and what not to take from the information which Rohan is giving you. Okay, so this is your input gate. Then based on that input from Rohan, you update yourself. Okay, and you got to know what is happening in your college. Let's suppose how is your teacher is doing, or let's say how your mentor is doing. Let's suppose that how your Anjali ma'am is doing. Okay, so you got to know from Rohan that now she is in Massachusetts. Okay, so these kind of information you are getting, and based on that you are giving the response. Okay, so this is the output. Okay, so LSTM has three inputs or three gates. One is forget gate, which allows you to keep certain information and to what to keep and what to remove. We can do it with the help of forget gate. And then input gate is with the help of forget gate and the previous state, you can take a decision which information to keep and which information not to keep. Okay, so this is the input, and with the help of this input and all, you can update your output. Okay, and then you can give it. Okay, so this is your next state, and this is the cell state. Okay, so it's a same. Then there will be one LSTM set, then there will be one LSTM and one LSTM, and it will go on till how many units you want to keep for the LSTM. Okay, so this is the basic functionality how LSTM works. Okay, so now let's move on to the next slide. So GRU is also similar kind of a model. Okay, but it has only two states. One is reset, and another one is known as output. Okay, so it has opposite to or not similar to LSTM. It has only two output. One is update. Okay, which does update your values. Okay, and reset is doing the same thing, like what to keep and what not to keep. Okay, and then it gives you y hat and the output and the next state. Okay, so then there will be one more GRU attached to it, then there will be one more attached, and then similar to LSTM architecture, it is same. But GRU and LSTM works similar to each other, but GRU has only two gate, that is update gate and reset gate, but LSTM has three gates: forget gate, input gate, output gate. Okay, so what is sequence to sequence model? Till now we have covered the basics of natural language processing, which we use in deep learning. Now let's try and understand what is sequence to sequence model. So in order to solve complex tasks like language translation, creating a chatbot, text summarization, question answer system, sequence to sequence model works very well, or it has been seen in various fields where sequence to sequence model works best for this. Okay, so encoder decoder architecture is one of the most common sequence to sequence model architecture available in the market. So there is one encoder, so it encodes the output and gives a context vector, and this will go to decoder, and then decoder will give you the output. So this is the basic structure of how encoder and decoder works. Okay, so now let's discuss them briefly. So before we go and discuss encoder and decoder, let's discuss some of the real life examples of sequence to sequence model. Some of the examples which we use in our day-to-day life is Google Translation, Google Assistant, Siri, Grammarly. Then we use Google's Smart Compose. We use Android Smart Keys. We also use Alexa. Okay, these are some of the sequence to sequence based models use case which we use in our day-to-day life. Now let's discuss how encoder decoder model works. So this is the basic structure of encoder decoder model. So encoder decoder model both uses RNN. Okay, so it can be LSTM or it can be GRU. Okay, so these can be the RNN models which we can use in decoder encoder, but we need to keep in mind that if we are using LSTM, then we cannot use GRU here. Okay, we will use only LSTM. Okay, or if we are using GRU, then we will not be using LSTM. Okay, we will be using GRU. Okay, so now let's try and understand how this encoder decoder works. Okay, so we can have a box something like that. Let's call it encoder denoted by E. Okay, and we have a decoder, the same as shown in the picture, that is decoder denoted by D, and it has few RNN states, and similarly this has few states, this. Okay, now suppose I want to feed a input. Okay, let's write how are you. Okay, and this gives you a output, I am good. Okay, so first this how will go. Okay, so I'll just mark it 1, this as 2, this as 3. Okay, so the moment this will how will go to this. Okay, this 1 will go, then this h1 is generated, that is hidden state 1. Okay, so then this will go to the model. Okay, as shown in the picture. Then similarly 2 will go. Okay, then this 2 will go. Okay, and it will generate h and this will generate h2. then this H2 will go, and then this 3 will go. Okay, and this will generate H3. Okay, H3, and this H3 will be your context vector, we can say, or we can say encoder vector. Okay, as shown it here. Okay, and this will go to this. Okay, so the moment it will go here, it will generate I. Okay, then this will go to the next context, it will generate M. Then this will go to the next context and it will generate good. Okay, so if we see closely in this diagram, what we can see that in the second box or the decoder, we have the outputs and we have the next hidden state. But in this, if we see closely in this encoder, we don't have the output from this RNN. So the RNN architecture of encoder is such that they don't produce the output. Okay, and we don't or we can say we don't store the output here. Okay, instead of that, we provided the hidden state. Okay, so this is the basic structure of how encoder decoder works. Okay, so now let's move on to our next slide. So encoder decoder using teacher forcing. So what happens that when we train our model, okay, so sometimes this happens that encoder decoder model takes very long time to process. Okay, so encoder decoder model are known for taking very longer period of time to train, and some of the time they overfit itself. Okay, so in order to tackle that, we use the teacher forcing. So how teacher forcing works, that when this hidden state 3, let's say H3, goes to this, okay, to this encoder vector. Okay, this encoder vector, let's suppose that this is H3, it goes there Y1. Similarly, there is one output. This is your decoder input. Okay, so this is your encoder input. We do not directly give the x1, we do the embeddings. Okay, so be it word to word embedding, like be it word to vec, be it character based embedding, be it one hot encoding embedding, anything. Okay, bag of words embedding, but we do provide this encoding to this x1, x2 and x3 are nothing but the input vectors. Okay, so this goes there. Similarly, this decoding input is nothing but the input vector for the decoded, the correct output. Okay, so this goes there. Okay, so the moment it goes there, and the moment it predicts, let's suppose that it predicts y11. Okay, and then it checks with this decoded input that whether the output which it is generating is correct or not. Okay, so our correct output is y1. Okay, so the model will penalize itself. Okay, the optimization technique will start working, and it will penalize the model. It will do the like update the weights of the RNN model, and then it will refit itself so that it can generate y1. Okay, so this way we get the better result by applying teacher forcing in encoder decoder model, and it also stops model to getting overfit, as well as it helps us in, it reduces the time taken to train the model. Okay, so let me erase this. Now let's move on to next slide. So what are the drawbacks of encoder decoder model? So it has been seen that the encoder decoder models have limited memory. Okay, so since we are using LSTM, okay, so it can perform well with longer text, but this cannot work well if we are passing an entire like sentence, or a sentence is containing 100 lines of text. Okay, in such situations, encoder and decoder model not perform well. Okay, similarly, model does not perform well when the length of the string is greater than 10. Okay, so with the help of blue score, in various researchers researched, and they found out that with increase in word length, the blue score started decreasing. Okay, so blue score is the parameter with which we can judge the performance of any encoder decoder based model for machine translation. So this has been seen that with this, it starts reducing. The blue score starts decreasing. So in various researchers found out, after performing various research, they found out that if the word length is greater than 10 or is 10, okay, it does not perform well. This is not a thumb rule, but this has been seen in various situations. This can be opposite of that for some of the cases when our data is different. Okay, since we know that machine learning or deep learning model works on data. Okay, if your data is correct, model will perform well. If your data is not correct, model won't be able to perform well, whatever technique we can try. Okay, so this depends upon the type of data as well, or the data and the frequency of the words. But it also has been seen that with a longer string, a model does not perform well. Okay, now let's try and solve a machine translation use case using Python programming language. Here we will be using encoder decoder based architecture with teacher forcing, and for this use case we will be using English to French language translation dataset that is freely available in kaggle.com. You can use this link to download the data. So now, without wasting any time, let's get started. So first, we will be loading the packages that are necessary to doing all the pre-processing stuffs. So we will be loading pandas and numpy. So now we have downloaded this data from the kaggle.com. So now let's upload this data. So we loaded the data, and now let's see. So there is a English word corresponding to that. We have a French word or a sentence. So like for example, hi, and corresponding to that there is salute. Okay, run, then cause. Okay, and then I'm not well versed with French words, so I'll prefer not to spell them. Yeah, but we can understand from this data that for each data point in English, there is a corresponding data point in French. Okay, so like we discussed in statistical machine translation model, that it's a parallel corpus. Like for X there is Y, for X there is Y. Okay, now let's move on. So what we will be doing first, we will be identifying, or we will be finding out the length of the string. Okay, so with the help of a string function, we will be first splitting them into a chunk of words, and from those tokens we will be counting the length of them. Okay, so let's take an example how this works. For example, let me create a, so this will create a list. Okay, so what it will do, it will create all the words into a tokens, and that tokens will be stored into a list. Okay, and then this str.length will do str.len. So let's execute it. It will take some time, so it will find out that how many words are present there. Let's, for example, let's see, there is one word, so it will count one. Okay, so now let's execute it. Okay, similarly we'll execute it for French also, and now let's see the data. So now we can see that there is English word count and French word count. Okay, so for the sake of this encoder decoder model, and we know that encoder decoder model does not perform well when the string length are very large. Okay, so for this purpose we are strictly using the length till 5. Okay, so if anything that is greater than 5, we will not be using those data points for training and for testing our model. Okay, so now let's execute it. So if we see, earlier we had 1,76,621 data. Now we have 54,212 data. Okay, now there can be a situation that we have a duplicate data, and when we have a duplicate data in our model, we need to drop them off. Otherwise, there can be a situation that our model will be overfitting. So with the help of drop duplicate function of pandas, let's execute it. Now let's see how many data. So we didn't have any duplicated data. So now we have our data ready. Okay, so now let's divide the data into train and test. Okay, so before dividing the data into train and test, let's just understand basics of how train and test split works. Okay, so let's suppose this is our entire data. So this is our data. Okay, let's say it has 100 data points. So in our unique data, let me write it unique. Okay, so from those unique data, first we divide the data into train, and as well as we divide it into test. Okay, after dividing the data into train and test, let's suppose that we divided it into 80 and 20. So 80% will be the train and 20% will be the test. And since we are using train test split, so our data will be stratified sampling. That means the proportion of the data would be same. Okay, there won't be a situation that one type of data would be in train and the other would be on the text. So there will be a mixture of the data. So now we have this 80-20 ratio ready. Now this further we can divide it into further train and validate. So this can be 80% and this can be 20% of that, so that we can train the model, and for validation and for optimization of the model we can use this 20% of data. And once our model is ready, then we will be using this 20% of the data that is totally unknown to the model. The model is not knowing about that data. That data is unseen to the model, and based on that data we will be try and will try to find out that whether our model is performing well or not. So this is the best technique whenever we are dealing any machine learning or deep learning model. Okay, so we need to divide the data into three parts. First, train, test, then that train will be further divided into train and validate. Now, let's divide the data into train and test using train test split. So we have divided the data into train and test. It will take some time. Now, let's see how many words are present in train set, how many French word maximum present in text set. So it would be 5, because we are not keeping those data points whose word length is greater than 5. So now further we will be dividing this train data into train and test with test size as 20. So we have divided it. Now let's calculate the this word frequency of English term and French term. Okay, that is available. So let's execute it. Now we have this is this English and French frequency words of CSV file ready. This takes typically 10-minute time or something like that. So I had already executed it, so I'm not going to execute it. So instead of that, I'll just load this data and now see. We can see that in English, the words and their frequency. Okay, and the frequency is such a way that the highest frequency terms is get on the top. Okay, so it's a decreasing in the order of decreasing frequency. Okay, similarly the French keywords are there. Okay, now let's do the data pre-processing. Okay, So whenever we are preparing the data for any machine translation model or for any sequence to sequence model, we provide a start token. Okay, let's say start, then whatever is our input, then we provide the end. Okay, so this we do with all the data. Okay, so that the model will understand what, from which point of data the model is starting and from which part of the model it is stopping. Okay, so to know the start and end of the data, we provide two anchors, that is start and end. Similarly here we are providing start and end to raw lines. Okay, so we are using the whatever the data we are getting, to that data we are appending it with the start and end. Okay, now let's see. So if we do this, we can see it in English that every sentence that start, I am just a teacher, end. Okay, are you getting tired, start, end. Okay, likewise we will do it with the French word also using this get word function. So let's execute it. So now for each French words, we have that start and the end string. Okay. So now we will do the, for the validation data also. We had did this with the train data. So now let's do it with the validation data. Now we have the validation data ready. Okay. So now since we are using the frequency of words maximum of 5, okay, and there can be minimum of 1. Okay. So what will happen if our input is 1? So let's say that the token gets for high. Okay, the high term will get uh, frequency. Like let's say its token ID is 1. Okay, so it will be 1. Okay, then there will be some term whose like number of tokens are present, 1, 2, 3, 4, 5. Then there will be 1, 2, 3, then 1, then 5, then 5 and 4. Okay, and things like that. Okay, so how can we normalize them, or how can we just fix the length of each of the terms? Okay, so to do so, we use the term padding. Okay, so we pad the each term after it, and we can do it with the pre and post. Okay, so here we are using post. Okay, let's say there is two tokens, 240 or 254 and 2. Okay, then there are three spaces. Those three spaces will be occupied by, let's say, 0. So 0 is our padding. So after the, once the string gets completed, this will be filled with the 0. Okay, so we are using the tokenizer from Keras. Okay, and then we are creating a token, this frequency token, French token, English token. Okay, and then we are training it with the French trained word and English trained word, and then we are creating a padded sequence for each of the terms, like for English and for French. So now in the next thing, what we are doing, we are finding out the number of input token, number of output token, number of what is the maximum length of input and what is the maximum length of output. Okay, so let's execute it. This will take some time. Let's execute this also. So now it is executed. Let's execute it. So now we can see that each of the terms are getting at the end 0 is appended. Okay, now let's execute this. Now let's count the number of output tokens. So number of output tokens are 17187. Number of input tokens, that would be around 10,000. Now let's see what is the input length, maximum input length, that is 7. What is the maximum output length? That is also 7. Okay, now let's see French train word. Okay, that was something which I'm not very comfortable in reading. Now let's see the padded of French. So we can see this frequency of this. So this process is good, but we have a very good package known as ktext. Okay, so we will be using this ktext package to do all the data pre-processing. Okay, so this ktext package is you can download it using pip install ktext. Okay, now let's import ktext function. So now we have imported process. Okay, now we will be doing the cleaning, we will be tokenizing, and we will padding the each text. Okay, for this we are using all the keywords, that is 10407, and maximum padding length we can assign any values, but for now we will be assigning it to be 7. Okay, and then we will be creating a train vector. Okay, so it takes a longer time to process because it does all the cleaning, tokenizing, everything. Okay, so I'm not going to execute it because it takes around half an hour process. So this way we can create a pre-processing for English. Similarly, for train vector we can generate. For French also we can do the same thing. Okay, and once we are done with that, since we will be using this preprocessed vectors into whenever we will be deploying this model, or if we want to do the prediction with this model, so we will be keeping those values into dpickle files as well as numpy files. Okay, for saving it into a pickle files we are using dpickle. Okay, that is dill. Okay, and we are using numpy to store it as a numpy vector. Okay, so since we have not executed the above two portions, so I'm not going to execute this because once we get this train vector and this preprocessed files, then we are dumping them into English pp, French pp, similarly French trained vector and English trained vector. Okay, so once we do that, why did we do that? Because let's suppose that this takes around 1 hour to process. Okay, and now suppose when we have a data of 20 crore, what will happen with those 20 crore? Let's suppose it takes 6 hours to process. Okay, will we do each time this 6 hour will invest in pre-processing? No. So what we will be doing, we will use it for once, we will invest those 6 hours, and we can use the same file each and every time. Okay, that's why we have stored it into a pickle file, that is serializable file. Okay, whenever we want to use it we can use it, whenever we don't want to use it we will not import it. Okay, so suppose whenever we want to load those data. Okay, so this data, the numpy file, now we want to load that decoder input. Since we discussed that we will be using the teacher forcing, so we need the decoder input. While discussing the architecture of teacher forcing with in encoder and decoder, we discussed that why decoder input is important. Okay, so we will be loading it. So once we load it, we will be getting the decoder input data as well as decoder target data. Similarly, we will be loading the encoder input data. Okay, so we will be getting the input encoder input data as well as the doc length. Okay, so in order to load the any pickle file, the dpickle files which we have stored already, okay, we are using this load text preprocessor. Okay, so we will be passing the dpickle file, and that dpickle file will be open, and we will get the total number of tokens and the processed file. Okay, so it is returning that number of tokens and the pp, that is English pp and the French pre-processed. Okay, so now let's execute this. Now let's execute it. Now load it. Okay, since we have not loaded the dpickle, okay, so let me just copy it just add it here. Okay, so we will be loading the dpickle. So now we have loaded it. Okay, so the number of vocabulary in size of vocabulary is 6280 for English vocabulary, and the French vocabulary is 9998. Okay, now let's import the vector files. Okay, so with the help of load encoder and load decoder, we will be loading them. We will be getting the encoded encoder input data, decoder input data, the doc length, and the decoder target data. Now let's see how it has been processed. Okay, so for this French input, we get the text vectors. Okay, similarly for this English, we are getting the original text, and the after pre-processing we can see it. Okay, now for this model training and model building, we are using Keras. We will be using GRU. Okay, so now let's import the packages. Now let's create a encoder model and decoder model. Now let's try and understand encoder and decoder model, how we can write a code for that to create a encoder and decoder. So for this, we are using the embedding as 300 dimensional embedding. Okay, so our embedding is 300 cross 300. Now let's define the encoder model. So encoder model shape would be the doc length, that is 7. Okay, and we are saving it with the name of encoder input. Okay, now this encoder input will go to the embedding. That embedding has the number of tokens, the dimension of the embedding, and we are storing it to body word embedding. Okay, and we are passing this encoder input to it, and then we are doing the batch normalization. So that X will go to the GRU. Okay, and since it's an encoder, so like we don't need the output from the encoder, so we are not keeping the output from the encoder. We are just storing the next state. Okay, so that's the next state is there. Then we are building a encoder model with the help of model API. Okay, we are passing this encoder input output as a state H. That is, the output will be the last state or the context vector. Okay, and then we are creating a sequence encoder output, that is encoder model. To this, we are passing the encoder inputs. So this input which we have created here, so that we are passing it here, and with this we are creating encoder output. Similarly, let's define our decoder model. So for that decoder model, we are passing the shape as none. Okay, and we are keeping the name as decoder input for teacher forcing. Okay, since we are using teacher forcing, so we will be passing this decoder input to the decoder model. Okay, then we are creating a word embedding for decoder. Okay, that is, we are passing the number of decoder tokens, latent dimension, and we are naming it with the decoder token, and we are passing the decoder input to it. Then we are doing the batch normalization, and then we are creating a GRU model, and we are this is our GRU model, and to this GRU model we are passing the batch normalized output. Okay, we are storing it here, and initial state is our the sequence to sequence encoder output, because we know that how encoder and decoder works. Let me just draw it. So there is a encoder and there is a decoder. So this last state from the encoder, that is context vector, goes to this decoder. So this is nothing but that context vector. Okay, so now let's see, we have now we have that decoder output. Okay, so now we will doing the batch normalization for that decoder output, and then we will be passing this to a dense layer, and we will be using a softmax as a activation function, and then the model like we are storing it to a this decoder output by passing this x to this decoder dense. Okay, now then we are creating a sequence to sequence model. That is model, here we are passing the encoder input and decoder input as a output. Okay, and decoder output as output. Okay, these are our input, this is our output, and then we are compiling the model with loss as sparse categorical cross entropy. Okay, so now let's execute it. Now our model is ready. Now let's see how the model architecture looks like. So this is our model. Then what we are doing it here, we are just uh, creating a model checkpoint and CV logger. Okay, so why model checkpoint we are using? So now let's create a sequence to sequence model and train it. Okay, so before training the model, we are storing the loggers into CSV logger file. Okay, that we are creating a CSV logger that is with the name of tutorial sequence to sequence.log, and we are saving it into as local, and then we are creating a model checkpoint. So what model checkpoint is? Model checkpoint checks each and every iteration of the model, and till now the best model, whatever the best model is, we will be saving that model only. Okay, so by this way we just keep the model which performs better irrespective of like storing the overfitted model or the underfitted model. Okay, so this way we prevent the model to get overfitting and underfitting. Now let's see, for batch normal batch size we are using 1200 batch size. Epochs we are using 70 epochs, and that whatever the model history is during the training, we are storing it to history variable. Okay, so now let's execute it. So this takes usually this takes a longer period of time, so we can wait for some of the times, and we will not be keep the model running for 70 epochs because this takes time. So for that, what we have already done is we have trained the model completely, and the best model which was with us, we saved that model only. So for now we will be training the model for let's say, because this will take 1 minute time, and then if we keep on running for 70 epochs, this will take around 90 or 80 odd minutes. Okay, so I'm just stopping it for now here. So just keyboard interrupt. Okay, now let's delete this sequence to sequence model object. Okay, since we have stopped it at a bit middle. Okay, so now we will again create a sequence to sequence model object using this model, where we are passing this encoder input, decoder input, and decoder output, and we are compiling the model. Okay, so our model is ready. Now we can see the model lot summary. So we can see the same summary of the model. Okay, total number of parameter, what are trainable parameter, what are non-trainable parameter. Then we will be loading the model weights. So what typically happens that whatever the weight has been assigned to the model while training it, we have stored it, and that we will be feeding it to the architecture of this sequence to sequence model. So now let's execute it. So now we have our model loaded with that. Okay, so now we have our, since we have already trained it and we have loaded the weight to the model. Now let's see how model has performed. Okay, so for that we will be extracting the encoder model and we will be extracting the decoder model. Okay, so first for that encoder model, let's create a function extract decoder model. Then we are passing the entire model. For this we will be passing this sequence to sequence model. this will give us encoder model dot get layer. Okay, if we go up, we can see that while defining the model, to each model we name them. Okay, let's say encoder model. Okay, so we will be calling the model with the name encoder model, and we are returning this encoder model. Similarly, we are extracting the decoder model by providing the decoder word embedding. Okay, then we are just extracting the decoder input, decoder embedding, decoder batch normalized. Okay, and at the end we are extracting the decoder model. Okay, so now let's execute this function. So now we have extracted this. Okay, now we will be creating a sequence to sequence interface. Okay, so what this will do, this will get the input from a user. Okay, and this will give a output that is in French. So it will take a input in English and it will generate a output in French. Okay, so now let's see, here we are using all the encoder pre-processed, decoder pre-processed things. Okay, and we are initializing a init function. Okay, that will get all those values. Okay, maximum length of the French word, maximum length of the English term. Okay, and things like that, everything. Then model, we are loading this sequence to sequence model here. Then we will be creating a function to generate French. Okay, so what it is passing, it is passing self, it is passing the raw input text, that is nothing but the English term. Okay, the English text, for example, hi, hello, how are you, this kind of a text. Okay, then it will be passing a maximum length of French. For default it is none. We will be getting this with the help of this default max length French. Okay, so now if the max length French is none, keep the max length as self dot default max length French. Okay, and if you provide while calling this function, if you provide any number, let's say 10, 20, 30, that will be the maximum length of French keywords. Okay, now we are loading the raw tokenizer. Okay, for English we are using this pp English dot translate. We are providing this raw input text. So the moment we provide the raw input text into a list, or in the form of list, it will translate and give a tokenized vector for that. Similarly, this raw tokenized input will go to the model, okay, the encoder model, and it will predict the encoding body for that. Okay, this body will we are storing it as a original body encoding. Okay, then we are just doing a set state value. Here what we are doing, we are using this French tokenizer, okay, to token ID to start. Okay, and then we are reshaping it to 1x1 vector. Okay, then decoded sentence stop condition, for now it's a stop false. Okay, while not stop condition, till we do not get a condition for which our stop condition will be true, it will iterate. Okay, then it will predict and state. Okay, then self dot decoder model, then predict. Okay, we will pass this state value as well as this body encoding or original body encoding. We are passing it and it is predicting it. Okay, then that prediction will be, we are getting the maximum prediction value, since we are using softmax. Okay, while creating the encoder and decoder model, so it will generate each words, it will not generate the text, rather than instead of generating the tokens, it will generate the probability for the token. Okay, and that probability we are getting here the maximum probability. Okay, so with the help of np.argmax, we are getting that token whose frequency is highest. Okay, and that token, that id will we will be passing to id.token. Okay, and that will give us the predicted word for that. Okay, and until or unless if we get that predicted stop word as end, okay, or we reach to the decoded sentence is greater than or equal to the maximum French word, we will change the stop condition to true and break it. Okay, the moment it breaks, it will go and it will break the loop. Okay, and then it will not execute these states, and at the end we will be getting original body encoding join decoded sentence. Okay, so this way we are generating the French. Okay, so now next we are creating a function that is known as print example. So here we will be passing the English text and the French text, and we will be seeing that what is the predicted output French text for that. Okay, so that we can understand that whether our model is performing good or not, or how it is performing. So now let's execute it. So we have created a class for that. Now we will create the object sequence to sequence INF. Create it. Okay. Now we will be using this this demo model prediction. Okay. Here we are passing the DF. So that DF is nothing but our test data. So now let's see our test data is. So our test data is this. This has 10,000 some values. Okay, so we are not passing the entire 10,843 values. Instead of that, we are passing the 50 data. Okay, and df is equals to test data. So now execute it. So let's see, it takes a couple of time. So now here is our English text. Okay, I'll be the 17th next year. Then the original text is this. For this, we can see that this is the text for that. Okay, and we can see that our model has predicted this start and end. Okay, so we can see that our model has not performed well for the first case. Now coming back to the second case, we can say what a beautiful town. Okay, so now we can see that our model has performed well. So we are getting a good result here. I don't smoke, so it is also again giving us a correct result. Then if we see this example, our model is not performing well. Now if we see this example, our model is performing up to some extent, it is performing well. For the last keyword, it is they are different. Okay, it is giving us the same result. Okay, so if we see the results, we will see that for some of the data the model has performed well, but for some of the data it is not performing well. Okay, so this is not the best model, but yeah, we can tune this model, or we can add and remove the tokens whose frequency is, let's say, 1. So with the frequency of 1, we know that the word has occurred only once in the entire corpus. So we can remove those tokens, and then we can retrain the model, and that model will outperform this existing model. And then we can do some of the architectural changes, and let's say we can use attention into that, we can use beam search into that. So we can do various kind of a thing in this model and get a good result for that. But for this use case, our intention was to just build a sequence to sequence basic model and try and see how the results are coming for a machine translation model. Okay.
What is customer engagement? I don't know, in HR, if you're either in a HR job or if you have come across, some of the HR activities, they talk of something called employee engagement, right? So what do we mean by the term engaged? It is that you're emotionally connected. If it's employee engagement, then the employee is emotionally connected with the job. Similarly, if it's customer engagement, then the customer is emotionally connected to the brand, right? Now, why is this important? Now, when we are emotionally connected with something, we don't let it go that easily, right? That's the reason why we stick on to friends, stick on to our spouses, relatives, and so on, because the aspect of engagement comes in here, right? So customer engagement similarly is very important to retain customers. It is about having an emotional connection between a customer and a brand. Now, there are several other definitions. I'm just going to go through two more just to give you a bit more of a dimension of customer engagement. So, it is the extent to which a customer makes brand focused interactions, like how engaged are you with the brand, how attached are you with the brand. And it also measures how much the customer interacts with the brand in various stages of his or her life cycle, right? So, this is what is customer engagement. And why is it so important today of all the times? As all of you know, there is a lot of impact on several businesses, right, due to the pandemic and the lockdown. And there is also uncertainty, and the economy is very volatile. It is critical to stay connected, right? So, when this being the state, you have to be connected with your customers in order to retain them. And to do that, you cannot follow one strategy fits all. You might have to have a human centric, relevant and targeted strategy, right? So this is where we are going to see how your NLP and social media analytics will add value. Now, what does this bring to the business? Obviously, as we said, it's going to increase your customer retention and reduce your churn, which means that when I have more customers, more engaged customers, it's going to increase audience because it's going to spread by word of mouth. You're going to acquire more customers. Then we'll widen the scope for cross sell and upsell. Now, when the customer has trust on your brand, then there are more opportunities for you to sell more of your different products in your same brand and increase your revenue. And again, the revenue realization is faster, right? People, they look at something, they trust you, so they don't do more of research, they don't go to competition, they quickly buy your product. There is increased brand loyalty, and you can also look at, we will do this as part of the use case where there is a net promoter score. And finally, with NLP and social media analytics, your customer service becomes much more effective and efficient. Now, let me show you some stats to confirm how important is customer engagement. Right? There are various research findings available. The first one says that up to 2/3 of a brand's profit might rely on effective customer engagement. This is done by Hall and Partners. And a fully engaged customer generates 24% more revenue than the average customer. This is research done by Gallup. And research done by Bain and Company states that 5% in increase in customer retention will increase your profits by 25%. Why? Basically because you don't lose customers. So the cost of losing customers you save, and usually acquiring customers is very expensive, right? So you make a saving there. So you can see that how crucial customer engagement is. Okay. So now coming to the role of social media, right? We've seen how important customer engagement is. Now, why are we talking about social media here? Now, with social distancing and the absence or very minimal brick and mortar store available, a lot of your business interactions are moving online, right? I even order my daily vegetables and grocery, through Dunzo or Swiggy. So the touch points, physical touch points between the customer and the business is coming down. A lot of these touch points are moving to online and social media, right? Which means you have a lot of content available in social media. Customer reviews are available, customer scores are available, social media posts are available, which means there is so much of information out there which we can use effectively to understand what the customer wants and then deliver whatever is required. Now, coming to the customer engagement lifecycle, what is the first step? Of course, we have to acquire customers, right? So to acquire customers, we have to identify who's our relevant and profitable customer. Then we've acquired our customer. The customer has started doing business with us, right? The next step is how do we get him or her to do more business, where we are talking about revenue growth. Now, when will I buy more of a brand, or when will I make use of a service? When it is relevant to me, right? So if I'm able to have targeted promotion and selling, then I will increase my revenue. Okay. So I start making a purchase with a brand and I have to feel good about it, right? So that's where comes your customer experience. So when I feel good about a brand, then my perception about the brand is good and the brand is able to deliver a good customer experience. Then comes customer loyalty, where that brand is there with me, right? I'm emotionally connected to the brand, and then I also start promoting the brand. Like I talk to people about it. I say that, this is a good brand. You might probably want to try it out. I've had very good experiences and things like that. Now, this is how the whole customer engagement life cycle works. Coming to our business use case, this is our use case, and we are going to see how to, build the customer engagement in this business use case. Now, there is a fitness brand which is trying to sustain its business amidst challenging times. Now, you know that gyms are closed, right? There's a lot of revenue, so a lot of gyms are trying out their online workout sessions. And then they might have been selling merchandise. Now all that is lost out. So we have a fitness brand which is trying to sustain its business amidst challenging times. As a first step, the brand wants to enhance customer engagement. Why would they want to enhance customer engagement? It's because now when things get back to normal, right, you will slowly want to increase your footfalls. And if things do not get back to normal, you have to find other ways of sustaining the business, right? So either way, you will have to enhance your customer engagement. So the good news for the brand is that the brand has a huge online presence, which means they have apps, they have a good website. So a lot of reviews are available, a lot of customer data is available. And they also have well-maintained social media accounts like Twitter, Instagram, Facebook. And they have a huge amount of social media data, which is mainly text. So this is the scenario. Now we have a fitness brand. Now the brand is trying to enhance customer engagement. They have a lot of social media data. Now what is the task that we need to do? We are going to formulate a customer engagement strategy step by step now in the next 30 to 40 minutes using NLP and social media analytics for this customer. Now, before we jump into the actual use case, for people who are not aware about NLP, I would like to give a quick introduction about what NLP is and why is it important, right? So NLP is the abbreviation for natural language processing. And NLP is a combination of using human language with a bit of programming and artificial intelligence so that we are able to convert text into a format that can be run through algorithms and used for prediction, right? So we are converting the unstructured text data into structured data and then gaining insights. This entire process is called NLP. Now, you might have a question, right? Now, there might be a lot of customer data available in terms of numbers, okay? Probably their purchase data, probably rows and columns of a lot of numbers. Now, why should I use text and, complicate the whole thing? This question might come up to a lot of people, especially people who are new to NLP. I'll tell you why. Only 20% of your data is structured, right? The so-called transactional data, the customer invoices, or data where you have numbers laid out in beautiful rows and columns as an Excel table, is only 20% of the data available. All the other data is unstructured data, which is text, images, audio, video, and whatnot. So, which means, especially if you want to look at what the customer feels about, what are they talking about, then we have to rely heavily on text data, and that's where NLP comes to play. Okay, let's quickly look at some of the applications of NLP in real life. Okay, you might have heard a lot about this sentiment analysis. This is a very interesting application of NLP. We will be doing sentiment analysis, in some time. Now, sentiment analysis is basically to understand the perception, of somebody based on the text, right? If I'm angry, I use certain words. If I'm happy, I use certain words. If I'm, sad, I use certain words. Now, based on the word usage, you can use sentiment analysis to extract the sentiment from a corpus of text. Now, this is used extensively to find out what customers like and what they don't like. This is also used for any hate speech detection. The next one is a chatbot. Now, any website that you go, you see a chatbot which pops up. So this is very effective for customer service because I don't have to, this can be switched on 24/7. This is based on conversational AI. So I don't need to man my website 24/7. I am able to immediately answer a customer's query with a properly trained conversational AI engine, and I'm able to give timely service to my customer. Then we have speech recognition. The common example of speech recognition are our Siris and Alexa, right? And our Google Assistant. We have machine translation, which is another important application of NLP, which is used in your Google Translator for language translation. Keyword search, right? Now, as we said, there is huge amount of data available, text data available, right? Who has the time to, read through all this, sift through all this, and then extract what is more important? So here you have very important applications of NLP, keyword search, which we will be again using in a while, for us to extract information from websites, right? What are the top 5 keywords that they are discussing in this news item? Okay. And what are the, if I look at some research, say research on COVID-19, right? There are hundreds of publications. Then what are the top keywords I'll take, I'll be able to extract? And then what are these topics? It could be hydroxychloroquine, it could be, something else. So these are certain very simple but very powerful applications of NLP. Finally, we have pattern matching. Now, I keep posting stuff on fitness, right? I say I have done this workout. Now I say that, I've been on a paleo diet, whatever. Then immediately after some time, you will see that you have ads on your Facebook feed related to fitness products, right? So it takes basically text from what you post and then or searches that you made on Google, and then advertisements are matched accordingly. This is also used extensively for profile matching in sites like Naukri, right? Now there is a job profile given by Naukri. So say for a particular role. Now you have posted your CV and then there are certain, skills that you have posted. Now, who has the time to read CV by CV and then, look at what is important? So what basically happens there is a pattern matching algorithm which looks for similar words and then ranks your CVs based on similarity. And then probably somebody will pick up the top 10 or 20 CVs and take it forward. So if you look at all of this, basically text mining and NLP is about decluttering, whatever is there and then extracting the information. Now we've seen the customer engagement lifecycle. Now we've seen what NLP is. Now in our use case, we will try to plug in these techniques in each stage of our lifecycle. Okay. So the first one is customer acquisition, right? Now, what are we going to use NLP here for? We will use social media analytics and NLP to identify potential customers, right? There are millions of people out there. Now, if I have to run a campaign, I cannot run it to everybody. I would like to select potential people who might be interested, and I might want to run the campaign with them. Okay. The other thing is, I might also want to look at, as I said, what people post. Okay. Now, I might be a fitness buff, but I might be interested more in running, right? I might want to go for a marathon. Somebody else might want to do cycling. And there are a few people who want to do a workout, right? So I want to understand, even in terms of fitness, what are customer interests and preferences. Now, once I've acquired the customer, as you know, the next stage is revenue growth. So in revenue growth, now we will look at what exactly customers are talking about and target the promotions based on that. Not only that, you need to know where to post, right? Where to place your promotion, and then where to advertise your products. That's very important. Now, if you're looking at YouTube, you're constantly searching for analytics videos, then you will see similar ads coming in your feed, right? That's basically because it picks up from the keywords and then throws relevant ads. Now, if you're somebody who are looking at a lot of data science related videos, you might even want to do a course. You might click on one and then convert into a customer, right? So there are two things we will do in revenue growth. So we will extract text and then we will target promotions by using the most effective channel, right? And for customer experience, we first need to understand something called voice of customer. Now, people who've been in Six Sigma, who've been in customer service have heard about this term VOC, which is voice of customer. Now, with all the reviews that we, do in Swiggy and, our Mintras and Amazon and all that, there is huge amount of data available as customer reviews, right? And when do I post a review? Usually when I'm extremely happy or when I'm extremely frustrated. So we are going to look at reviews for both these extremes and see how these are able to enhance your customer experience. And the other thing, of course, for customer experience is your chatbots and AI. Now, finally, customer loyalty. When it comes to customer loyalty or even employee loyalty for that matter, there is a term called NPS score, which is nothing but the net promoter score, right? So it talks about whether you will promote a brand, whether you will not promote or you hate a brand, which is called detractors. And the other thing is whether you will be neutral, right? So there is an NPS score. We are going to use sentiment analysis to derive NPS scores, and we will see how these can be used for agile customer support, right? Now, this is how we are going to embed our NLP and social media techniques in our customer engagement journey. So this is how our life cycle starts, right? Now, the first stage is to identify potential customers. Now, how are we going to do this? Now, I am going to choose relevant social media accounts, right? Social media accounts. So, for example, if I am somebody who is interested in fitness, I will be already either following a fitness brand or maybe a fitness influencer, or I will post something on fitness, right? That's how we are going to find relevant social media accounts. And then we are going to extract user information about these people, and then maybe, use that, reach out to those accounts and then position our ads. Now we've seen the customer engagement life cycle. Now we've seen what NLP is. Now in our use case, we will try to plug in these techniques in each stage of our life cycle. Okay. So the first one is customer acquisition, right? Now, what are we going to use NLP here for? We will use social media analytics and NLP to identify potential customers, right? There are millions of people out there. Now, if I have to run a campaign, I cannot run it to everybody. I would like to select potential people who might be interested, and I might want to run the campaign with them. Okay. The other thing is, I might also want to look at, as I said, what people post. Okay. Now I might be a fitness buff, but I might be interested more in running, right? I might want to go for a marathon. Somebody else might want to do cycling. And there are a few people who want to do a workout, right? So I want to understand, even in terms of fitness, what are customer interests and preferences. Now, once I've acquired the customer, as you know, the next stage is revenue growth. So in revenue growth, now we will look at what exactly customers are talking about and target the promotions based on that. Not only that, you need to know where to post, right? Where to place your promotion, and then where to advertise your products. That's very important. Now, if you're looking at YouTube, you're constantly searching for analytics videos, then you will see similar ads coming in your feed, right? That's basically because it picks up from the keywords and then throws relevant ads. Now, if you're somebody who are looking at a lot of data science related videos, you might even want to do a course. You might click on one and then convert into a customer, right? So there are two things we will do in revenue growth. So we will extract text and then we will target promotions by using the most effective channel, right? And for customer experience, we first need to understand something called voice of customer. Now, people who've been in Six Sigma, who've been in customer service have heard about this term VOC, which is voice of customer. Now, with all the reviews that we, do in Swiggy and, our Mintras and Amazon and all that, there is huge amount of data available as customer reviews, right? And when do I post a review? Usually when I'm extremely happy or when I'm extremely frustrated. So we are going to look at reviews for both these extremes and see how these are able to enhance your customer experience. And the other thing, of course, for customer experience is your chatbots and AI. Now, finally, customer loyalty. When it comes to customer loyalty or even employee loyalty for that matter, there is a term called NPS score, which is nothing but the net promoter score, right? So it talks about whether you will promote a brand, whether you will not promote or you hate a brand, which is called detractors. And the other thing is whether you will be neutral, right? So there is an NPS score. We are going to use sentiment analysis to derive NPS scores, and we will see how these can be used for agile customer support, right? Now, this is how we are going to embed our NLP and social media techniques in our customer engagement journey. Topic modeling, we are going to see topic modeling, Murli Krishna. So one of our examples has topic modeling. We'll be also creating data pipelines. We are only talking about text extraction. So data pipelines, I'll take it later offline after the main session is over. We will look at click-through rate as well on how it can be used to improve click-through rate. HR analysis, as I said, it can be used for employee engagement. And the other use case, as I said, is, the NPS scores. You can look at comments from employees and convert it to exit interview scores. And then you can extract keywords to look at why people are leaving. You can also use it, as I said, for pattern matching and then, selecting from CVs. Now, if you have advertised for a role and then you have thousands of applications, you can use NLP to pick the most relevant CVs. So this is how our life cycle starts, right? Now, the first stage is to identify potential customers. Now, how are we going to do this? Now, I'm going to choose relevant social media accounts, right? Social media accounts. So for example, if I'm somebody who is interested in fitness, I will be already either following a fitness brand or maybe a fitness influencer, or I will post something on fitness, right? That's how we are going to find relevant social media accounts. And then we are going to extract user information about these people, and then maybe, use that, reach out to those accounts and then position our ads. Now, this is the first use case that we are going to see. Now I've done this in R. So I have extracted data from Twitter. The reason why I use Twitter is and even for you to try out, Twitter has a very, especially with R, it has an open API. So with just a two-step process, you will be able to connect to the Twitter API and you'll be able to extract tweets with this library called RTweet. Okay. So this is the first use case we are going to take a look at. So what am I doing first? I initiate the libraries. As I mentioned earlier, all of these code, all of the data sets will be provided to you at the end of the session. Okay. So I'm going to extract followers. I'm just showing you some examples here, right? Now, like this, there might be several fitness brands, there might be several fitness influencers. Now, when you actually do it in real life, you will collate all of that information to create your customer database. I'm just showing you an example of how and where to start. I mean, this is not exhaustive, right? I want you to keep that in mind. So I'm using this get followers for me to extract followers for a particular brand, say CureFit. I chose CureFit because they have a lot of online presence. They have a good Twitter account. They have their app. So a lot of text data is available. I am also getting followers of Rujita Devakar. I don't know, people who have followed her know she's very famous for her, diet recommendations. And she is, the fitness coach for a lot of celebrities. So now I have follower information from Twitter. I mean, the same thing can be replicated to any social media. As I said, the reason I use Twitter is because, Twitter has, an easy interface to an API to extract tweets. Okay. So after I extract, then I can use the lookup user function in RTweet, where I get a lot of information about these users. So let me probably, okay. So I get their screen name, I get their latest tweet, what is their source, okay. And a lot of information is available from this lookup users. So once I have this, then I'm able to extract their screen names. Now I've just got it for 6 people. Now imagine each one of these, right? Each one of these has 5,000 followers at least. And then if I do it for, several brands, imagine the number of relevant user accounts I will have access to, right? So this is the first one. So what have I done here? I've selected followers of a fitness brand and a fitness influencer. And then for these followers, I collect more information about them in terms of their social media accounts so that I can target my promotions towards this. Okay, so now we have a list of relevant customers. Say that, you have to pitch to these customers and then you will have to start getting business from these customers, right? Now, how are we going to do that? We need to make targeted promotions based on customer interests. Okay. I answered 2 questions here. Where to promote, which is what is the most effective channel, and what to promote, right? I am going to have, see, how long are people going to look at an ad? Maximum 5 seconds. So in that 5 seconds, I have to give them a very powerful message which is acceptable, right? Or which people like. So, which is when my brand gets promoted, okay? So with this, in this part, we are going to answer 2 questions with NLP and social media. The first one is where to promote, and the second one is what to promote, okay? We'll go back to R, right? Now, if I have to promote about fitness, where do I have to promote? I have to look at fitness magazines or sites which are for fitness, or probably, I can use fitness influencers. I can pay them some kind of royalty and promote on their account. Now, so these are typical sites that I will select, right? If I want to promote on fitness. So now I have taken 4 popular fitness magazines on Twitter. These are more, you know, in the international context, but you can, I mean, I just took this to show you an example, but you can of course take relevant ones, you know, for your business. So these are the 4 Twitter handles for, you know, 4 fitness magazines. Now, like earlier, I am extracting the user information, right? Now, what am I looking for in the user information is again the followers count. Now, imagine what, now there are people who talk about in Instagram, right? Saying I have 1 million followers, I have 2 million followers. Why is it important to have followers, right? When there are more number of followers, then a lot of people look at what you post, right? So you have increased visibility, and then there are greater chances of conversion. So I would want to, out of these 4, choose that Twitter site which has the maximum number of followers. So for each of these sites, I am extracting the follower count, right? So this is what I have. Now the first one has 10,000, 63,000, 37. Obviously this is the winner, right? Shape magazine has about 600,000 followers. And if I'm somebody who wants to promote, obviously I will use this because with a single ad, I will be able to reach 600,000 people, right? So this answers the question of where to promote. Now, as I said, this is an ocean, okay? I am only giving you leads of where you can start. You might, I did it for 4, you might be doing it for 20 or even 30 different sites together to identify the best one, okay? Now coming to the next one on what to promote. Now this answers where to promote. So for our use case, I know that we have to promote in Shape magazine. Now what to promote, as I said, is the promotional data that we are using. Okay, so for this, again, I have extracted tweets, right? And in Twitter, there is something called retweeting, right? In Facebook, you share something, right? If somebody has posted something, you like it, you share it, right? You reshare the same content. So retweeting or sharing content is called amplification in social media language, okay? Now I tweet something and then 100 people retweet it. It means that they like it, so they are tweeting it again. So whatever message I say is amplified 100 times, okay? So I am going to look for the tweet text and how many times it is retweeted, right? Now, if something is retweeted 100 times, then I know that message goes well with people who like fitness. So let's look at this count. Okay, so yeah, I have my tweets, and then for each of it, I have the retweet count. What I will do is, now I will sort this in descending order, okay? I sort this in descending order. So I have the top 10 tweets that were retweeted. Okay, let's take a look at these. Now these are the top 10 tweets. This is a bit small, so let me go here. Okay, so if you look at this, these are very catchy, right? Add a quick to your workouts, and then work out like a world champion would. So these are all catchy messages which people seem to like a lot, okay? So add a kick to your workouts is something which syncs with a lot of people who like fitness. So you will do your research around what are the themes which people like. So this is something which goes well with people, okay? I just heard I have a chance to work out with Superman. So when you post something like this, then a lot of people's attention is, diverted to this ad. So you will take a look at all of this, and then you will wrap your branding message in this direction. Okay. So now this brings us to the second part of our customer engagement lifecycle. Basically NLP is more about, there is a lot of pre-processing required. Then there are certain concepts required in terms of NLP. All that you will be covering as part of NLP plus Python. Yes, you just need working knowledge of Python or R. Yes, fake news is a combination of NLP and unsupervised learning algorithms. You can use NLP to, detect fake news. So to quickly sum up, first we looked at acquiring customers. So we looked at, followers of CureFit and Rujita Devakar. So these are our audience, potential audience. Then we looked at, okay, we have these people, how do I increase my business? Okay. So I have extracted data from Twitter. The reason why I use Twitter is and even for you to try out, Twitter has a very, especially with R, it has an open API. So with just a two-step process, you will be able to connect to the Twitter API and you'll be able to extract tweets with this library called RTweet. Okay. So this is the first use case we are going to take a look at. So what am I doing first? I initiate the libraries. So I'm going to extract followers. I'm just showing you some examples here, right? Now, like this, there might be several fitness brands, there might be several fitness influencers. Now, when you actually do it in real life, you will collate all of that information to create your customer database. I'm just showing you an example of how and where to start. I mean, this is not exhaustive, right? I want you to keep that in mind. So I'm using this get followers for me to extract followers for a particular brand, say CureFit. I chose CureFit because they have a lot of online presence. They have a good Twitter account. They have their app. So a lot of text data is available. I am also getting followers of Rujita Devakar. I don't know, people who have followed her know she's very famous for her, diet recommendations. And she is, the fitness coach for a lot of celebrities. So now I have follower information from Twitter. I mean, the same thing can be replicated to any social media. As I said, the reason I use Twitter is because, Twitter has an easy interface to an API to extract tweets. Okay. So after I extract, then I can use the lookup user function in RTweet, where I get a lot of information about these users. So let me probably, okay. So I get their screen name, I get their latest tweet, what is their source, okay. And a lot of information is available from this lookup users. So once I have this, then I'm able to extract their screen names. Now I've just got it for 6 people. Now imagine each one of these, right? Each one of these has 5,000 followers at least. And then if I do it for, several brands, imagine the number of relevant user accounts I will have access to, right? So this is the first one. So what have I done here? I've selected followers of a fitness brand and a fitness influencer. And then for these followers, I collect more information about them in terms of their social media accounts so that I can target my promotions towards this. Okay, so now we have a list of relevant customers. Say that, you have to pitch to these customers and then you will have to start getting business from these customers, right? Now, how are we going to do that? We need to make targeted promotions based on customer interests. Okay. I answered 2 questions here. Where to promote, which is what is the most effective channel, and what to promote, right? I am going to have, see, how long are people going to look at an ad? Maximum 5 seconds. So in that 5 seconds, I have to give them a very powerful message which is acceptable, right? Or which people like. So which is when my brand gets promoted. Okay. So with this, in this part, we are going to answer 2 questions with NLP and social media. The first one is where to promote, and the second one is what to promote. Okay. We'll go back to R. Now, if I have to promote about fitness, where do I have to promote? I have to look at fitness magazines or sites which are for fitness, or probably, I can use fitness influencers. I can pay them some kind of royalty and promote on their account. Now, so these are typical sites that I will select, right? If I want to promote on fitness. So now I have taken 4 popular fitness magazines on Twitter. These are more, in the international context, but you can, I just took this to show you an example, but you can, of course, take relevant ones, for your business. So these are the 4 Twitter handles for, 4 fitness magazines. Now, like earlier, I am extracting the user information, right? Now, what am I looking for in the user information is again the followers count. Now, imagine now there are people who talk about in Instagram, right? Saying I have 1 million followers, I have 2 million followers. Why is it important to have followers, right? When there are more number of followers, then a lot of people look at what you post, right? So you have increased visibility, and then there are greater chances of conversion. So I would want to, out of these 4, choose that Twitter site which has the maximum number of followers. So for each of these sites, I am extracting the follower count, right? So this is what I have. Now, the first one has 10,000, 63,000, 37. Obviously, this is the winner, right? Shape magazine has about 600,000 followers. And if I'm somebody who wants to promote, obviously, I will use this because with a single ad, I will be able to reach 600,000 people, right? So this answers the question of where to promote. Now, as I said, this is an ocean, okay? I am only giving you leads of where you can start. I did it for 4, you might be doing it for 20 or even 30 different sites together to identify the best one, okay? Now, coming to the next one on what to promote. Now, this answers where to promote. So for our use case, I know that we have to promote in Shape magazine. Now, what to promote, as I said, is the promotional data that we are using. Okay, so for this, again, I have extracted tweets, right? And in Twitter, there is something called retweeting, right? In Facebook, you share something, right? If somebody has posted something, you like it, you share it, right? You reshare the same content. So retweeting or sharing content is called amplification in social media language, okay? Now, I tweet something and then 100 people retweet it. It means that they like it, so they are tweeting it again. So whatever message I say is amplified 100 times, okay? So I am going to look for the tweet text and how many times it is retweeted, right? Now, if something is retweeted 100 times, then I know that message goes well with people who like fitness. So let's look at this count. Okay, so yeah, I have my tweets, and then for each of it, I have the retweet count. What I will do is, now I will sort this in descending order, okay? I sort this in descending order. So I have the top 10 tweets that were retweeted. Okay, let's take a look at these. Now, these are the top 10 tweets. This is a bit small, so let me go here. Okay, so if you look at this, these are very catchy, right? Add a quick to your workouts, and then work out like a world champion would. So these are all catchy messages which people seem to like a lot. Okay, so add a kick to your workouts is something which syncs with a lot of people who like fitness. So you will do your research around what are the themes which people like. So this is something which goes well with people. Okay, I just heard I have a chance to work out with Superman. So when you post something like this, then a lot of people's attention is diverted to this ad. So you will take a look at all of this, and then you will wrap your branding message in this direction. Okay. So to quickly sum up, first we looked at acquiring customers. So we looked at, followers of Cure Fit and Rojita Devakar. So these are our audience, potential audience. Then we looked at, okay, we have these people. How do I increase my business? Okay. The third step, as I said, is to look at customer experience. The first stage is understand voice of customer. Now there are usually tweets that I make, right, on a particular brand, or I provide reviews, right, on Amazon or Flipkart or on Myntra. I provide some reviews. So I can use all of this, but there are millions of posts like this, right? I just want to declutter all of this, cut out the redundant information, and only extract the most important information, right? So we will do that using keywords. And then we will also use topic modeling to understand what are the topics generally discussed about this brand, right? That will also, suppose I'm looking at 1,200 tweets, right? I do not have time to read all of them, but I can look at what are the top 5 topics discussed across these 1,000 or 2,000 tweets to very quickly get an idea of the customer perception, right? Let me do this in Python, because some of the NLP tasks are, Python is much more powerful. Later, if you want to, do some text classification, some sequential models, then Python is handy. So I'm now going to shift gears to Python. Okay, so I have my tweets, right? I have about 1,700 tweets, right? I've taken a very small subset of tweets. You probably might have millions of tweets, because I just wanted to, quickly run this and show it to you as a demo. I've taken a very small subset. So now we are going to extract keywords, right? So Python has a lot of very powerful NLP libraries. One is NLTK, then you have Sparsy. So for this, we are going to use NLTK. I'm importing the library, and then I am extracting the tweet text, right? So the tweet data that you extract not only has text, but it has about 89 to 90 columns of metadata around the tweet, including screen name, from where the tweet is, how many followers, how many times this is retweeted, right? And several other information. So for us here, our interest is the actual tweet text itself, right? So I'm extracting this. And then, as I said, now this Twitter text or social media text especially has a lot of noise, right? What do I mean in terms of noise? It could probably have emoticons, it can have web URLs, it can have slangs, right? And then it can have punctuations, other special characters. Now, if I want to extract whatever is important, I have to get rid of all this redundant information. So it is like sieving, right? If you're trying to sieve something, then you do that, and then you let out all the smaller particles through the sieve, and then retain only the bigger particles, right? So similarly, I only want my most important keywords, so I am going to do some text pre-processing. Okay, so one part of text pre-processing is called removing stop words. Now there are general stop words, for example, and is, because this is used all along, right? This cannot be an important keyword. And then there could be some context specific stop words. Now if I'm exporting tweets on CureFit, definitely you will have this word CureFit coming again and again. So I don't want to look at these words, right? So I'm going to filter out certain stop words or redundant words, right? And then this is a very small function or a for loop that I've written here for us to pre-process text. Now, fundamentally, what does this do? It removes punctuation, converts to lowercase, right? And then lematizes or normalizes your text and gives you a clean corpus. Okay, so it's removed all the redundant information, and it does this for all the 1,700 tweets. Okay, now after this, I create a vocabulary of words. What is a vocabulary of words? Now across the 1,700 tweets, what are the unique important words? Okay, so for this there are two techniques that you can use. count vectorizer and TF-IDF vectorizer. So this is more to do with how these words are extracted. Okay. So I do this to get my top 10 words. Okay. So tweets on CureFit have these. I can take top 10, top 20, how much ever. I've taken top 10. So what is this talking about? It's talking about keep going. So which means, right, keep doing your fitness, stay safe. This is more related to your lockdown. So stay indoors. Now all of these gyms are coming with indoor workout. So it talks about indoor workout. And then, live from home. So you have live, like our YouTube live, CureFit or CultFit has their live sessions. Getting better every day, be better every day is again CureFit's, one of their taglines. So you can see how beautifully, from the 1700 tweets, you are able to start extracting the top keywords, right? I can also visualize this using a word cloud, if you want to make it jazzy. And as I said, TF-IDF is yet another way of extracting keywords. So let's take a look at this, right? So this is talking about adding pause days. So in CureFit, if you use the app, now if you if you have a 3-month membership, you can pause a few days if you cannot go to the gym, right? So when it comes to lockdown, what a lot of customers are asking about is about your pause day. Okay, see, so that customers are concerned about this, right? So I'm not able to go to the gym, right? Will you be able to pause my membership? So several terms related to pause day have come out. So again, a very, very effective way of extracting what exactly customers are looking for from your keywords, right? Then the next one is, we'll go to topic modeling. So same text pre-processing can be done. And like how I extracted just keywords, I can also extract topics, right? What are the most relevant topics? So these are some of the topics, right? So the first thing is, it's about be better every day, your dance fitness. The second topic is about startups, right? There are some tweets on startups like Swiggy, Zomato, CureFit, Ola, and all that. And then Ankit Nagori, I guess, is one of the founders of CureFit. So this is about him. And then this is about the HRX brand, right? So you can see how topics also emerge from the tweet. Now, as I said, I've only taken 1700 tweets. Now, if you do topic modeling on more, like say 20,000, 30,000 tweets, this will be very, very effective. So with just a few steps, we are able to not just extract keywords, but also topics then based on, the tweets using NLP. Now, there is another aspect of customer perception, which is your sentiment analysis. So now we looked at, topics, keywords. I am going to show you a very beautiful library in R called Suzette, which is used for sentiment analysis. So I'm basically taking, tweets, the same tweets on CureFit, okay, and I'm going to perform sentiment analysis to understand the overall perception of the customer about the brand, right? How do customers feel? Do they have a positive sentiment? Do they have a negative sentiment? That's the first step, right? Overall, what is it out there? Do customers like my brand? That's what we'll take a look now. Suzette is beautiful because it not just gives you the positive or negative sentiment, which we will take a look at in a minute, but it also gives you an emotional score. Okay. So when I talk about an emotional score for CureFit based on the 1700 tweets we know that the most dominant sentiments are trust, joy, and anticipation, positive and negative. Definitely the positive sentiments are high compared to your negative sentiments, right? But is this enough for us to retain customers? Although there are only very little negative sentiments, these are people who could probably destroy your brand, right? So it is very important to find out who these people are and what is that they are unhappy with, right? That's the next step. Okay, overall I am happy. The brand perception, there are a lot of positive sentiments around the brand. You have trust, joy, anticipation, which is good, but I also have anger, disgust. So I want to find out what's really wrong with these people. So I might want to call them and address this, right? If you've heard of NPS scores, the process of coming up with NPS scores is, where you have to send out a survey. You will ask people, I don't know if you've done a survey which says on a scale of 1 to 10, how is it likely that you will recommend this brand, right? So running such a survey is very expensive and you may not get enough data. But sentiment analysis can be converted to an NPS score, right? That's the last application we will see. And with that, we will be able to wrap up our use case and give a very beautiful strategy to this fitness brand. So here, what I've basically done is I've used the same tweets on CureFit, and I use the Vader library where I get a positive, negative, and a composite score for each of my tweets. Okay. So for every tweet, I can get whether that has a positive score or I have a negative score, right? Once I have this information, what I would probably do is I will then look at what are the kind of tweets where people are happy. Okay. So let us look at some of the positive tweets. Okay, so these are some of the positive tweets where they're talking about a particular trainer. They say she's amazing, what amount of energy she has. Thanks for the great session. So these are all positive tweets. This is where people are happy, right? Now, what is more important? We want to look at people where they have given a negative tweet. Now, what are they unhappy about? This person is unhappy about being spammed with SMSs. So probably, you might want to look at how you are sending out your messages out to people. And then see, CureFit is an app-based fitness, right? So it doesn't have a phone number. Certain people find it very difficult to kind of appreciate this. So this is what this person is very unhappy about, right? There is no response to any of our emails. So this can be a very important customer, right? You might directly want to contact this customer to find out what is wrong. Now imagine if you do not have a mechanism like the sentiment analysis we did now. This tweet is lost in the millions of tweets, right? But if I do a simple dashboard where I am able to flag the most negative comments, I will be able to quickly reach out to these customers and then find out what has gone wrong and then, try to set it right. So this is what I call as agile customer service. This is one. The other thing is based on the score. So if you look at this, you have the scores here, right? Now, based on the scores, I can bucket customers as promoters, detractors, and neutrals, right? So now for every customer, now in this data, I have 433 promoters, but I also have 272 detractors. These are people who can ruin my brand, right? So I have to look at why they are unhappy. And then there are neutrals. You would want to push the neutrals into the promoters so that they vouch for your brand. Okay. So for every customer, I will be able to get whether they are a promoter or a detractor or a neutral. With this, we have completed the 4 steps of customer engagement. And then we've seen how to use NLP and social media in each of these areas. So to sum up, how do we enhance customer engagement? Know your customer. So for this, your social media data and NLP is extremely helpful. Extract voice of customer. So we saw keyword extraction, we saw topic modeling, and then we saw sentiment extraction. With that, you can understand how customers perceive your brand. And then you can segment your customers, right? Promoters, you will follow a different strategy, or you can do some kind of clustering and customer segmentation models and then target one specific strategy for each segment. And we saw about proactive customer support, right? I can either use a chatbot, or as I showed you, if you're able to quickly flag negative tweets or negative reviews, you can reach out to that customer before he or she causes damage. And with this, you can provide world-class customer service. Okay. So thanks NPS scores. The process of coming up with NPS scores is, where you have to send out a survey. You will ask people, I don't know if you've done a survey which says on a scale of 1 to 10, how is it likely that you will recommend this brand, right? So running such a survey is very expensive and you may not get enough data. But sentiment analysis can be converted to an NPS score, right? That's the last application we will see. And with that, we will be able to wrap up our use case and give a very beautiful strategy to this fitness brand. Of course, let me go back to Python now. So here, what I've basically done is, I've used the same tweets on CureFit, and I use the Vader library where I get a positive, negative, and a composite score for each of my tweets. Okay. So for every tweet, I can get whether that has a positive score or I have a negative score, right? Once I have this information, what I would probably do is, I will then look at what are the kind of tweets where people are happy. Okay. So let us look at some of the positive tweets. Okay. So these are some of the positive tweets where they're talking about a particular trainer. They say she's amazing, what amount of energy she has. Thanks for the great session. So these are all positive tweets. This is where people are happy, right? Now, what is more important? We want to look at people where they have given a negative tweet. Now, what are they unhappy about? This person is unhappy about being spammed with SMSs. So probably, you might want to look at how you are sending out your messages out to people. And then see, CureFit is an app-based fitness, right? So it doesn't have a phone number. Certain people find it very difficult to kind of appreciate this. So this is what this person is very unhappy about, right? There is no response to any of our emails. So this can be a very important customer, right? You might directly want to contact this customer to find out what is wrong. Now imagine if you do not have a mechanism like the sentiment analysis we did now. This tweet is lost in the millions of tweets, right? But if I do a simple dashboard where I am able to flag the most negative comments, I will be able to quickly reach out to these customers and then find out what has gone wrong and then, try to set it right. So this is what I call as agile customer service. This is one. The other thing is based on the score. So if you look at this, you have the scores here, right? Now, based on the scores, I can bucket customers as promoters, detractors, and neutrals, right? So now for every customer, now in this data, I have 433 promoters, but I also have 272 detractors. These are people who can ruin my brand, right? So I have to look at why they are unhappy. And then there are neutrals. You would want to push the neutrals into the promoters so that they vouch for your brand. Okay. So for every customer, I will be able to get whether they are a promoter or a detractor or a neutral, right? So with this, we have completed the 4 steps of customer engagement. And then we've seen how to use NLP and social media in each of these areas. So to sum up, how do we enhance customer engagement? Know your customer. So for this, your social media data and NLP is extremely helpful. Extract voice of customer. So we saw keyword extraction, we saw topic modeling, and then we saw sentiment extraction. With that, you can understand how customers perceive your brand. And then you can segment your customers, right? Promoters, you will follow a different strategy, or you can do some kind of clustering and customer segmentation models and then target one specific strategy for each segment. And we saw about proactive customer support, right? I can either use a chatbot, or as I showed you, if you're able to quickly flag negative tweets or negative reviews, you can reach out to that customer before he or she causes damage. And with this, you can provide world-class customer service.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.